Hello, what's up everyone? Welcome to this series of videos to learn how to develop iOS apps with Swift and Xcode. So this is going to be a beginner's tutorial. So if you want to learn how to create iOS apps, but you've never done that in the past and you've never used either Swift or Xcode, you are at the right place. It's been quite some time since I wanted to create this series of videos. If you look on my channel, you will see that I have a lot of content about iOS, but I didn't have this particular piece of content to guide beginners with their first steps in the iOS ecosystem. But what happened is that a few weeks ago, as I'm recording this tutorial, Apple released a series of written tutorials that go over all the steps that you need to learn in order to get started with iOS development. So I figured why not do these tutorials live? This way I can go over them with you. I can add additional explanation. If something is weird or hard to understand, I will unstuck you. And basically, if you stick with me, you will do the tutorial and you have the guarantee that you will not be stuck on something that you don't understand. If you want to check the tutorial by yourself, please feel free to do so. You have the link to check it out in the description of the video on YouTube. And by the way, I'm recording this tutorial live, so live on YouTube. So if you're watching live, well, first, thank you for being here, but also don't forget that you have a chat where you can make remarks, ask questions. I will try my best to answer them. And remember also that the questions and the remarks that come to your mind are probably the same than the one that people watching the replay will have. So please voice them. This way, you will also give a voice to people who watch the replay, and I think that's pretty cool. Um, I see a few messages in the chat, but it seems like we have Nice and Elnor. So welcome to the live stream. I see you're talking with each other, so I don't think it's questions addressed to myself. But I'm glad to see that we have people that want to go on this discovery journey, this learning journey. I think I've said more than enough for the intro. It's time to actually get started. So I'm going to go on the tutorial and I'm just going to go over what we're going to learn. If you look at the tutorial, you will see that it's quite comprehensive. Honestly, the team at Apple that made these did a pretty good job. So today we'll cover this we'll cover this part. So about the Swift UI foundation, so getting familiar with the tools and technology we use to create modern iOS apps. So we will explore Xcode, which is the software that you use in order to develop apps for iOS or for macOS or for any Apple platform. Then we'll learn a few more technicalities, so about views, structures, and properties, the basic building blocks, sorry, of a Swift and a Swift UI app. Then we'll learn a bit more about UI, about layout and style. So how do you display a UI that is visually pleasing? How do you handle buttons and states? So how do you handle user interaction? How do you handle lists and text fields? And we will stop here for this tutorial. So actually, this will take us more than one video. I think this will be at least 2 videos, maybe even 3 videos. And then the next part is about Swift data. But this part, I've actually already covered it. So you can find this part being covered on my channel already. We did that the past 2 weeks. And the next part is about spatial computing. So maybe I will do it after in the future. Maybe once I will have been able to get my hands on the Vision Pro. But it's nice to see that we have also this option to learn about how to develop for Vision OS and the Vision Pro. So let's get back to the topic at hand. Before I start, something I forgot to mention is that I'm recording. We are in April 2024, so it might seem stupid if you're watching the live stream because, of course, you know when we are. But if you're watching the video in the future, it's always good to know that the tutorial is from April 2024 and from the days of iOS 17. I'm saying it because if you're watching this and it's 3, 4, 5 years from now, maybe the information I'm going to share is a bit old. So keep that in mind if you are watching a few years in the future. But if you're watching this video a few years in the future, it's pretty cool. It means that the video like managed to stay alive and stay relevant. So that would be pretty cool, to be honest. So let's get started. So chapter 1, we're going to explore Xcode. We'll get to know Xcode and SwiftUI by creating a prototype of a messaging app. We'll learn about syntax for Swift and how to use the source editor and preview. So let's get started. So first, it seems we have some kind of intro for this series of tutorials. So welcome to Develop in Swift tutorials. So these will teach you how to develop apps using Xcode, Swift, and SwiftUI. This content is for anyone. No prior coding experience is required. What are we going to learn? We'll learn how to use Xcode, Apple's advanced tool for developing apps, the basics of Swift, Apple's modern programming language, which is designed to be easy to learn and fun to use, and a foundation in SwiftUI, which helps you build great looking apps with the power of Swift. So, the most modern technologies that you have for now in the Apple ecosystem. I'm also going to make myself a bit smaller because I take a lot of room and I don't want to hide any of the text by mistake because the text is way more important. So each chapter introduces a new concept in Swift, or rather new concepts in Swift and SwiftUI through the experience of building a small project in Xcode. It's what I really like when I did the Swift data part of this tutorial is that it's really like learning by doing, and I think they did a great job at introducing each concept and making you do it, which makes it way easier to understand how it works and to just like get your to wrap your head around how it works. That's the expression the idiom I was looking for. So start with the tutorial where you'll follow step-by-step instructions to create prototypes, app screens, and fully functioning apps. After the tutorial, read a wrap-up article to review what you learned and continue practicing your new skills. So it's really like the structure of like you have one tutorial to learn something and then a wrap-up to recap on what you've learned. And also they give you like if you want to go further, they give you some like challenges that you can do on your own. And I think it's a pretty good value also. If you're an educator, download the educator guide for an overview of the skills and topics introduced in each chapter. So I didn't check this actually, but if you are teaching iOS in a school or in your company or anywhere, and you're using these tutorials as teaching material, as I'm doing it right now, I guess you might want to read this. I didn't check it out because I really wanted to discover the tutorial as I'm teaching it, because since I know Swift and iOS for more than 10 years, I mean, Swift is not yet 10 years old, but iOS is a bit more. So I know iOS for more than 10 years. So it's very hard for me to be like in the beginner state of mind. So I was like, at least I will discover the tutorial live, and it helps me like build a bit of empathy with someone that is discovering Swift and iOS as they watch this video or as they follow the live stream. So what are we going to need? We are going to need curiosity and imagination. All right, I guess we've got that. A Mac running macOS Sonoma or Ventura. So I'm currently running macOS Sonoma, so the latest version of macOS as I'm recording, and Xcode. So you can install Xcode from the Mac App Store, or you can also download it from a website. I mean, you can download it from the developer portal, and you have a website called Xcode Releases with links to download it. I would recommend you download it from the developer portal rather than the App Store, honestly, because it's quite slow to download from the App Store. But if you know nothing about computer science or anything, get it from the App Store. It's easier and it will look like getting any other kind of. It will be the same process than getting any other app, but people who are a bit more seasoned know that downloading Xcode from the App Store, it can be quite long and the installation can be very, very, very long. But so yeah, it might take some time to download and to install, and the install time can be surprisingly long. You don't need an iOS device because Xcode already includes tools that show you how your app will look and work right on your Mac. To be correct, in a real world situation, you want to have an actual iOS device because there can be small but important differences in how an app looks like in the simulator and on a real device. So for a real app, you will always want to test on a real device, but indeed, to follow tutorial, you don't need a real device. Actually, almost all of my videos, I use I use the simulator, and it's more than enough when you're doing tutorials. A few words of advice, and then I will answer the question I see in the chat. So the only way to learn to develop apps is to make them. It's an art you practice, just like learning to paint or play an instrument. Type the code in your project instead of copying and pasting from the tutorials. You'll build your skills and confidence more quickly. So that's a very good point here. Me, I will be copy and pasting because we want to cover ground, and I don't think it's super interesting if you see me just like typing code all the time. But please, indeed, especially if you're learning, try not to just copy paste. Try to write it yourself. It really helps understand what's happening. And with the code completion in Xcode, it doesn't take as long as it seems. And finally, bring your own ideas. The project in each chapter can be a great starting point to build something you care about. So if you have ideas on how to improve and how to go further, please do it. The tutorials, they are a starting point, but they should by no means be a limiting scope. You can always go beyond that scope. And so it's time to get going. We can navigate using the bar, so at the top, use the menu to choose, and we'll do things linearly. So we're going to move on to the next chapter, which is about getting started with Xcode, Swift, and SwiftUI. But first, let me answer the question in the chat. So let me display it on the broadcast. So do you think it's problematic to learn SwiftUI at the same time as Swift? Possibly because it would be hard to differentiate what is SwiftUI specific versus what is part of the core language. That's a good point. That's a good point. I would say you need to start somewhere. And people who watch this kind of tutorial, you often what they want is to get a head start and get something working. So if you have time to learn, maybe indeed it can make sense to learn about Swift first. But learning by doing and getting an understanding of what you're doing, I think, is also valuable. But you raise a very good point: is that we're going to see things that are part of SwiftUI and others which are part of Swift, and it can be interesting after the fact to try and understand where the line is and why you have this difference between the two. So one is a language, Swift is a language, and SwiftUI is a framework that uses the Swift language. It might be interesting to make sure to really understand where is the line between the two of them. That's a very good remark. I will try to point it out when I can, but it might be useful if I don't point it out, that you ask yourself, is this part of SwiftUI? Is this part of Swift? That's a very good remark. And hello, I see a few more people. Hello, Yash. Nice to see you here. I know you've been following the channel since almost the very beginning, and nice of you to drop by. So let's actually get started. Let's discover SwiftUI. So we're going to start our app development journey by getting to know Xcode, Swift, and SwiftUI. And in this first project called Chat Prototype, we'll code a chat conversation using text views. The text and colors in the project are just suggestions, so feel free to make it your own by changing the words and style. All right. So we're going to create a new project, and we begin by downloading Xcode, the tool you use to create apps. So I've already downloaded it because it's quite long to download, but if you haven't and you're watching the replay, now is your time to download it and pause the video until you've installed it. So Xcode is the software that manages all the files that make up an app, so images, icons, project settings, and code. It's what's called an IDE. So IDE stands for, if I'm correct, Integrated Development Environment, and basically it's the all-in-one software to create apps for the Apple ecosystem. So whether you want to make a Mac app, an iOS app, a visionOS app, a watchOS app, any kind of app for the Apple ecosystem, you will need to use Xcode at one point or another. So step 1, downloading Xcode. So I trust you to do it. Step 2, launching Xcode. So, and when you launch it, the first time you open it, you will see this. So what you will want is to download and install the iOS runtime, which is what allows you to run iOS locally on your Mac on what's called the simulator. So you will want to download this extra 7 and a few gigabytes worth of data. And of course, if you want to try these other OSs, you might want to download them. But of course, you can always download them later when you need. So in the welcome window, click Create New Project. So I've done it just before, so I will switch to Xcode on the next step. And what's a project? Because it's a very important word, project, which you will see appear often, and it does have a technical meaning. So a project, it's what contains all of the components of an app. So it's all of the source code that describes how it runs to the icon that represents it. So basically, the project it's everything you need. It's everything you need to build an app. So all of the sources, so the source code, the images, the sound, maybe the videos, everything you need to build the app and the way to build it. So the build steps, how do you compile the app, etc. And so this is managed in a project file. And so when you hear the word project, this is what it means. There is a very technical sense to project that you might not be familiar with if you're just getting started with iOS development. So next, you will want to choose which template to use. So Xcode has a variety of templates that basically each contains some boilerplate code to create a certain kind of app. I use the word boilerplate. If you are new to computer science, you might not know what it means. Boilerplate, it means the kind of code that you need to write in order to just get started. So for instance, if you do an hello world, maybe you need to import the function that allows you to print to the console. That's the kind of thing. If you want to do a basic SwiftUI app, you need to have code that imports SwiftUI, that displays a basic view, and that displays some text on the screen. That's also what we call boilerplate. So that's a term that you might see often when you learn about how to create apps. And so here you want to use a template that is in the iOS section and the app template, which is the most basic one and the one that you almost always end up using. I mean, in my experience, I almost always use this one. I don't remember when I actually used the document app, for instance. I guess it's much rarer that you use the other one. So you will choose this one, and then you will be on step 5, which is the one where I'm at currently in Xcode. I see a very good question. So somewhat unrelated question. Does Docsy have support for making this new style of tutorial docs like this? I know you can make tutorials, but think there's some styling things may have changed. I think it might be what I think Docsy might be able to do that. Maybe not all of it, but a good part of it. Because if you remember, I think it was in either at the end of last year or the beginning of this year, but I followed the tutorial about TCA, the composable architecture, and it really looked like this one. And I think, I mean, if the guys from TCA, which are not part of Apple, have made it, they use Docsy to make it. So honestly, I think it's possible, and I would recommend that you check out what the people at Point Free that make TCA have used. Maybe even ask them on social media. But I think this can be generated using Docsy. But I haven't done it myself, so I can say for sure if you can do all of it using Docsy. And if you don't know what Docsy is, it's a tool that Apple released last year, so in 2023, that allows you to write documentation in a like a markdown syntax, and then have the tool, so this Docsy tool, generate these beautiful web pages for you. So I think Docsy stands for Documentation Compiler or something like this. So that was a good point. Thank you for mentioning it. Let's go back to the tutorial. And so we will call the project chat prototype. So as you see, I'm doing copy paste, but you might not want to follow my example on this one. So I've selected the app template. So I call it chat prototype. And you can see here they explain what the other options are for. So next to organization identifier, you need to enter name.yourname. So for instance, if your name is Sophie Sun, you will enter name.sophiesun. The organization identifier is used when you upload an app to the App Store. And the App Store requires your organization name to be unique. You typically format it as a reverse domain name like com.apple.com. So me, I did com.vincentpradey, which is my name. But Apple suggests I should have done it something like this. And the goal is that if I ever were to upload this app to the App Store, this would need to be unique across all apps because this is what uniquely identifies my app. Actually, if I'm correct, I think there is something that is appended before that identifies my developer account. And so I think this name only needs to be unique among my apps. Like all of my apps, we need to have a unique name, but not all apps in the world need to have a unique name here. But I'm not 100% sure, to be honest. So it's called a chat prototype. So I've put my organization identifier, and you can see that it gives me the bundle identifier, which is just organization identifier concatenated with the product name. And this is what iOS uses to uniquely identify an app with maybe an extra info added in front to identify the developer account. And this is very useful. For instance, when an app receives a push notification, what happens is that the push notification is sent to the iOS device and it contains the name of the app. And this is what iOS uses to know which app is the notification for. Because otherwise, Xcode iOS needs to have a way to know this notification is for this application, and so this is how it's done. So you can see it kind of like it's kind of like the phone number in a way, but the phone number but for an application. It's kind of the same concept when you think about it. And then for this tutorial, you don't want to change the settings, so I will put them back as they are by default. So interface Swift UI, language Swift, and storage none. So I had the first two correct. Storage was set to Swift data because, as I've told you, I followed the Swift data tutorial the weeks before, but I will put it back to none. And they've left include test checked, so I will do the same. And so next, I click next. Sorry, you cannot see it. Let me move it. Okay, this way you can see it now. So I'm going to click next here. And let's see where it gets me. So where do I want to store the project? So I'm going to store it on my desktop. So you can put it, of course, wherever you want. They ask you to uncheck the box to create a Git repository on your Mac. I'm not sure the reason why they ask you to do that, but maybe they will talk about Git later. Maybe they want to take this part out of it. But just if you don't know about what Git is what's called a source management control system, if I'm correct. I don't know what the actual like acronym is for it, but I know that there is one. But since Git is so popular as a way to handle changes in your source code, I think I always use Git, so I don't remember the name of the category of software that Git is part of. But the job of Git is to be able to track, yes, VCS, version control system. Yes, I remembered. I think CVS. No, maybe CVS. There is one that is like that was one of the first software to do that. So I think it's Control Version System, CVS. I think it's also the name of a pharmacy chain in the US, but that's just a coincidence, I think. But yeah, this software. So there is Git. An older one is also SVN. There is also Mercurial that you might hear of. Their goal is to enable you to track changes in your source code by being able to commit incremental changes into your source code and being able to go back to previous stages of your source code if you've made a mistake, or create what's called a branch in order to work on several features in parallel. So I'm not going to cover this unless the tutorial does it, but if you're new to developing apps, you might want to take the time to learn also how Git works, because Git is a very important part of the workflow of software engineer. So it's nice that I have the opportunity to mention it here. But let's uncheck it so that we do the same thing than them. And finally, you do create to create and save the project. So what I've just done. Next, we're going to explore the project to see what is inside an Xcode project. And so we'll be exploring the key features of Xcode, the navigator, so to move about inside our project, the editor to update, to make changes to the source files, and the preview to see what our app looks like. So step one is about what is the navigator. So the navigator is the leftmost column in the Xcode window, so the one you can see here, the part that doesn't have this white veil over it. So the project navigator is selected. So it's the first tab right here. You can see its icon, a small folder highlighted at the top of the pane. The project navigator displays all the files in your project. Note that content view is the highlighted file. So you can see it's here. So on the left, we have the navigator. We have several panels here, and the first one that's selected is the one that's called, I think they said it's called the project navigator. And this allows us to navigate through all of the files inside our Xcode project. So we'll go over these files one by one to see what they have inside, I guess. And you can see that the current highlighted file is the content view, which is displayed, whose content is displayed in the editor, which is right here. And I guess we're going to talk about just after. So indeed, next is the editor. So it's where you write your source code, and it's displaying the code from the content view file because it's the one that is selected in the navigator. When you select an item in the project navigator, its content appears in the editor. So very basic, but also something that might not be that intuitive if you're getting started with developing apps and doing computer engineering. The preview, so the part on the right here, the preview canvas is the right part of the editor. It shows you what your app would look like running on a real device. And you can control preview options like device size and light or dark mode using the buttons along the bottom. So a preview only appears, of course, when you are editing a SwiftUI file. Actually, you can see the preview is defined in code right here. I guess we'll go over about what this syntax means just after. And as they said, you can override if you want the color scheme, so to switch between light and dark appearance, or to switch between orientation, or to switch between dynamic type, which is the size of the font. You can see I made the size of the font larger, and now I'm making it get back to its default size. And I'm also going to uncheck overriding the color scheme. And if I make a change in the code, so if I put, for instance, capital W here, you can see the preview is reflecting these changes in real time. But I guess I'm getting ahead of the next steps. So let's see. Now it's about exploring our code. So we're going to read through the code. Swift and SwiftUI are designed to read like natural language. Swift is the programming language you use to write your app's code. SwiftUI is a framework that provides views, controls, and layout structures for creating your app's user interface. And as the name suggests, SwiftUI is built using Swift, and it leverages several key features of Swift in order to have its very powerful and I'm trying to phrase this correctly, but let me rephrase it. SwiftUI is built in a way that you don't need to write a lot of code to get the result you want, and this is possible because SwiftUI leverages a lot of features of Swift, and actually several features of Swift were developed in part or in total because Apple had the idea of building the SwiftUI framework. So we'll see that the name of many Swift elements are common English words. So for instance, image, image scale, text, and they all hint at how they create the interface. And they highlight something is that image scale is formatted using what is called camel case. So the words are glued together without spaces, and each word after the first one is capitalized. So this is something important, and this is something that is very, very typical of computer code, is that this is what's called an identifier in the terminology of programming language. And identifiers, most of the time, they don't have spaces in between them because a space it's actually hard to explain simply the reason for it. But basically, when you have a space in most programming languages, it means that you're talking about two separate concepts. And so, if you were to have a space here, then image and scale would be two different things because typically you would use a space, for instance, when doing 3 plus 3. And so you separate different elements. Here, it's not the case. You have two words, but they are still part of the same concept. And so these two words are grouped together in this thing that's called an identifier. Here is the name of a method that we are calling on the image. And so we use this syntax called camel case in order to put several words, to glue several words together, but still keep a good readability. Because if we didn't have the first letter of all the subsequent words uh, being uppercase. You can see here it's hard to read like image scale, but it's hard to read it at a glance. Same thing here, like foreground style. It's a bit easier, but it's less confusing than for this first one. But you see, like the first one, like is it images calé? Is it image scale? Is it imag scale? It's not clear. Whereas when you do this, it makes it much clearer. You might see other programming languages that use sometimes like underscores as a way to separate words without using a space. Swift chose to use camel case, and it seems to be one of the most popular choices in many programming languages. But you can find the two approaches, to be honest. Uh, some languages use camel case, others use these underscores, which we call snake case, because it kind of looks like a snake if you think a lot about it. So it's kind of like, you know, like when they tell you that the stars, they are in that shape or this other shape, you need to think about it. You need to squint a bit at it to see that it's a snake case. But the idea is that it's kind of like a snake, you know, like being like having its body like being like this. So you need to use your imagination. They told us at the beginning we would need to use our imagination, but that's the name of it. And camel case is because it's similar to how a camel looks like with the bumps on its back. All right. All right, all right, all right. And yeah, using snake case. Oh, yes, true. Kebab case also exists with a dash to separate the items. Kebab case is a bit more rare these days, to be honest. I think one of the places where I would expect this, so kebab case is in XML files, but XML files are less and less popular, which is arguably a good thing. But but you're absolutely right. This one does exist, and good to know that some people use it for unit test function names. Personally, I would rather go with underscores, but I think it's maybe more like force of habits. But yeah, uh, kebab case. It's been a long time since I've used this one. To be honest. All right, let's go back to the tutorial. So then they tell us to look for the braces and parentheses in the code. We can see that these characters are present a lot. And so parentheses, they usually have information related to the code immediately before them. Braces, they are like containers. They usually group multiple lines of code into one chunk. And the word that we use to describe this chunk is often a scope. So the curly braces, they define a scope of code. Whereas, so for instance, here we have a scope of code. So this is the code that is inside the property called body. And we'll learn about what is a property just after, I guess. And parentheses, indeed, often they are attached to what is immediately before them. So, for instance, here, these parentheses, they allow us to pass the arguments of the image. So here it's the name of the image, the name of the system image, so the built-in image as part of iOS. And here for image scale, it's the argument we pass. So what is the actual scale of the image? We used a large image, but we could also have said a medium image or a small image. And you can see the size has changed every time I updated the value of the argument. And I think like yeah, these parentheses and curly braces, they're really like when you look at this, it's what's typical of showing code. Like if a movie wants to show something that looks like code, they will put something with lots of curly braces and parentheses and a lot of syntax coloring. And basically, to someone who doesn't know anything more, like this looks like some hacky computer science thing. So this is very typical of source code, and especially source code of languages that have like inherited from the C programming language, which is a very popular language that started, I think, this whole pattern of using a lot of curly braces to define scopes of code. And you can, if you double click on them, you can open or close them. So let's see. Actually, so when you double click, you select everything inside, and you have a feature in Xcode to be able to close them, but I might have disabled it. It's in text editing, it's this thing. So like the code folding ribbon, they might be referring to this, uh, might be referring to that. I've disabled it because I don't use it that much, to be honest, and also because when I do screenshots for my website, I think that it's cleaner if you don't have this folding ribbon, but indeed, you can close. Oh, I think no, they meant try double clicking on it, and so to show you that you can just select everything that's inside of it. It's a shortcut, and also if you go over a closing uh, brace or parenthesis, you can see that the corresponding opening one is being highlighted. Sadly, it doesn't work. So actually, it works. So yeah, it works for the opening curly brace. Also, you can see it. It doesn't seem to work for the parenthesis for some reason. Actually, so that's weird. Like here it works for the opening one, but not here. So it might be a small bug in Xcode. When you work on iOS apps, you will come to learn that Xcode can have small or large bugs at times. So it might be a bug of Xcode here, but when you move your cursor over a parenthesis or a curly brace, it will show you what is the corresponding opening or closing parentheses or curly brace. And that's very useful when you are navigating large pieces of code and you're a bit lost and you want to know where is the other part, or you can just double click and you can see the whole content being selected. Now let's look at the indentation of our code. So indentation are the leading empty spaces before you have actual characters on a line. So you use indentation to reflect the code's organization and make it more readable. However, code without any indentation will still run. So if I take this code, you can see that it's indented. So basically, every time that you are nesting child content inside a parent content. So basically, every time that you meet an opening curly brace, you add one level of indentation, which usually is 4 empty spaces. And you can see that when I hit enter, Xcode is doing it automatically for me. And this makes the code easier to read because you have this visual aid to understand the level of nesting of your views. And so it becomes clear that the V stack here is inside the body, that both the image and the text are inside the V stack, etc., etc. However, this is not mandatory to make the code build. So you could imagine not uh, not doing a correct indentation, but you will see that as soon as you do it, the code becomes much harder to read. Like this is much harder to understand what's happening at a glance. Like you see this, okay, what is it part of? You need to move. Okay, it seems to be part of this VStack, but imagine on a more complex piece of code, it would be very hard. Compare it to what we had before, which I can put back by doing Control plus I. This is much better. So indentation is very important, and you should always like strive to maintain a good indentation. And it's very easy. Just select the code, do Control plus I, and it will be done automatically for you by Xcode. So really, my point here is that there is no excuse to not have a good indentation because it helps tremendously to understand how the code works and is structured, and it's basically free. Xcode does everything it can to help you have a correct indentation. Now, let's talk about syntax highlighting and syntax coloring. So you've probably noticed that Xcode colors different parts of our code according to their purpose. This is called syntax highlighting. You can often see the terms of also of syntax coloring, but I think Apple prefers syntax highlighting. So some things, or rather some words, such as struct here, are keywords in Swift. So it's reserved words that have a specific meaning in the Swift programming language, while others, such as image, are features of Swift UI. And that's why they are colored in different colors. And you can turn off syntax highlighting or select a different color scheme by choosing an option under Editor Syntax Coloring. So where is this syntax coloring? I know you have it in the theme here. So for instance, you can change the theme and you can see that it can look very different differently. So me, I use presentation dark and you can see that indeed the color is not the same and even the formatting, this is bold, is not the same for keywords than for comments, than for instance, declarations which are at the level of the project or at the level of something that's being imported. So this is super useful. I didn't know that you can select like your cursor. You can put an underline cursor if you want. You can put like an underline cursor like this. I didn't know you could do that in Xcode, and you can also put a block cursor if you want. So you learn something new every day, I guess. I still recommend you keep this one because it's the one we are most used to. And so, can you deactivate? You can deactivate. Maybe is it here? I'm looking to find how to deactivate this. Okay, this is where you select for the indentation. Where do you disable this syntax coloring? Because it would be funny to see the code without any of it. I don't really see it. Oh, maybe actually, no, they said I was looking in the preferences, but it's in editor. So no, editor is in the menu. So editor, it's in one of the menus. Like I'm sorry, I think it's outside of what's being streamed. But editor, it's actually I shouldn't say sorry. I should move the camera because what's important is that you can see what's happening. So editor is right here, and so. Where is this syntax? Oh, yes, syntax coloring. So if I do none, whoa, you can see this is much harder to understand at a glance what's happening. I wouldn't want to have to work with this kind of code. So imagine if you have no syntax coloring and no indentation, it's going to take you a lot more time to write your apps. So of course, don't do this. Put it back to default for file type, and this is much better. I think we can all agree. We can all agree on this. All right. And then next step, find the text hello world in the code. So right here, it's color red and surrounded by quotation marks. Swift calls a written language like this string. So string stands for string of characters. So a collection, an ordered collection of characters. And whenever you are handling text, it's going to be done through a string. And so strings are defined by putting quotation marks, double quotation marks at the beginning and at the end of the string. Okay, now we're going to edit code and make mistakes. So we're going to change the code in the editor and see how the preview updates in response. Xcode has features common to other text editors like copy and paste, undo and redo, and text selection. So I'm going to hide this because I'm going to show it to you in Xcode directly. So step one, we change the text inside the quotation marks to a word or phrase of your choice. Make sure not to delete the quotation marks themselves. Note, you won't see the preview until Xcode finishes downloading the iOS platform. So if you are just downloading and launching Xcode for the first time, you won't see the preview until you've installed the iOS platform, because remember, you need to download it separately after having installed Xcode. So let's change hello world to a hello YouTube, for instance. And you can see, let me make it a bit bigger, that the preview does show hello YouTube. So the preview is reflecting in real time what's the content of my content view. Now we're going to make a deliberate mistake. We'll delete the string inside the text, including the quotation marks. And we'll notice the error banner in Xcode that popped up on the line of code we edited. When Xcode can't understand what you wrote in the editor, you'll see messages like this. So I'm double clicking the quotation marks to select everything. So it works just the same way than when you double click on a parenthesis or on a curly brace. And I remove everything. And so now you can see we have a failure, and the failure says, let me hide the left panel, missing arguments for parameter verbatim in call. Insert verbatim and then a string. So let's see what the tutorial also tells us. So now start to correct the error by typing one quotation mark inside the parentheses. So we are putting back the string argument that we passed to create the text. The editor may automatically insert a second one for you. If so, delete the second one. So you can see it didn't. So we can see the rest of the code on this line is colored in red. And so here they want to show us that sometimes you can cause temporary errors by putting the code into an invalid state as your type. The current error is a good example. Text needs you to supply a string for it to display, but you haven't finished typing a string. So you don't have a correct string right now for now. So they suggest that we click the red icon at the head of the error banner to expand details for both errors. And it says the new error is unterminated string literal. So let's see. Indeed, unterminated string literal. So we began to start a string, but you need to finish it with another double quotation mark, which I haven't provided yet. And a string literal is the kind of Swift string you've been working with, text inside quotation mark. So literal, this word can be a bit weird, but basically this right here is a string literal right here. If I write this is an integer literal. So literal, it just means that the value is written in the source code. That's what literal means. So you can kind of understand as like, you can kind of understand literal as being something that's literally written inside the source code. So this is a literal string. The reason why there is this difference between a literal string and actual string is because there are advanced operations that allow you to take the literal string and turn it into a more complex object. By default, a literal string is turned into a string, but if you want, you can turn it into an object with more features. For instance, you could imagine turning this into a URL if your string contains a URL, but by default, literal strings are turned into strings. But in the eyes of Swift, the two things, literal strings and strings, are still slightly different because of this mapping that is done when you build your project. This was a high-level explanation of something that is like really quite complex and quite subtle. So if you want to learn more about it, I really encourage you that you search more about what a literal string is in Swift and how it works, but it's an advanced topic, so I won't cover it in this live, which is supposed to be a beginner tutorial. And so they tell us that all languages have rules, including Swift. If you begin a string with a quotation mark but don't close it with a second one, you've broken a rule about string literals, and these rules are what's called the syntax of the language. Notice the closing parenthesis is now red because Xcode's best guess is that the closing parenthesis is part of the string. And indeed, maybe you want to keep writing something and finally close the string. All right. No, let's get back to how it was. It was like this. Okay, it was like that. So we're going to add a second quotation mark to fix the error. So like that. Now the code is correct because we pass in an empty string, so a string that contains 0 characters, and this is valid. Just like you can have an empty array, just like you can have an empty set in mathematics. Just like 0 is a valid number, you can have an empty string that contains no character. And so the preview on the right now has no visible text, just a globe image. That's because the text is an empty string, so there is no text to display. But we are back to having valid source code. This is something that builds and that can be run on an iOS device. And step 6, put your greeting back in the text view before you continue to the next section. Your code is working again and you've completed the first part of your conversation. All right, so I'm going to put back hello YouTube like this. All right. I see a question about what do you think of beginning an iOS dev career in 2024? It's a topic that would be worth being discussed at length. I won't do it because it's a bit outside of the topic of the live stream. But honestly, I mean, I don't monitor the job market closely because I already have a job and I'm not looking for a new one. I would say if you're committed to being like above average and quite good, so to really understand things at a deep level, I would say that there is still room for there is still room for talented people. It might be either junior positions or positions for simple projects that might be a little bit harder to get a job at. Either because the job market has become tougher, people can rely on AI tools more to write simple code where they don't really care about it being correct or it being maintainable. So I would say if you want to get into iOS, probably think about do you see yourself doing this and keep learning continuously over the next 2, 3, 4 years in order to keep improving your skills and reach a very good level. I think in general that this is the recipe to get a good amount of success in a career, but also with more junior positions becoming more and more scarce, this might be like other approaches where someone would only learn the basics and be happy with that might become less and less successful or way less successful than they could have been a few years back when there was a very high demand for all kind of software engineers. But it's only my take. Don't take it like as gospel. I don't follow the job market very closely, as I was saying. So ask around, ask opinions for other people, ask opinions of people that are working in the job market that you are looking to apply to. For instance, I work in France. If you're planning to apply, I don't know, in the US or in another country, ask people who work there. They will also have not a better, but maybe a more informed opinion to share that I cannot have because I don't know every job market. So that's the best I could give as an answer without going too much off track. But thank you for asking this question because I think a lot of people that are watching such a beginner's tutorial might ask themselves the same question. All right. Section 5, use the library to add a text view. In SwiftUI, a view is part of the interface of an app. Text is one example of a view. Views are distinct from the data they display. Text is the view, and the string inside the parentheses is the data. A very important distinction to have in mind between what we often call the UI, so the view, what displays the data, and what we often call the model, so the data that is being displayed. And being able to efficiently separate the two of them is actually a key skill at computer engineering. So step 1, we're going to delete the line of code beginning with image and the 2 lines below, and then add a new line below the text view. So this, off you go, and we add a new line below the text, which is a view, such as VStack, but I guess we'll go into what VStack is a little bit later. Just saying it in case you wonder, VStack is a way to combine several views vertically. You can see we had 2 views, so image and text, and they were stacked on top of each other, so they were vertically stacked, hence the name of VStack. And as you can imagine, you also have an H stack for horizontal stack. And you also have a Z stack to put things on top of each other on the Z axis, so from the bottom to the front. So on this axis, so like that, where I don't know if it makes sense what I'm doing, but where you're putting like one thing on top of another, but in a direction that faces the screen. I don't know if it's super clear. If you want to know what a Z stack is, look at its documentation. I'm sure that there is like a good example with a good image to explain what it is. But I just wanted to shed some light on what this VStack is right here. So now they're going to show us how to create, how to add a view using the library. So it's a way to add a view using the UI in Xcode. When you have some experience, usually you don't use it, you just write it by hand. But when you're just discovering and learning, I think this can be quite useful. So you do this by clicking the Add button, so the plus at the top of the project window, which opens the library. You can also open the library by choosing View, Show Library, so in the menu, in the menu bar, and you can use the library for quick access to SwiftUI components, colors, and images, as well as other items you'll use frequently when building an app. You can click and drag to position it. To dismiss the library, press escape or click anywhere else on the screen. So like that, we can open the library. And you can see that we have examples of snippets of code. And I think here what we're interested in are Swift UI views. So it's this panel right here. Make sure you pick this one if this one wasn't selected by default. And so we have several kinds of Swift UI views. We have buttons, date pickers, color pickers, forms, gauges. So let's see which one we need to pick. I think we need to pick a text. So they tell us to select the first icon just like I did, all right? And then in the search bar, you type text in the field at the top at the top to narrow your search. Then from the list below, you select text to insert it into your code and double click on it or press return. And the new view has a placeholder string in the blue capsule, which is highlighted by default. So let's see what that means. So I need to reopen the library because I left Xcode. So text, and I want this one, so I can just hit return, and you can see it has put the new text where I had my cursor. So most of the time when you want to create a view, you will probably most likely type it because you will remember it. But when you're still new to it and you want to have an overview of what's available, this library right here can be quite useful. But to be fully honest with you, I don't really use it on a day-to-day basis because most of the time I already know what I want. But it's a great tool when you are still learning. And so we have this placeholder, and so we're going to replace it with this text message. So actually, you know what? I'm going to do the same thing so that we have the same content. So here it was knock knock, and then the other one is who's there. And so here we have a placeholder, so we can double click on it, and we can replace the content with this who's there string. And you can see it's being displayed in the preview. Okay, now we're going to use code completion to add something called modifiers. So now that we have a pair of chat messages, we are going to use view modifiers to change their appearance and behavior. So we're going to add an empty line below the first text view, so like this, all right? And then we're going to start to type dot pad, so PAD, then pause to let Xcode show code completion suggestions. We're going to use the arrow keys to highlight padding with this argument, so edges and length in the menu. Then press return to insert the padding modifier into your code. So we start typing. So you can see it's actually the one that's being selected by default. So I can move to select other modifiers which also contain this PAD string. And so I'm going to hit return. And you can see I've added some padding around the text by calling what's called a modifier on the view text. So we'll see, I guess it's going to explain what a padding and what a modifier is just after. Here they show that you can show or hide code completion by pressing escape. So indeed, you can do it like that with escape, both to show it and to hide it. So that can be quite confusing when you are new to Xcode because in other software, it's often like control and space, for instance, to trigger code completion. In Xcode, it's actually escape. And when I started doing iOS development, so more than 10 years ago, it took me a bit of time to understand that it's escape because I just was not used at all to using escape to open something. You're used to using escape to exit something, but not to open it. But actually, to open or close code completion in Xcode, you use escape, which kind of makes sense in a way because it's quite easy to hit. The key is quite large on the keyboard, so it makes sense, but it can be surprising when you are not aware of it. It's a good thing that they mentioned it. So now let's talk about this padding modifier. The padding modifier adds extra space around the edges of a view to separate it from its surrounding views, to separate it from a visual point of view. You apply modifiers to views using dot notation, so using this dot right here. That's why there's a period before the word padding. And we say that we call the modifier padding on the text. And basically, by calling the modifier padding on the text, we get a new text, which is a text with padding applied to it. That's a way to understand it. And you can compose modifiers, so you can call one modifier after another. So we're going to add a second modifier to give the chat bubble a background color and a shape. So just below the padding, we start typing dot back, then let Xcode show us code completion suggestions, and we're going to choose background style in and press return to add it to our code. So let's see that. So it's background style in. So it's this one right here. So I'm going to hit enter, all right? And they tell us that there are often multiple versions of the same view or modifier. This version of the background modifier lets you set the style of the background and give it a shape with the argument in shape. So when they say this version, they refer to the doc of the version we've selected. So if I click it, you can see, sorry for the white screen if you were watching this in a dark lit room, sorry for your eyes. So this is the version we've selected. So when you have a function like background with the same name but several possible sets of arguments, it's what we call overloads. So overloads is when you have the same function or method with the same name but a different list of arguments. We say that they are all overloads of background, for instance. So you can have several overloads. Let me show them to you again. So you can see all of these, they are overloads of background because they have the same name, background, but they take different sets of arguments. And because they take different sets of arguments, the compiler is able to tell them apart and to know which is which. Oh no, I've lost where I was. Damn it. So where was I? We were in Hello Swift UI, and we were, I think, in no, this one. This one, yes. Okay, we were adding the background. All right. And so, okay. So next step, the modifier requires arguments between the parentheses to specify the style and shape. Xcode automatically highlights the placeholder for the first argument. We're going to type color.yellow for the first argument, then press tab to move on to the next argument. And you can see other color options by typing color dot and viewing the code completion list. So let's see. So color dot, indeed, we can see several colors. So we're looking for yellow, which is here. We could have also started to type to narrow down the possibilities. And so color is what's called a type in Swift. And then this type has members. And so you can access them using also the dot notation. So we've provided the first argument. Now it's still not working because we need to provide a value for all arguments and we still need to provide the shape. What I will do is that I will display the call over several lines. This way it's easier to read. So this is a syntax which is kind of nice, and you can actually get it automatically in Xcode by putting your cursor inside the call and doing Control plus M, and it will format it that way. And this way it's easier to read. I personally find. And so what do we do for the second argument? So we're going to begin typing a rounded rectangle for the second argument to the modifier background. And from the code completion list, we'll choose the version of rounded rectangle with an argument labeled corner radius and set the value of the corner radius to 8. So let's do it like that. Rounded rectangle, the one with a corner radius, and the value of 8. All right. And so now the code is working again, and you can see that we do have the padding, so that added some extra space around the text. And then we colored that padding in yellow with the shape of a rounded rectangle with a corner radius of 8 points like this. So this is our first venture into trying to add some styling logic to our UI components. So before adding modifiers to the next chat bubble, we'll do a quick experiment to see how the order of modifiers affects your views, because this is super important to understand. So reverse the order of background and padding modifiers so that the padding comes after the background. So we're going to move this line from before the background to after it. You can see we don't get the same thing. And you can notice how the chat bubble's appearance changes. So at the bottom leading corner of the preview, click the button to enter selectable mode. So in a live preview, the default mode, you can interact with your interface to test it out. So if there is a button, for instance, we can click on it. in selectable mode, so what we're going to select with this button here, we can click elements in the preview to see more information about them and to highlight the corresponding code in the source editor. So you see now, if I click here, it selects the corresponding code in the editor. And so we're going to click the top message bubble to select it. Xcode shows the selection by drawing a thin blue border around it. So we've selected this part right here. And you can see it corresponds to this piece of code right here, the one that's highlighted. The selection rectangle encompasses the colored bubble and the empty padding around it. And now, if we restore the original modifier order by putting the padding before the background, we can see that the colored bubble now fills the selection rectangle. So I'm going to move this back at the top, and you can see that now the blue fills entirely the rectangle, whereas before it only filled the part that was before we added the padding. So why is that? So we're going to take a look at the sequence of modifiers in our code. So let me make sure that I'm not covering, yes, perfect, I'm not covering it. So let's take a look at the sequence of modifiers in our code. The padding modifier creates a new padded view with empty space around it, which is affected by any modifier coming after it. And what's affected is the white empty space. If you want the padded area to have a background color, you must modify that padded view. So you can see that you have the text. If you put a background color, then you put a background color just on the space occupied by the text, and then the padding adds extra space, but that space comes after the background color yellow modifier, and so that extra space is going to stay white because it was applied after we colored. Whereas if we apply the padding before, then when we color everything, and so we color the space occupied by the padding as well. So another way to see it is that putting your shoes over your socks is different than putting your socks over your shoes. It's kind of the same thing when you think about it, and it's important to be able to have this distinction in the order, because there are situations where you might want to have the behavior on the right, but there are potentially situations where you want to have the behavior on the left. For instance, if you make a button, maybe you don't want it to touch like the very border of the screen. Maybe you want to have some empty space between the border of the button and the border of the screen. So there are times where you will want what's on the left, and there are times where you will want what's on the right. So it's good that the syntax we have in SwiftUI allows us to define both, because this kind of possibility that also makes SwiftUI quite a powerful framework. If we could only do either the one on the left or the one on the right, we would be quite limited quite soon. All right. It's good of them to have explained this. And now we're going to change the preview back to live mode by clicking the button just before the selectable mode. So this one right here, the default one. And I'm going to make the text, the texts a bit more visible. All right. And step 3, we add padding and background to the second chat bubble, this time using a different color, for instance, color teal. So remember, me, I copy paste because I'm lazy and it's not interesting if I spend all of my time writing code, but you should try to write it yourself. And remember to format across several lines. You do Control and M, and the code, I think, looks better that way. So now we have 2 different formattings for each of the text bubble. All right. What's the next step? Okay, so actually we finished this part. So check your understanding. What type of data in Swift represents written language? So if you're watching the replay, now would be a good time to pause and try to understand the question yourself. Don't just wait for me to give the answer. So what type of data in Swift represents written language? Text, writing, or string? So it's not writing because we didn't cover it at all. Is it text or string? So it's actually string because string represents the data. Text represents how to display the data. And remember, this difference between the UI and the model is extremely important. So it's indeed string that is a Swift type that represents written language. Then, which modifier order expands the background of a view? So we have padding and background, and then background and padding. So what expands the background of a view? So it's kind of hard to understand what they mean. If they mean that the background, so for instance, the blue background will look bigger, in that case, it's the first one because we apply the background after the padding. So if I understand correctly, which is which modifier order will make the background color apply to the extra space around the view, then it will be the first one. Okay, so I got it correctly. So you apply the background modifier after the padding to include the padded area in the background. So I understand this expand correctly. Last question, true or false? You provide arguments between braces to provide related data. So this is false. You provide arguments using parentheses. Braces are to define scopes of code. And so I was correct. Arguments, they come between parentheses. All right. So let's read the wrap-up about exploring Xcode. So the first chapter. So time to reflect on the concepts we've learned and get ideas for ways to practice using text and modifiers. So what have we learned? What are the concepts that we have learned we should reflect on? So SwiftUI contains the components used to build the interface of an app. Views and modifiers are the foundation of SwiftUI. You can use them to make the most complex, powerful, and beautiful app you can imagine. So we just covered the very basics, but you can make very complex apps using what we've using this basic building block that we've just covered. So what topics and skills have we covered? Creating a new project in Xcode, the structure of Swift code, including keywords, braces, parentheses, and dot notation, the Xcode library, writing code using code completion, text views and the modifiers that change their appearance, ordering modifiers to achieve a desired layout, and how can you continue practicing. So if you want to extend your app, so usually these are the easy challenges. So you can add more messages to the conversation. You can tinker with the color schemes of your message bubbles and their text using code completion to explore all the built-in named colors. So maybe a red color, a blue color, a gray color. You can try to make these changes. You can try to add shadows to the bubbles by using the shadow modifier. Or you can try to modify the VStack by adding an argument to change the default spacing between its elements, like this, so passing a spacing of 5 when creating the VStack. And if you want to change yourself, so this is something that is usually a bit more complex to do, you can start a new project called myself in 6 words, use the text views to display 6 words that describe you, give each word some padding and a different background color. For an extra challenge, try displaying the words horizontally and vertically by nesting HTAG views inside VStacks. So I mentioned HTAGs before. This is your sign to try them if you wish to. So that could be a good way to challenge yourself if you want to. If you're watching the replay, also could be a good time to pause, reflect, maybe try a few of these challenges and come back for the next part once you've been able to just like digest a bit these new concepts. So next step, we are going to cover view structures and properties. So as you can see, there is 1, 2, 3, 4, 5 chapters. I won't cover all of them in a single live stream because I would be dead on arrival. So I think I will cover the first 2 today. So we'll still cover this one, then these 2 next week, and probably the last one last time, or maybe it will depend on how long each of them are, but I will cover view structures and properties right now, and then for the next part, it will be next week. I didn't want to open the documentation, so actually, I wanted to move on to the next chapter. So it's this one. Customize views with properties. So we're going to create a SwiftUI app by building custom views to make a multi-day weather forecast. In your custom view, you'll use properties to customize the display for each day. Because in our current view, everything you see was written in the code. All of the data was written in the code. This is what we call having hard-coded data. But of course, if your app was to be like that, you would need to write a view for each possible string that the app displays. So of course, that's not possible. What you want to have is to have arguments that the view can display. And so that's what we're going to focus on right now, if I understand it correctly. So we're going to design custom views using structures. Structures are a way to organize your code so that related pieces of code are packaged together. Every structure has a name that lets you reuse it like a template anywhere in your app. Actually, we've already used structures before because image is a structure, text is a structure, even string is also a structure. With structures, you can write code that is more efficient and has fewer errors because you are building something once and then reusing it in several places. And so you only need to build it successfully once, and then it will be correct in every place that you use it if it was correct in the way you've built it. So we will be creating a new project in Xcode. So now you know how to do it, and we'll call it weather forecast. So let me go in Xcode. Let me minimize this project. Let's create a new one. So I did Command Shift N to create a new project. So it's an app. I call it weather forecast. All right. I just save it. Okay. So let's do that. Put it on my desktop. All right. And so we're going to prototype a forecast view. So we'll create a simple interface. So this one right here, simple, but yet more complex than what we've done before. To display two weather forecasts, notice the repeated pattern in the interface with the name of the day, some kind of icon, the high temperature, the low temperature, obviously in Fahrenheit degrees, because the day we have this in Celsius degree, we are in a very, very bad place. And I think we are likely to be dead the day we have this in Celsius degrees. Even worse if it's in Kelvin degrees. So this is definitely Fahrenheit degrees. You can see the tutorial was written by people in the US, but actually they might. I don't know if we're going to format the degrees using a formatter, but if we do, they might appear as Celsius because my computer is definitely on the European local. So let's get started. Step 1 in content view, delete the code inside the VStack. So let's do that. And that's it. It's gone. And replace it with a simple weather forecast. So remember, I'm copy and pasting, but you should strive to write it by hand. Let's see it appear. Let me make it a little bit bigger. Something like that. All right. Then we add an image view to our forecast and use it to display an SF symbol as a sun. If you don't know what SF symbol is, it's a font of character that contains icons and that contains basically all of the built-in icons you can use for to add icons to your app. And it's built in into iOS, so you don't need to include anything inside your app. So it's pretty useful. So this kind of image requires one argument, whose argument label is system name, so the label of the argument. And if you want to browse all of the SF symbols available, you can download an app that allows you to do it. So I would recommend that you check it out if you want to see all of the SF symbols which are available, and there are quite a few of them available by now. So I've added the symbol, the icon of a sun, maximum amount of sun, and being filled. But you can see, for instance, if I remove the fill, then it's empty at the center. So you can modify like that, and the app SF symbols app allows you to figure out how you get this string to display the icon of a sun with a field center. Okay, step 3, we use the foreground style modifier to make the sun icon yellow. So we're going to add the foreground style. So careful, we only apply it to the image like that. All right. You can see it's become yellow in the preview. So you use the foreground style modifier to apply a color to the foreground elements of any view. For example, setting a color as the foreground style of a text view changes the color of the text. And here, for this kind of image, which can be recolored, you can also use foreground style in order to set its foreground style. And in this case, the style happens to be a color. Next step, we get ready to add a second forecast by right-clicking on the VStack and choosing Embed in HStack. So let's see. Actually, I remove the VStack also. So first, I need to put my code inside a VStack. So I do right-click, Embed in VStack. Actually, I need to move the rest inside the VStack, like that. All right. So my bad, I should have kept the VStack. And then I right-click the VStack and I embed it into an HStack, like that. All right. An H stack is a container view that arranges views horizontally, and the V stack arranges the view it contains vertically. So I talked about it a little bit before. There is no change to the interface because the H stack only contains one element, and when it doesn't do anything specific. It just displays that element, but there is nothing else to display. So the H stack is kind of like what we call. You can often hear the word no op for no operation. It's something that's there, but that in the current context does nothing. And then we're going to copy the entire VStack, including the padding modifier, and then paste the code below the first forecast to create a second forecast view. And we update the data to display the next day's forecast. So actually, I should have also kept the padding on the VStack. So I've put it back. And so you can see now I need to add the second VStack. So actually, you can do it by copy and pasting the first one and then changing the data. Me, I'm just copy and pasting from the tutorial so that I don't make a mistake. And you can see what's interesting is that in the code, they are happening one after the other. So they are put together vertically in the code, but in the code, every line is going to be vertically after it's the previous line. So don't be confused by that. They are still displayed horizontally because we've put them into an H tag, So I'm saying this because when you are very new to computer science, you might be confused as to like, why are these two things side by side when they are one on top of each other in the code? It's because in the code, the next line is always after the previous line. Like code is only like it only grows in one dimension. Like you only have lines. You don't have an array with several cells. So it will only always be one after the other. But you can still choose how the views should be displayed and composed on the UI. And here we did it. We did it by choosing an H stack, which makes our two views being displayed one next to each other horizontally. If I change the H stack into a V stack, then they are displayed on top of each other. All right. Next section will be about creating a custom subview. So instead of continuing to copy and paste your code, which is a bad practice, you might hear the word DRI, dry, for don't repeat yourself. Because usually in computer science and computer engineering, if you write the same kind of code more than 2 times, it's sign that you should put it back into a single place so that when you change it into the future, the change will be applied everywhere. Is the idea that I was getting at, and the tutorial was getting at the beginning of this chapter of write something once and use it in several places. We're getting there. So we are going to encapsulate the code to display a day's forecast in its own structure to make a customizable forecast card. So step 1, we're going to right-click the VStack for the first day's forecast. Xcode presents a menu of common actions, and we choose Extract Subview. So Xcode will replace the VStack with Extracted View. Look further down in your code to find the new custom view, which will be introduced by struct Extracted View. And a subview is a view inside another view. For example, in the default code for a new project, text and image were subviews of content view. You might also see the word child view, and you can consider child view and subview to be basically synonyms. I think most of them they will be used to describe the same thing. So let's do that. We select the first VStack and we do extract in subview, and you can see it created a new view here at the bottom of the file, which is then used right here. And of course, I could use it a second time if I wanted. But let's see how the tutorial gets to this point. So in both locations, we're going to rename extracted view to day forecast, so a name that makes much more sense in our context. And by the way, one of the hardest things in computer science is how to name things correctly. It's harder than it might look. So we're going to rename it. So like that. So extracted view here and here is renamed to day forecast. And now, as they were pointing out, anywhere you type day forecast, you'll use all the code you extracted into the new view. So the view that's right here. Now that you've created a day forecast view, you can use it for each day forecast. So we're going to replace the second forecast with another day forecast view. So I'm going to remove this and replace it with another day forecast like that. You can see now they have the same data because they are both using this piece of code. But what's nice is that if I make a change here, the change is reflected in in the two places. So now this right here has become the single source of truth for these two different pieces of UI in my app. So this is quite powerful, and so this mechanism is what's called also factoring code out. You can see the word factorization. It's one of the reasons why computer languages are so powerful, because you're able to create higher level abstraction that you can then reuse, which make it much easier to write code. I know that when I started to learn computer science, I was like, but how can people write such complex systems without making mistake and updating everything, and it all works like so nicely? And then you understand that there is this idea that you can reuse the same thing in different places, and you can customize the behavior of the thing by passing arguments, which we will see just after. And then it's like, oh, okay, you understand how it works, because it's very easy to be super naive when you don't know about it. Like the first time I used an iPod Touch, so back in 2007, so quite a long time ago, like 15 years ago, even more, like 17 years ago actually. And I was like, wow, it's amazing, like all of the apps, they have the same buttons and everywhere. Like how do they manage to sync together the developers to have the same apps all look the same? The reason is because you can create reusable components, and actually when we use text and image, they are reusable components. So that's the power of computing languages in a nutshell. Without this ability to do so, we wouldn't have the complex system that we have today. So let's examine our code. There are three places where you reference day forecast inside the H tag. So sorry, these were two separate sentences. So examine your code. There are three places where you reference day forecast. So two places in the H tag and one in the struct. So inside the H tag, you're creating two instances of day forecast to display on the screen. And at the bottom, you're defining what a day forecast is and what's its content. The word instance here is very important. You can see here the structure as a template. And then whenever you use the template, you create an instance of the template. And so these two things are instances of day forecast. So they are instances of the same template. They are shaped. There are two things shaped by the same mold, to say it differently. And so you define or declare a structure using the struct keyword, and you use or you create an instance of the structure by typing its name followed by parentheses. So this is super important. It's another way to say what I was mentioning about being able to factor code out and reuse it in several places. So now let's generalize the day with a property. So you can use properties to display any forecast data using your custom view. Start by making the day of the week customizable. So right now it's still all hard coded. So in the sense that Monday is written, it's is written like it's spelled out, and it will always display Monday. Let's make this customizable. So we're going to add a new property to the day forecast view to store data about the day of the week. You add a new blank line between the property and the body property below it. So this is a property. So it's something that stores data, is I guess the most generic way to define it. And so they say we do let day equal string. You see why I try not to type, because I make mistakes very easily when I'm focused on also explaining. All right. So you can use blank lines in Swift to make your code more readable. They have no impact on the way your code runs. Important, Xcode displays an error which you'll fix in a moment. So if you have an error, it's normal, don't be alarmed by it. Before you fix the error, let's take a look at the property you just created. To declare a property, we've just used the let keyword. A property has a name, so by using an identifier, followed by a colon, and then the kind of data it holds. This property's name is day, and it holds a string. In Swift, kinds of data are called types, and that's also the case in most programming languages. You can read the code you added to the day forecast structure like this. Day is a property whose type is string. Or you could say day is a property of type string. I just want to say something. When they say that you use the let keyword to declare a property, actually, let, you declare a constant property, so a property that cannot be changed after the instance has been created, but you could also use var, so var, to declare a property that can be changed after the instance has been created. Both keywords, let and var, allow you to create properties. It's just the mutability of the property that will differ depending on which one you use. So now let's look at the error when you first use the day forecast. It says missing argument for parameter day in call. So click the icon next to the message in Xcode to expand it. So that's what I did right here. So when you add a property to a structure, you need to give it a value every time you create an instance of the structure. So every instance of day forecast needs to be told which day it should store. And when you don't, you get an error at compile time. This error means that you haven't given the day property a value. So we'll click the fix button in the error banner to add the argument label day colon. So like that. And now we still need to provide the actual value for the day. So we will replace the placeholder with a day of the week in quotation marks. And so what we're doing here is calling the initializer for day forecast and passing a string argument for the day parameter. So parameter is the value that the day forecast will use inside, and we pass a value for it for the specific instance. But as you can imagine, we will pass a different value in the second instance of day forecast. And it's this ability to pass different values for the same argument in different places that makes us able to use the same structure in several places to cover several use cases. So here I'm passing mon as the string. Okay. And of course, we need to fix the mistake for the second instance of day forecast. So we'll do it, and this time we will pass Q for Tuesday. All right. But you can see the preview still doesn't reload because there is still a mistake in another file of the project. They say it here. The preview doesn't change because you're still passing a string literal into the first text view in the day forecast structure. So, oh yes. So actually there is not an error, but we don't see Q, so for Tuesday being displayed here, because even though we've passed a value for the argument, that value is stored correctly, but it's not used anywhere. We don't use this anywhere inside the body of the view. So it makes sense that the change is still not reflected on the screen. Actually, it's a great example of this distinction I was mentioning between the UI and the model. Our model is correct. We've passed the correct value. However, we don't use the model in the right way when building the view. Here, we don't use the model at all. And so the UI isn't updated. So once again, UI and the UI and the model are different, and you can get one correctly and get the other one wrong, and that happens more often than you would think. So now we use the day property in the text view of the day forecast structure, so the preview reflects the data we added above. So we no longer pass this hard-coded value, but rather we pass the content of the property day. And now you can see the change is being reflected on the screen. And so we've achieved our first example of factoring code out and being able to reuse the factored code out, but with slight differences that we control through the arguments that we pass each time that we create an instance of our struct day forecast. And here we have a note that the day property holds a string value. By using the property as an argument, we can pass its value to the text view because text expects a string, so the types are compatible. Now let's take a look at how the string value journeys from your content view into an instance of day forecast and from there to your interface. So that's great because they're giving like a visual representation of what I've tried to explain just using words. So it will be nice to see this even better explanation. So, okay, I'm hiding the part, but it's not the most important one. The ones that are interesting are highlighted and I'm not hiding them. All right. So you can see that when we create the day forecast, we pass in the value Monday. It's stored inside the property. and then the property is used to display on the screen something. And so, thanks to this journey of the value, if we pass Monday, in the end, Mon is displayed on screen. Same thing if we pass Wednesday or if we pass any other value. And we've seen that when we had forgotten to do that part right here, then the data wasn't, the model wasn't displayed on the screen because we were missing this second red arrow right here. So this one is about getting the model correctly, and this one is about using the model correctly, which, remember, are two very different things. You can get one correctly and not the other, or you can get both incorrectly. This can also happen, but of course, your goal is to get both correctly. All right, now we're going to use int to display temperatures. So we've displayed strings of characters. Now we're going to display numerical values. So we'll extend day forecast to generalize the temperature range. We'll add properties to represent temperatures as numbers using a new type, int, which stands for integer. Then use string interpolation to display the temperature into a text view, because the text view doesn't know how to display an integer directly. This integer needs to be formatted into a string. And there are several ways to format an integer. Imagine like 1000. Do you add a separator between the 1 and the 3 zeros? Do you add a dot and then 0 to say there is nothing after the decimal point? There are several ways to decide how to format a numerical value, even one as simple as an integer. So first, we'll store the high and low temperature as int properties in day forecast. Int is a data type that represents a whole number, and more specifically, it represents an integer, whether it's positive or negative. So we'll get errors like we did when we added the day property, because your day forecast initializers are now missing some arguments. So let's add the high and low properties to the struct. So like that, I've added the two properties. Now, of course, we need to update the call sites, so the places where we create the day forecast and provide the temperature. So I'm going to split the calls across several lines so it's easier to see during the live stream, because we don't have a lot of real estate in the editor. Okay. So you can see, just like before, the values are not reflected because we are still passing hard-coded values here. So we need to use the high and low property inside the body. So let's do that. So in day forecast, we're going to update the text view initializer for the two temperature values. And if we do that, we'll get another error. So let's see. We're attempting to use high and low right here. And we're supposed to get some errors. Yes, they are here. They say no exact match in call to initializer, which can seem quite cryptic when you don't know more about it. So let's try and see what they have to tell us about it. So we get another error, no exact matches in call to initializer, because there's no way to initialize the text view with a numeric value. You need a way to convert a number to a string to pass into a text initializer. You can use a string interpolation to do just that. So what is string interpolation? We're going to change the int values in the text initializers to string literals using interpolation to insert the values of your two temperature properties. If you want to display the value of a number in the text view, which expects a string, you have to change the number into a string, which you do like this. So by using quotation marks and then putting the integer property in between parentheses with a leading backslash. So this seems a bit weird, but once explained, it will all make sense. So like that, and same thing for the other one. What we're saying is basically, this is a string, and then take this integer and turn it into a string. The reason is that in memory, an integer is not stored the same way than a string of characters. And so you need to do this conversion somehow. And this is Swift syntax to do the conversion, which is much nicer than what you would have in older programming languages. And now you can see that we are reflecting the data we've passed. We've lost the contextual information about being the high and low temperature, but I guess we are going to put them back. So indeed, we update our text view initializers to include the high and low labels before the temperature. And so that's why we have this name text interpolation, is because this feature allows us to interpolate other types than strings inside a string. So here we have something that's a string, like here from, oh, actually I'm realizing that part of the code might not have been displayed. Oh, I'm sorry about that. I'm going to make sure that, yeah, the Xcode window was going a little bit further down than I thought. Okay, you should be able to see everything now. So this is a string, and then in this string, we are interpolating this value. So we're turning this value, which is a number, into a string and putting it into a string. And then we could also add other stuff after if we wanted. So that's a really convenient way to put more complex data types into a string and to interpolate them within a string. So hence this name of string interpolation, which might seem a bit weird when you don't know where it comes from. What do we do next? Let me check. What do we... I didn't mean to do that. I wanted to go back to the tutorial. All right. That's the one where you can see that I'm starting to get a bit tired because for me in France, we're getting close to 10 p.m. And so we're getting close to the end of the day. Hopefully, we'll also get close to the end of the chapter. And so experiment. Try changing the text in the surrounding the text surrounding the interpretation of the temperature. For example, we could type the degree sign if we wanted. So you can use Option O to do it if you use a US keyboard, I guess, because me, I have a French layout on my keyboard, and I can do Shift and the closing parenthesis, and I get so not here, I get the degree sign. And this is a great example of adding text after the interpolation. Much better one than what I had done of just typing gibberish. So good on them to have suggested this. All right. Then we'll use computer properties for the icon and the color. So we're going to add another property that uses a boolean, a value that is either true or false, to compute what appears in the image view. We show a rain cloud if the value is true and the sun if it's false. So we are in a world where the weather can be either super sunny or super rainy. It's simplified, but it will do the trick. So we add this new boolean property. So remember, boolean means that can be either true or false. So it's like you have only one bit of information. It's either true or false. And I say bit in the sense that it's 0 or 1. So it really takes only a single bit when you want to store this into memory. So like that, let is rainy of type bool for boolean. All right. Then we have our good old errors to address. So we need to pass a value for the argument is rainy when creating the day forecast. I'm going to put them back on several lines. And you can see the first one is not rainy, but the second one is rainy. Okay. Now, how do we choose the icon that we use depending on whether or not it's rainy? That's what we're going to do next. And here we have a little note that's important, that the order of the parameters in the initializer matches the order of the declarations of their matching property. So you can't add the new argument at the end as you did before, and the order does matter. So that's why they didn't make us add the argument at the end to show us this nice little subtlety. So because the isRainy property is a bool, you need to write code for what to do when the value is true and when it's false. To do this, we're going to create what's called a computed property that represents the icon names. What's a computed property, you might ask? It's a property that doesn't store a value directly, like the store properties we declared earlier right here using let. Computed properties use the var keyword because their value may vary depending on the result of the computation. So you can think about them as values which are created on demand every time you ask for them. Just one thing that I want to point out, because here they oppose using var to create a computed property and let to create a stored property. That's true. However, it's like when you want to create a computed property, you can only use var because it can change at every call. But when you want to create a stored property, you can use either let or var, depending on whether or not you want it to be mutating. Let will be non-mutating and var mutating. So here, they make it kind of sound like there is like strong opposition between var for computed properties and let for stored properties. It's not the case. It's more subtle than that. You can only use var for computed properties, but you can use either var or let for stored properties depending on whether or not you want them to be mutable. So I wanted to point this out. It's one of the very rare flaws of the tutorial up until now. They've done a really great job. It's the only flaw I've been able to find in the explanation up until now, but they've really done a great job of it. Okay, so let's add this new compute property called icon name, and apparently we're going to get an error. So missing return in accessor expected to return string. All right. So code that computes a value must provide the value using the return keyword. And what's accessor? It's another name for a compute property. It's kind of like its scientific name for the compiler. You know, just like when you have like animals, they have their regular name like cat, dog, and then there is the scientific name in Latin. It's kind of the similar thing. And so we're going to start by saying, okay, the icon name, we will just say it's always cloud.write.field. So it's always going to return this string when you call the property icon name. All right. So if we remove the return keyword, what's going to happen? Actually, it's still going to work. Why is that the case? It's because Swift encourages programmers to remove the return keyword if the code is simple enough. And by simple enough, they mean if it only contains a single expression. You can choose whether to include a keyword to remind yourself of the function of the code or to remove it for conciseness. Here you can see that there is no return in the body, and the body here is also a compute property. So we can leave it or not. I will just leave it for now, but you can remove it if you want. So then we will replace the string literal sun.max.fill in the image initializer with a reference to the new icon name compute property. So let's do that. I don't really like that they use the word reference here because it's more like we are calling the property. I get that they say a reference in the sense that we refer to the property, but a reference has a very specific meaning in Swift. So I don't like the way they use a reference here. And if you ever hear reference types and value types, this is not the meaning that's used here at all. Here they just say that it refers to it, so it uses it. You can see it's used in the same way than using the compute property. And so now we have two yellow clouds because, yes, we have replaced the hard-coded sun icon with this property, but it always returns the same value for now. So we still need to return the correct icon name depending on whether it's rainy or not. So let's do that. And so we're going to remove the simple return statement, and instead we're going to add an if-else statement to return the correct icon name based on the value of the isRainy property. So let's add the code, and then we will read the rest of the explanation. First, we can see that now it's working. So we have the correct icon. It might not make sense to have a yellow color for rainy, but I guess we're going to take care of it just after. So what does this code do? If the condition is true, Swift will execute the code in the braces following the if, so this path right here. And if the condition is false, Swift executes the code in the braces following the else keyword, so this code path right here. So like the simple return statement, you can choose to remove the return keywords in the if and else, so you can remove it like that. You can see that it still works correctly. And finally, so as I was saying, as I was foreshadowing, I should say, the color of the icon also depends on the isRainy property. So you can follow the same pattern to create a second compute property for the icon color. Use another if-else statement to return the correct color depending on the weather condition. Then replace the color yellow value in the foreground style modifier with a reference to icon color. Here, I would prefer we use with a call to icon color than a reference. And once it's done, we will have successfully encapsulated the full expressiveness of a forecast card, so the day forecast view, in a custom view. You can add one or two more cards to see how easy it is to add new ones to the parent view in which we use it. So let's try and do it like that. So something like this. So icon color, okay? And now we can use the icon color instead of the hard-coded color. And you can see now it's blue when it's rainy. So that's perfect. That's pretty good. Sorry, once again, I didn't meant to do that. That's pretty good to be honest. And so now if we want to add a new day forecast, we can do it super easily. So let's add a Wednesday. Wednesday, we are back to being not rainy again. And let's change the temperature a bit. I have no idea how Fahrenheit temperatures work. I guess this would be quite 500 degrees is not good, even in Fahrenheit. Okay, I don't think this is realistic, but at least it allowed us to add a new day forecast extremely quickly, thanks to the fact we have encapsulated the UI logic of a day forecast into this day forecast subview or child view. All right, guess we should be near. We are almost at the end. Last section, I guess, is to, let's see, no, 7 of 8, there are still 2 left, is to style the custom view. So now that you've made a custom subview for a forecast card, you can easily adjust the style, font, and padding of its elements and see the changes in every card. So in the body of your day forecast view, we'll add a line below text day, then begin typing font and pause to let Xcode display code completion suggestions. So I think we need to go, where do we need to go? We need to go, so here, here, and start to type font. All right. Then what do I do? So we see indeed, we see this, okay. Choose font underscore font colon from the code completion suggestions and press return to insert into your code. So the first one, okay. Then type to replace the highlighted placeholder with font.headline. So like that. You can see something changed in the way the text is formatted. Now it seems to be a little bit bigger and a little bit bolder also. So some code completion suggestions like caption and title are semantic values. So they meant the other options we had here. So headline, caption, we also had title, but we chose to go with headline. So what does it mean to be semantic? It means that their name indicates how the fonts should be used in your app. So you're saying this is a headline, and then it will display a headline with the appropriate style, which maybe might be a bit different depending on whether you're on macOS, iOS, watchOS, visionOS, etc. So you can try using different values for the font modifier. So for instance, we can use title, which will be way better. All right. We can use a large title, which is even larger, or we can use caption, which will be much smaller than just using nothing. So you can see this way you can add some formatting, some styling to the text. All right. So, oh yes, 10 p.m. almost. My goal is to finish close to 10 p.m. because after that I can feel on my voice that it's a little bit long. So it seems that the timing is pretty good on that one, but perfect. All right. So then we use the font large title to increase the size of the image. So why can we use font to increase the size of an image? It's not magic. It won't work with any kind of image. It's because here the SF symbol is a font. So it's already a vector image which you can make larger without any problem. That's why we can use things that are more part of a font, even though it's an image, because it's a character font under the hood. Actually, I think they are already explaining it just right here. So they say that because SF symbols are often used in conjunction with text, you can adjust their size using semantic font names. They're designed to work at many different sizes and weights. And they would go even further. It's because SF symbol, I think, is a font, or at least it's available as a font if needed. Maybe it's not always used as a font under the hood by iOS, but it can also be used as a font if you want. And SF symbols works automatically with dynamic type, so they will scale appropriately when people adjust the text size on their device. Let's try to do it. We actually did it at the beginning, and you can see that if I make the text much bigger or much smaller, everything scales together, including the image, which is quite nice when you think about it. Then we're going to use the font weight modifier, so a different one, to change the weights of the high and low temperatures. We can experiment with different weights from the code completion suggestions. So let's see. So here we can do font weight. And then you can see we have, for instance, bold. So it looks similar to the day of the week. maybe we can go for something like medium, which is less strong, or semi-bold, which is a bit stronger than medium. So maybe we can go with like a semi-bold, I don't know, maybe with medium. I guess we should go for the same for both. It would make sense, maybe. I don't know. No, actually, they do semi-bold and medium. So we'll do two different ones. You see? You can see it's subtle, but there is a difference. It's easier to see when you go from one to the other, but there is a difference. Might be harder to see with the video compression or if you're on a small screen, but there is definitely a difference. High is a bit bolder than low. Okay. So the font weight modifier changes the weight of a font without affecting its semantic meaning. So the way using body or headline would. So it doesn't change what it means. It's like you make it look like maybe a title, but it's not a title under the hood. And what you pass as the headline, for instance, I think voiceover, if you use the feature to read the voice, so for people who have like difficulty in viewing difficulties, I don't know how you say it. I think visually impaired is the correct word in English. They can use VoiceOver to have iOS or read the content of the screen to them. I think it's able to use the headline to know what should be read first and what should be read only after. But I'm not 100% sure on that one, to be honest. And then we're going to use the secondary system color for the low temperature. So that's what you use for less important information. So a way to structure information by giving different style to different information according to different pieces of information according to their importance. So we do here foreground style and it will be secondary. And you can see it becomes a little bit grayer. Usually apps in their UI design system, they will have what's called a primary color, a secondary color. And the idea is that primary color is used to display the main text and secondary to display text that is less important. It's kind of like also you will have maybe a primary action color for the button, this kind of thing. Similar to how we have different colors here for the code in a way. It's a way to provide some visual clues so that at a glance, the user can understand what is the important information, what is the less important information. It's a way to give a visual structure of the information. And so by default, the secondary color is this kind of light gray that we can see being used right now. And finally, we're going to add a little padding to the icon. So we're going to add a padding of 5. So we can provide a custom value for the padding if we want. So here we say it's 5 points. So that there is a bit of space on the top, on the bottom, also on the left and the right, which is less visible because there is nothing on this side, but you can see it's been added to all edges. Of course, you can specify only a specific edge or a specific set of edges if you want it to apply. For instance, you could apply the padding only to the top and trailing edges if you wanted. It's possible, or only the vertical edges or only the horizontal edges. You have control over this through the different arguments that you can provide in the different overloads of padding. Oh, actually, last section is the quiz. So we are almost done. All right. Let's do the quiz. So what code creates an instance of the following view? So we have a struct person avatar. We have three properties: name, image name, and color, and then the body of the view. So like this, person avatar with argument labels, person avatar without argument labels, or person avatar with this weird syntax. Actually, it's the same than here, but the colons and the commas have been switched. So the correct one is, of course, this one. You need to provide argument labels. Actually, what's happening here is that when you create a struct, you get an automatically generated initializer that takes all of the properties in the order they were declared and that adds external names, so argument labels for each of the arguments. If you wanted, you could create your own initializer and ignore the argument label so that you don't have to provide it. It's considered a good practice in Swift to use the argument label because it makes it much more clear what the role of each argument is. So I would really recommend that you keep this built-in behavior and Still, regardless of your choice, for this code right here, this is the correct way to create an instance of person avatar. So I'm going to submit this answer. And indeed, I was correct about it. So you need to pass arguments for each of the properties. And you also need to provide the property name in the argument label and provide the arguments in the order in which the properties have been declared. Next question. A property can have a value that changes based on other data. So yes, we saw it, and it's what's called a compute property. So a property whose value is computed every time you call it, and it can use other properties, other pieces of data to decide what to return, and that's what we use to have a different icon and a different color depending on whether the forecast was it would be raining or not. So it's indeed true, and you use a compute property to derive a value from another property or other properties or other things, like it could be like the hour of the day, things like that. And last question, how do you insert values into a string? So remember string interpolation. So which is the correct syntax? So you might remember it's the first one. It's backslash and then parentheses in which you put the value that must be interpolated. So it's the first one. And here there is no trick. Like they could have all been potentially correct syntaxes. I mean, not this one, I guess, but they could have all been correct syntaxes. Just Swift decided that this is the correct syntax. So it's the first one. And it's the backslash parentheses sequence that inserts the value of its content, so what's inside the parentheses, into a string. All right, let's do the recap to finish. So wrap up about views, structures, and properties. And let's drink a little bit more apple juice. Let's reflect on how we used a structure to create a custom view, and we unuse properties to pass arguments to the view's initializers to customize each instance. So let's reflect on the concept. Structures represent a fundamental activity in programming, reusing common patterns of code. By creating a custom forecast card structure, actually it was day forecast, not forecast card. I think they iterated on the tutorial and they forgot to change the name everywhere. But that's actually a great example of why you want to have encapsulate code, because this way when you change it into one place, you change it everywhere, which is not the case here because there was no encapsulation. You had two different pages, and when a change was made on the first page, it wasn't reflected on the second page. So actually it's a mistake, but in a way it's a greatly timed mistake. So by creating a custom day forecast structure, we group the view's code and related data, saving ourselves time and reducing the potential for error. Here we group the views code and related data. The fact that we stored inside a single unit data and logic to operate on the data is also very, very important and a big part about what it means to factor code out. Usually, you want to factor together data and the logic that operates on the data. You want to put it together into a tightly knit concept, which is here a structure. Structures are general purpose tools for organizing any type of code. As a developer, you'll need to store, display, send, and receive data in your apps. You'll use structures to create models for this data. And you can see that they use the word model here for the first time, I think, but I've used it several times during the live stream. So you might have heard it before if you paid attention to what I was saying, I guess. So I hope that you've heard it before, you've remembered it, but it's nice to see Apple also using this terminology, which is like the way that people refer to data that reflects the state of an app. So which topic and skills were covered? Using a structure to make a custom view, creating instances using a structure's initializer, customizing each instance of a structure using properties, the string, int, and bool data types, which are the most basic types you can use to represent data, and compute properties, which change data based on a condition, or rather, which might return different data based on the current state, because a compute property might also return the same data. It doesn't need to change every time. It's like it computes and returns a value on demand, but this could be always different. This could be always the same. This could depend on the condition. There is no fixed rule for what you do inside of a compute property. And so what can you do if you want to keep practicing? First, you can expand the app we've written. You can experiment with the style of the forecast cards by modifying the spacing, the font, and the colors, like we did a bit. You can add more days to the forecast, like I did at the end. If you run out of horizontal space, wrap everything in a VStack and group the cards in multiple HTAG containers inside, or look into scroll view to be able to scroll content, which is a great way to go further. You can also create a new custom week forecast view that displays a date range and the summary for the week. So the average low, average high, and number of days of sun and rain. So basically gaining one level of abstraction because we put the content for a day together, then do the same thing for a week. And as you can imagine, the week will be composed of days. So that can be a great way to go further. And if you want to change yourself, you can practice using commit properties. For instance, adding a commit property by adding a commit property to return different colors if the high temperature is above 80 degrees, so high greater than 80. You can use the foreground style modifier to change the text color depending on the value of the property. For instance, put it in red if it's above 80 degrees, which I guess is, I don't know, maybe the equivalent of 30 or 40 Celsius degrees in Fahrenheit. And you can practice creating custom views. So you can also go back to the project we did in the previous chapter, so the chat prototype project, and create a new view named chat bubble and use properties to represent the bubble's text and color, and use your custom view in the content view. So by reusing the text bubble several times, just like we did with the day forecast. So I think that concludes this first video of the series. So next time we'll cover layout and style in more detail, and I guess also button and state, and probably the week after list and fields. So it's been 2 hours, just like I wanted. Perfect timing. I just have to say, so thank you for watching. Thank you to the people who watched live and who asked great questions and made great remarks, because every time they brought some points that I wouldn't have thought myself of bringing. So a big thank you to them. And finally, if you are indeed getting started with iOS and you've watched this video up until right now, which is the end, don't hesitate to tell me in the comments what is your honest feedback. What did you like? What did you not like? What would you have liked me to explain a bit more? Maybe all of the things that can help me better understand what I can improve and create better content, better other and better beginner content. And if this content has been helpful to you, don't hesitate to also share it with other people you might know that might want to get started with iOS, because if it's been helpful to you, there is no reason that it won't be helpful to someone else. I think I've said everything I wanted for the outro. So I just have to say thanks again for watching, and see you next week or in the next video if you're watching the replay for the next part of this series of video about how to get started developing iOS apps with Swift and Xcode. Thank you for watching. Bye-bye. See you next time. Hello, what's up everyone? Welcome to the second part of my tutorial, of my series of tutorial videos on how to start developing iOS apps with Xcode and Swift. So this series of videos are for complete beginners, people who want to start developing iOS apps but don't have any prior experience in doing it. And in order to learn how to do it, I'm using a resource actually made from Apple. So a tutorial that Apple released a few weeks ago as of when I'm recording this video, so end of April 2024. So you have the link of the tutorial in the description of the YouTube video. Of course, I encourage you to check it out as you are watching this video. So as I was saying just before, this is part 2. So of course there was a part 1 before. Part 1 was recorded last week, and we covered these 2 chapters. So exploring Xcode to learn how to use Xcode. Xcode being the software development tool that you use to build iOS apps, but also macOS, watchOS, visionOS, any kind of apps for the Apple ecosystem. And then we saw how to build a very simple UI using SwiftUI and how to make this UI customizable. Today, we're going to see how to build more advanced, more complex pieces of UI, and we'll cover chapter 3, how to lay out and style the UI, probably chapter 4, buttons and state, and if we have time, I would also love to cover chapter 5, lists and text fields, but if we don't have time, it will be for a third video. Before we start, just as always, this is being recorded live. So if you're watching live and you have any question or remark, you have a chat that's available for you. Please write your questions, write your remark in the chat, and I will do my best to try and answer them. That being said, let's actually get started. So I'm just gonna make myself a little bit smaller so that I never cover the code, because the code is the important part in this series of videos. So let's get started, and we're going to start chapter 3, layout and style. So we're going to learn how to design an interface, and we're going to practice putting views where we want them and inspecting their size by building 2 onboarding screens for an iOS app. As you code, play with your own layout, color, graphics, and text to make this project meaningful to you. So I see a few people. Hello from Brazil. Nice to see that we have people watching from another continent. And button and states is where you're stuck at in the playgrounds. All right. So hopefully I'll be able to unstuck you, and it will be just after this chapter. All right, so section 1, we're going to create a welcome page. So we start a new project in Xcode and create a new SwiftUI view. So if you followed the previous video, you know how to create a new project in Xcode. So you open Xcode, you do new project, and you create a project called onboarding flow. So actually, I've already opened Xcode. So it's there. So onboarding flow, make sure you have a SwiftUI interface. All right. I'm gonna put it on my desktop. Okay, the project has been created. What do we do now? I'm gonna hide the preview for now. So I did that by doing Command, Alt, and Return. By the way, that's the shortcut to do to hide and show the preview. Okay, so then we need to create a new SwiftUI view. So we do Command N here, and then SwiftUI view. All right. How do we call this new SwiftUI view? We call the file welcome page, and then we click on create. So it added a new SwiftUI view, and you can see that we have all of the boilerplate, so the necessary code in order to have a simple SwiftUI view. If I put the preview back, we'll see the preview rendering just the text that says hello world. Yes, we have it right here. All right. So in welcome page, we're going to replace the code inside the body with a title. And we're going to use the font modifier to increase the size and make it stand out. So as I said last week, I copy paste the code because it goes faster and it prevents mistakes from happening because I have to focus on different things. But if you're doing the tutorial, please don't copy paste. Try to write it yourself, because it's likely that it's your first time writing Swift code, and it's really important to learn by doing. So please don't do like me. I'm just doing it because I want to save time and I don't want to spend lots of time writing code. It's not the most interesting thing I can do. It's more interesting if I spend my time commenting what I'm doing. Okay, I'm making the preview a little bit bigger so that you can see it. Yeah, something like that. Okay. And they say experiment. You can try out different fonts for your message by deleting the title, so here, and choosing different options from the code completion menu. Notice the different sizes and weights, and think about how you might use the various options in an app. So remember, in order to open code completion, you use the escape key, and you can see we can choose headline, for instance, which is a bit smaller. We have title, a bit bigger. We have also large title, way bigger. We have caption, way smaller. And they all match the role that the label has in the screen. So these different presets for font it's a way to be able to nicely organize and hierarchize content on a view by making the title bigger. And basically, the more information is important, the bigger it should be. And the less, not really important, but the higher it is in the hierarchy and in the structure of the app, the bigger it should be. And the more it gets like towards the actual content, the smaller it should be. Like you want to have your title to be big and the text of an article to be small, basically, and not the other way around. So then we're going to refine the code by removing the font type name from the argument. So we can actually remove the name of the type where the property title has been declared. And the reason why we can do this is because the font modifier requires its argument to be of type font. You can abbreviate font.title to just .title. This is called type inference. This means that when you compile your code, the compiler is able to infer that here you're talking about the title font. Because since this modifier expects an argument of type font, then it makes sense that this property, you are looking for it on the type font. And so what's happening is that the compiler is going to try and is basically going to say, okay, the compiler says, so this doesn't build, but if I add font, then it builds, and so it's satisfied. Of course, if you were to use something that doesn't exist on font, like title big, for instance, you get an error because this doesn't exist on font and it doesn't exist anywhere that the compiler can infer. But this feature of type inference, when you're new to computer science, it actually seems quite natural, but it's something that was added to programming languages that are used widely quite recently. I mean, I say recently, but Swift is almost 10 years old. But like in the language before Swift, which was Objective-C to develop for Apple platforms, you didn't have this feature. So this is very convenient, but it's also quite recent because like the implementation behind it and the math behind it is not trivial at all, actually. I won't go into the details, but doing type inference, like being able to infer the missing part, it's actually kind of the same thing than filling in the blanks in a mathematical demonstration. It's actually exactly the same thing because of some mathematical property. I won't go into the details of it, but just mentioning it to give you an idea of the fact that it's not trivial at all, especially when you get with code that is way more complex than what we have here in this simple example. Then we're going to emphasize the title using the font weight modifier. So you use type inference here too. So here you can see we just do dot semi-bold and not font weight dot semi-bold, for instance. In this case, Xcode infer the type font dot weight. So weight is a type which is nested inside the type font, which is the required type of the argument to font weight. So let's try and write this so that we really see it. So you can see font weight, it expects an argument of type font.weight, and font.weight defines several static properties, and including one called semi-bold. But if we look at it, we can see that they are all static properties defined inside the struct weight, which itself is defined inside the struct, inside an extension of font, which is a way to add stuff to the type font, but after its initial declaration. I see an interesting comment. It says, the little I've read about previous languages to Swift, the more horrific it seemed. So glad to have started with Swift's quality of life. Yeah, and Objective-C was actually improved around like the first time around 2008, something like that, when there was something called like, I think it was either like modern Objective-C or Objective-C 2.0. There was already like one nice addition to the language which added things like properties and synthesized properties. And then there was a second improvement, which I think was the one called Modern Objective-C, which added stuff like being able to subscript an array. Because originally in Objective-C, you couldn't subscript an array by doing like angle braces. You would need to call the method object at index. And same thing, to create a static array, you would need to call the method nsArray, array with objects, and then pass a list of objects. It was very roots, very like low level. I mean, back when Objective-C was introduced itself, it was a significant addition on what was before. But that's the thing. Like in 10 years or 15 years, Swift might still be there, and it will probably look very old compared to the language that will come after it. But when they introduced Swift in 2014, you can have a look at the video from WWDC with Craig Federighi that is presenting the language. He compares it to Objective C, and they show like how smaller the code is compared to Objective C, and it's very similar to the dynamic of UIKit versus Swift UI. You have this very similar vibe with it, and it's kind of nice to have a look at it just for like. It's more of like for historical understanding, but I encourage you to have a quick look at how Objective C look like. Okay, so and let's say experiment, change the look of the text using the font width or font design modifier. So let's see, what does font width do? So font width, so you can say like compressed to put the letters together a bit more, or condensed, which is a little less closer, or expanded, so that they are like further apart. So here I'm less, I mean, knowing when to use each of these width is more of a designer job, and I'm not a designer, so I'm less experimented on when you should use them or not use them. But it is good to know that they exist. So we've tried font width, and the other one is font design. This one I've never heard of it before. Oh, so it's like you can have a monospace version. Okay, that's what they call a design. That's great. So monospace is useful because it means that each character will have the same width, which is not the case by default. You can see that, for instance, the L takes way less width than the C. In some cases, it's nice. In some other cases, it's not what you want. Typical examples are actually the font used to write code. They are almost always monospaced because you want that one character always takes the same width. If you try to write code in Google Docs or in Pages or in like a word processing software, it always feels weird, and that's one of the reasons why it feels weird. Is because the font you're using by default, like Calibri or Times New Roman, they are not monospaced. Okay, so that's what the design is. So we have monospaced, we have rounded also, okay, which gives like a rounded endings to the characters, rounding like not edges, but like the pointy things at the end. Serif, which adds serif, which is to have this little, well, I guess they're called serif in English, at the end of the character. You know, things that make it feel very much like this is very typical of like of trying to make it so you can see it. Yes, like that. This is very typical of written newspaper-like text. Think of the New York Times, for instance. I think the New York Times is written in a font similar to this one. And default, which here would be the without serif version. Same thing. I'm less familiar on when you should use each of these variants, except that monospaced is more appropriate for code, and serif is more appropriate either for things that's written down or for text that wants to feel like something written down. So it's possible that, like in an e-reader app, for instance, you would use a monospace font. I'm not sure, to be honest. I'm not. I'm not sure. It's a designer's job, and I'm not a designer, so I won't go into that territory because I don't know enough to give a good answer or rather a good explanation. All right. So then, section 2: inspect the size of your views using borders. So we're going to explore how SwiftUI lays out views and how modifiers affect layout using the modifier border. A border outlines the area a view occupies. So we're going to wrap the existing body content in a padded VStack by right-clicking and choosing Embed in VStack, then adding the padding. Okay? So right-click on text, embed in VStack. So remember, a VStack is a way to stack several views together vertically. And we add a padding around it. So for now, the padding, I mean, you don't see it because it added extra transparent space, but you can see if I don't have the padding, it stops right at the edge of the W. And if I put it back, then you can see that there is some extra padding. So it's working, even though you can't really see really see the difference for now. Okay, and then we're going to add a description below the title using another text view and a font modifier of our choice. So here they chose to use font title Q. And so the two views are stacked vertically because they are in a VStack. I'm saying it because since they are stacked, and since they are written one on top of each other in the code, someone that is a beginner might think that that's the reason why they appear on top of each other, but no, it's because they are in a VStack. If I use a H stack instead, they are put one next to the other, but in the horizontal direction. So important distinction to keep in mind. So they say once again, try making the description string long enough to wrap to another line, then use the multi-line text alignment modifier to change the way the text is aligned. So just going to copy and paste several times like that. And so it's better like that actually. Yes, better like that. And so if we do text alignment like that, you can see that by default, it's leading. So align with the leading edge, which is the left edge because we are using a language which is written left to right, but I could also do trailing and center. So something that you should already be familiar with because this feature has been in basically every word processing software since like for decades. So I don't remember using a word processor that didn't offer this feature. So I think you already know how it works. I don't need to explain it. But think that there was a time when having this feature of centering the text in a word processor must have been amazing because before then, like people were writing text in the terminal and you couldn't necessarily like center the text. So at one point, this was also something straight out of the future. I'm going to put it back to having just description text like that. Then we're going to add borders to the text views, specifying a border, a color, and border width. So a text view's default size is exactly enough to contain its content. A view's default size is called its ideal size. And borders are great tools if you're having layout issues or if a view isn't behaving as you expect. Sometimes the actual boundaries of a view don't match the edges of its visible content, like we had before when we had the extra padding. And if you were not aware there was a padding, there wasn't any visual clue to help you see it in the UI. So we've added the black border around the first text. And now let's add the second black border around the second text. Of course, you can change the color, maybe making it like more red, for instance. Totally doable. Okay. And then we're going to add borders to the VStack before and after the padding modifier to see the size of the view with and without its padding. Very interesting approach. So I'm replacing the line padding with what I've copy pasted. And you can see in orange, the size of the VStack before the padding, and in purple, the size of the VStack after the padding. By the way, when we say the size of the VStack after the padding, it's a bit of a simplification because calling padding returns a new view. So it's not the size of the VStack with the padding, but rather it's the size of the view created by applying the padding to the VStack. We say that it's the size of the VStack with the padding because it matches more what we see visually when we look at the code. But technically, it's important to understand that whenever we call a modifier, SwiftUI returns a new view. So here it returned a new view where we added a border, then a new view where we added a padding, then a new view where we added another border. It's important to have this distinction in mind. I won't go into the details of it, but if you want to learn SwiftUI in more details, I have a series of videos on my channel called Learning SwiftUI When You Already Know UIKit. Actually, it's mostly you learning SwiftUI when you already know a bit of iOS. So after watching this series on how to get started from scratch, you can go watch this other series, which goes much more into the details of how SwiftUI works. So we've added the border, and they say that the VStack also has an ideal size, one that exactly encompasses its subviews. And you can see in orange, it's the ideal size of the VStack. what's interesting is that the text so has an ideal size because of its content, which is a string, and then the VStack has an ideal size, which is a function of the ideal size of both its of its subviews. So we can see that there is this very recursive way of defining how ideal size are computed. Step 5, we're going to complete the welcome page by adding a graphic using a shape and an SF symbol. So we start by adding the shape. So we add a rounded rectangle, which is one of the kind of shapes available in SwiftUI. I'm gonna make the view a little bit smaller, and you can see that it took a lot of room in the screen. I'm sure there is an explanation for this. So if you're using rounded rectangle, you'll need to add corner radius as an argument. A value of 0 creates a 90-degree corner. Higher values make a more gentle curve. So here I put 30, and you can see if I put 0, it's back to an angle, a 90 degree angle. I think it's called a straight angle. I mean, in French, it would be called a straight angle. I don't know if the term is if the word is the same in English. Don't hesitate to let me know. You can see 30 is rounded, 15 is slightly less rounded, and 45 is even more rounded. So I'm going to leave it at 30. And now the explanation of why does the rounded rectangle, so it's right angle. Okay, so in French we would say angle droit, which it's also a direct translation. So it makes okay. There was no trick at all actually. It was just like the English, I mean the French word translated into English. Good to know. So why does the rounded rectangle takes so much room on the screen? That's because they say that your shape, so the rounded rectangle, stretches horizontally and vertically to fill all available space because shapes in SwiftUI don't have an ideal size. In turn, the enclosing VStack increases its size to contain the shape. Only the stack's padding prevents the shape from extending to the edges of the screen. So the way this works, I'm going to try and explain with my own words. And once again, you have a more detailed explanation in my other series of tutorials on SwiftUI. It's that what's happening is that when the body is rendered, it can take all of the screen, or rather all of the safe area, so the part that's in purple. Then the padding takes a bit of that space away. So the view that's inside has a little bit less room to render. So you can see that's why its border is in the orange area. And then the VStack is given the space in the orange area. And what it does is that it first gets the size of the views which have an ideal size, so the text here and the text there. And then the size, the space that's left available, it gives it to the rounded rectangle, which says, okay, me, I'm going to take everything. So that's the gist of how the layout algorithm works. The parent view proposes a size to the child view, and the child view says, all right, I'm going to take this size, and the parent takes that into account and proposes the space that's available, but that's left available to the second child view, etc., etc. The only thing is that it doesn't necessarily happen in the order that they were written, because of course the rounded rectangle needs to decide the space it occupies after the two texts have given their ideal size. Otherwise, rounded rectangle would take all of the space available, and the two texts wouldn't have any room left to render. And once again, in my other series of SwiftUI tutorials, you have a much more detailed explanation where I take more time to explain this topic, which is a bit more advanced. So that's why I'm not going to cover it in details in this beginner tutorial. But still, it's important to give an idea of like when you're learning, it's important to learn the basics, but also to know where you should look at when you want to learn more. That's why whenever there is like I can give you a pointer to learn more, I try to do it. Okay, so step 6, make your shape smaller using a frame modifier. So a frame allows you the frame modifier allows you to specify the space available to the view. So here we're saying, okay, here you should occupy a space of 150 by 150. And this way, we kind of like what should be the correct word? We give an indication. We express a constraint to the rounded rectangle view on how much shape, how much space it should take. Then we're going to use the accent color for the shape's foreground style. So foreground style, and then we use the tint color. So this allows us to color it with the tint color, which is blue by default. That's because buttons, for instance, are blue by default in iOS. If you hadn't noticed it, next time you use iOS, and you will see that most system apps, like settings, for instance, they have blue buttons, if I'm correct. Some Apple apps have different color for the buttons. I think, for instance, Apple Music might have more like red-orange buttons because that's the color of the Apple Music app, actually. Maybe the TV app, the Apple TV app has white as the color for the buttons because it's very black and white, but I'm less sure for this one. But basically, that's what the accent color is. It's the color for all of the primary actions in an app. And same thing if you've never noticed it, but in an app, all of the primary actions tend to use the same color this way. When you see something of that color, you know intuitively, without having to think about it, that indeed this is something that you can interact with. And mobile apps, they are filled with this kind of like small hints that are dropping at you. So that's one of the things that makes mobile apps very easy and intuitive to use. And actually, oftentimes when you try to design an interface yourself and it's not your job, you make the mistakes of not following these patterns correctly. And when people want to use your app, it feels very confusing and very like unwelcoming. And that's actually the reason why apps can feel that way. Okay, so next step will be to use padding within stacks. So the amount of space SwiftUI gives views in a layout depends on their order, their types, their modifiers, and other factors such as dynamic type, which is the ability for the user to ask for bigger or smaller text. In this case, the automatic spacing of the VStack puts the title close to the shape above it. You can use the padding modifier to give the title more space. So we're going to add a padding to the title, so like that. And you can see we need to add it before the black border, so like that. So it gave more space around the title, both on the top, bottom, leading, and trailing edges. Let's see. By adding the padding before the border modifier, you can see the boundaries of the text view along with its padding, indeed, because the border is applied to the space occupied after applying the padding. Remember, the order of modifiers matters. Remember the analogy. Putting your socks first and your shoes second is not the same as putting your shoes first and your socks second. Same thing here. And we can restrict the padding to only apply to the top edge of the title by specifying which edge it should apply to. So we can say it should only apply to the top edge. Once again, because of type inference, we don't need to type edge.set.top. We can just write .top, and Swift is able to infer the rest. And they say, experiment, the 4 edges of a view are leading, trailing, top, and bottom. Try different kinds of padding on your views to change the design. You can use multiple successive padding modifiers to provide different values for different dimensions. So for instance, we can say, we can provide the value of, for instance, 16. So I'm making the padding bigger and even bigger. Whoa, it was way too much. But you can control both the edge and the value. And you can also do things like top and leading like that, for instance. And you can see it pushes the content back to the bottom right corner, or rather the bottom trailing corner. So I will put it back as it is. I really encourage you to experiment with this because it's quite interesting and it shows the flexibility of the padding modifier. And if you look at the signature, it takes as argument the edges, which can be one edge or several edges, and then the length of the padding. Okay, section 4. Use a Z-stack to embellish your graphic. So to add an SF symbol on top of your shape, add an SF symbol on top of your shape using a Z-stack. A Z-stack arranges views on top of one another. So we knew about V-stack and H-stack. Now we also learn about Z-stack, which puts views on top of each other. The reason why it's called Z-stack is because you can imagine on your screen you have the X like that horizontally and the Y order vertically, while the Z-stack is the one that goes from bottom, from back to front. So from back to front. So it's called the Z axis. And so often you can see also the property Z order to say what's the ordering from back to front. And so that's why the view is called the Z stack. Of course, on an iPhone, this all gets flattened. But for instance, I guess in a Vision OS app where you can have a sense of depth, a Z stack, you could even see the depth between the elements. You could see the depth between the elements being more visible. And also, I'm not sure actually if it works, but I know that on the Apple TV, on some of the buttons, you know that when you have a button selected on the Apple TV, if you move your thumb on the touchpad, you can see the button moving slightly. You're not selecting the next button, you're just moving the button that you are currently on. And you can see that there is a kind of a parallax effect. So I don't know if this tag gives you this parallax effect by default in when you use SwiftUI for the TV app, but if it's the case, it would be pretty cool because this effect, like the first time I saw it, I was like, "Whoa, that's super cool!" It gives a very much of a very high end, very polished feeling. So it's really nice. So we're going to embed the shape, so the rounded rectangle in a Z stack. So we do embed or right click embed in Z stack like that. Okay. Then we add an SF symbol to the stack below the shape. So as you can imagine, the order is going to be important. So we can see it's appearing. Okay. And then we use the font modifier to make the image larger. Remember, we can do that because SF symbol is actually a font with vector graphics under the hood. Okay, let me just fix the indentation like that. All right, so it's become a little bit bigger, you can see, before and after, like that. So use a system font to set the size you need to make your SF symbol even larger to fit in your shape. So we can actually control the size by passing system, so system for the default font of the system of size 70. So instead of using the preset large title, I do system of size 70. All right. Then let's go back to the tutorial. So then we change the image color using the foreground style modifier. So just like we did actually for the rectangle. So we add the modifier here. We can see it looks much nicer. Okay. And finally, we remove the borders to finish our welcome page. So we remove all of the borders, which were just here to help us understand what was happening. So let's see, where are all of the borders? So I did Command F to search for border. So border here, 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 and here. No more borders. We're good. Okay. So then we're going to create the features page. So we're going to build a second page to display a list of cards describing the app's features. To keep your views organized on the features page, you'll create two views, one for the page itself and another for the cards on the page. So very similar to what we did at the end of the previous videos. So we're going to create a new SwiftUI view file called features page. So we go into the navigator, create a new SwiftUI view called features page. Okay, what do we do next? We're going to replace the code in the body with a title inside a padded VStack. So we copy and paste the VStack like that. Okay, So we have the title, the V stack has some padding. All right, what's next? Then we create a new SwiftUI view, so second one, and we created feature card. And we create a SwiftUI view file, not just a new view in the same file, we create a new file. And we call it feature card. Then we add two properties to feature card, all right? Okay, like that. So for now, no changes in the view. We have a build error because we need to provide actually values for the icon name and the description. I see a message in the chat. So what does it say? Bonsoir Vincent from across the pond. Just wanted to offer some appreciation for what you do, putting out Swift into Swift info and streams so consistently in such an unthankful world can be easy. So merci. You are very much welcome, and I really hope that this series of tutorial is going to have an impact. I saw that Apple is really happy about their tutorial to the point that they actually run ads on Reddit apparently to promote the tutorial. So I hope that they will enjoy also that I use them. But I really hope that these videos will help people that are on this journey of getting started with Swift and iOS. And thank you for sharing your appreciation. It's very much appreciated on my end. So now we need to solve the build error. And if you followed last video, you already know how to do it. But let's see what tutorial is going to tell us. So we're going to fix the instance of feature card in the preview by adding string arguments for both the SF symbol and the description. Make sure the description is long enough to occupy more than one line of text. And they say you can use the fix button in the error banner. So this one right here, the fix button. And if you use it, what does it do? What do they say? They say that it will add necessary arguments, but because you aren't using the properties in the views body yet, you won't see any changes in the preview. So let me copy and paste the code and put it back here. So like that. Okay, going to hide it here, split across several lines. Remember, it's Command M, Control M to do that. Okay, and so here we have the preview like that. Okay, so it didn't change anything because we are not using the icon name or description inside the body. But of course, that's going to change because we're going to use them just after, I guess. Yes. So in the views body, display the SF symbol using an image view inside an H tag and use the icon name property as the argument. So copy and pasting. So I replace the text with this H tag. And inside we have the image. We can see it right here. So the image which shows two persons, crop square stack fill. So the name of the SF symbol that we are using. Remember that there is an app that you can use if you want to browse across all of the existing SF symbols, and you can download it from Apple's website. Okay. Did we add the large title? Yes, we did. Then we add a text view to the H tag to add the description, and we use the description property as the argument. So it's going to add this quite lengthy description. Okay. We can see that it goes onto the second line. So it's a multi-line description about a feature paired with the image on the left. Okay. Then we add a colored background using a rounded rectangle. So for this, we use a new modifier, which we haven't used before, which is the background rectangle. And I apply it at the level of the H tag. So you might be wondering, it's weird because last time we used the rounded rectangle without specifying a frame to it, it tried to take all of the space available on the entire phone. But this time, it doesn't seem to do that. Why this difference? The difference is that before we were using a rounded rectangle inside a VStack and a ZStack. And both the VStack and the ZStack were allowed to take as much space as was available on the screen. Technically on the safe area, but I'm simplifying a bit by saying the screen. Here it's different because the modifier background is going to only offer to the rounded rectangle the space occupied by the view the modifier has been applied to. So for instance, if the H tag only takes that much space on the screen, then the background will only be able to occupy that much space. So that's why there is this difference. If we had used a Z stack instead of the background modifier, it would have been very different because in the Z stack, the rounded rectangle would have been able to take as much space as was available in the screen here because there is no other parent view that could limit the space available. So that's a very big difference. I see a great question. Is the comma after tint necessary even when on its own line of code? Yes, it is necessary. If you forget it, the code won't build. The reason why it's the case is because of something that's called the grammar of the language, which is basically the set of rules that says what's a valid Swift syntax and what isn't one. And if you look for the grammar of how to call a function in Swift, you will see that every argument except the last one needs to be followed by a comma. So even if it's on a new line, it doesn't change anything. To say it otherwise, the fact that it's on a new line or not doesn't make any difference in the semantics of what you've written. It's purely visual, but for the Swift compiler, it's actually the same thing. And indeed, the reason is because there is another argument after this one. Now, don't get me wrong. When I say that the new line is ignored, it doesn't mean that that new lines are ignored by Swift. For instance, if I put a new line here in the middle of the identifier, you can see that it does have significance because now Swift is confused and it's very different to write back new line ground than to write background. That's very important. So in some places, adding return to a new line has an impact on the syntax. In other places, it doesn't. And more generally, Swift isn't a language that uses new lines and indentation for the syntax of the code. There are languages that actually do that. Typical example would be Python. In Python, you do indentation. The indentation is used to know the scope of the code. In Swift, we use curly braces for that. So it's more some language have this philosophy. Swift doesn't. But very good question. Thank you for asking it because it's a typical kind of question that when you're a beginner, you might ask yourself. But me, it's been so long since I've been doing like computer science stuff that I've become so accustomed to it that this question or this remark wouldn't even have come across, one thing that's interesting, and I'm going to mention it more as like an exercise to the reader, but if you add an extra comma at the end of a function call, so after the last argument, you get an error. This is not a valid syntax. There are languages where this would be a valid syntax. However, in Swift, if you define, for instance, an array, so like that, so like an array 1, 2, 3, like that, so you have this array, you split it across several lines. When you have an array, you are allowed to add a comma after the last value. This is valid. There is an error here for another reason, but this is valid. So having a trailing comma is valid when you declare like literal collections, so arrays, dictionaries, but it's not valid when you are passing arguments to function. I won't go into the details about why it's not valid for functions. I'm not 100% sure, but I'm pretty sure it's linked to the fact that Swift supports functions which are called variadic, so functions that can take several arguments. I think that's the reason why. Arguments that can take more than one value. So if you want to learn about these variadic functions, look it up. I won't go into the details of it, but I think that's the reason why trailing commas are not supported for the last argument of functions in Swift. And now I think it's high time that I go back on the topic of the tutorial. And yes, the upside of Swift not using spacing and stuff like that for the syntax is that a bad formatting cannot ruin your code. Yes, that's a very good point. It's very easy in Python to put some code outside of a for loop, for instance, and not realize it. So that's a very good feature of Swift, personally. Uh, like it's more like it's personal preferences. Some people prefer one over the other. Personally, I kind of prefer like the safer way of Swift. Back to the content. Then we add a white foreground style to improve the contrast of the card because it looks a bit weird. And interestingly, you can see that we add the foreground style to the H tag. And then it gets distributed kind of magically to all of the views inside the H tag. So I'm not sure that the tutorial will go into details of why it's the case and how it works under the hood. So I'm just going to say the keyword in case you want to learn more. But what it does is that it injects the value white color for the key foreground style into the environment. The important word here is environment. If you want to learn more about how this modifier called on the H tag can have an effect on the image and the text, even though the call of this modifier here is unrelated to the declaration of these two views, is because we have the environment, which is a way for SwiftUI to pass values from a parent view to a child view. I won't say more, but you can learn more about it if you search on Google. And once again, it's also covered in my SwiftUI training course, which is available for free on YouTube in my more advanced SwiftUI training course. Then we're going to give the card's content some space by adding a padding modifier to the H tag before the background modifier. So adding a padding is usually kind of a good practice, not gonna lie. Okay, it looks much better. And then they say use the navigator to switch to the features page file, then add a feature card below your title, and use an SF symbol and description of your choice. Me, I will just copy paste because I'm super lazy, of course. So we go back to the features page. We can either do it by clicking here if the file was still open. Otherwise, here on the navigator, we go into features page. And so below the title, we add the features card. Let's split across several lines like that. Okay. Then they say add a bottom padding to the header text to separate it from the card. So we add a bottom padding like that. Okay. Then we add a second feature card with a different icon and a shorter description. Testing with different icons and descriptions will ensure your feature card can accommodate different content and still maintain its design. So basically testing you will often see the term edge case in computer science, and edge case, sorry, I meant to do Control M. Edge case, it's testing like the kind of like values that are at the edges of the domain of possible values. So for instance, text on one line, text on a lot of lines, text that is very short or very long, this kind of different possible values. So it's kind of nice looking, but you can see that it would be better if both blocks had the same size, because here it feels a little bit weird. So I guess that's what we're going to fix just after. Let me just make the code a little bit nicer before. So the card with the shorter description doesn't fill the width of the screen. If you switch files to fix the card view, you won't see the second card you just added. So click the Pin Preview button in the top corner of the preview panel so you can see both cards while you edit your code in another file. So we can pin this preview here, and then when we are inside the other file, we will get access to the pin preview. We can still get access to a preview of the current file, but also the pin preview. And I think the fact that we can access both was added in Xcode 15, because I think before there wasn't this nice feature, like you could only see either the pinned or the current one, but not both. And it's really nice to have the choice. And tip, when an app contains many views, you can pin a few key previews to minimize switching back and forth. So you can pin more than one preview, which is very useful. So then we select feature card in the navigator, then add a spacer to the end of the stack, of the H stack. This shifts the rest of the card's content to the leading edge and makes the card occupy the full width of the screen. So what are spacers? spacers, they are a special kind of views that expand as much as possible to fill empty space in the direction of their containing stack. So in an H stack, a spacer will fill horizontally, and in a V stack, a spacer will fill vertically. And so experiment, try moving the spacer to the beginning or the middle of the card, or try adding more than one spacer. So here we add a spacer here at the end, and it's a way, you see, to fill the empty. It pushes the content to the left, but it's more of a consequence is that it takes all of the space available, and because it does that, then the content gets pushed to the left. And so if we move the spacer like that, you can see here in the middle and here at the beginning. This is dirty, this is better. So let me put it back. I see an interesting question. Is there an equivalent to spacer in UIKit? So two answers to that. There is one, but not in UIKit as you think, but you might know that when you use UI tab bar item, actually, UI tab bar item is not a subclass of UI view, it's just an object. And you have the flexible width in UI tab bar item, which technically is the equivalent of a spacer. And sometimes I've said in my other SwiftUI course that UI tab bar item was kind of like a simplified version of SwiftUI because it was a declarative syntax to build a small part of the UI, so the tab bar inside UIKit. So that's more for the joke that I'm mentioning this one. And no, you don't really have an equivalent of the spacer in UIKit, but because in UIKit, what you would do is that you would say, okay, this label, you would constrain its trailing edge to the trailing edge of the parent view, for instance. So that's what you would do. You would have a parent view actually here, and you would say, okay, this parent view is constrained to the leading edge constrained to leading edge of the parent view, etc., etc. So you would do things like that by constraining the edges. So there isn't really the equivalent of a spacer, to be honest, in UIKit. If someone has a better answer in mind, and I missed like something, please say it in the chat. But I don't think there is one, because when you have constraints, you don't really need spacers. And spacers are kind of here because without constraints, like in UIKit, you need a way to express declaratively the fact that you want something that will take all of the space that's available. If there are people that come from the Android world, I know that when I did a bit of Android almost 10 years ago, you could say whether a child view should wrap its content or match the size of its parent. And so that was kind of like an equivalent of adding a spacer in a way. There is an alternative to spacer also, which is to put a frame and say the frame should have a max width of infinity, for instance. I will let you read on this more advanced technique if you want to look for alternatives. But there is a great video from the YouTube channel Flow Writes Code on this, and it's very interesting. I think like the thumbnail is like a spacer with a forbidden sign on it. It's a great thumbnail, and the ID covered in the video is really nice. And you're saying, so Wicked, thanks. Yeah, I've struggled to ensure elements are spaced properly in UIKit, but that's encouraging. I'm doing the right thing currently. Yeah, and if you want to do the same thing with a VStack in UIKit, it can be challenging. The way you would do this in UIKit would be also in UIKit, you have this idea of compression resistance, and you can use it to say, okay, when there is space available and there are two views inside a subview, which view should expand or compress in order to accommodate when there is more room or less room. But it's quite a confusing syntax, and it's way more difficult to maintain than just having a spacer. Spacer has the advantage of being very clear when you see it. The meaning, the intent is quite clear, and so that's a big advantage of spacers versus their equivalent in UIKit. And so now that both cards are full width, make the icons occupy the same width by adding frame and padding modifiers to the image. So frame to say same a width of 50, and padding to say we add a trailing padding or a padding to the trailing edge. So like that. Looks better indeed. All right. And you can provide any combination of arguments to the padding modifier, edge, size, or both. We saw it a bit before because both parameters have default values. Let me show you actually. But indeed, by default, the value for the argument edges is all edges and length is nil. Be careful, nil doesn't mean 0. That's something that can be so tricky because HStack and VStack, they also have a spacing property that you can specify which is an optional CG float and with a default value of nil. Nil doesn't mean 0. Nil means that SwiftUI will use the most appropriate value depending on the context. And often it will be 8 points for the padding, for instance. But nil here is different than 0. If you specify 0 for the padding or the spacing of the items in an HStack or a VStack, it will be very different than specifying nil. And I've seen people, even very experienced people, get caught off guard by this, especially with VStack and HStack being like, I don't understand, there is a margin, I don't understand where it's coming from. It's because you would need to do spacing 0 if you want to have a spacing of 0. By default, the HStack might apply some spacing in order to have something that looks best and that is aligned with Apple's human interface guidelines, which, if you don't know about it, it's a page on the developer website which lists all of the best practices to build an iOS UI that actually looks like an iOS UI. So if you've wondered the rules that Apple applies when building their own apps, they're available actually on Apple developers website, and it's something called the Human Interface Guidelines, and you can often see them being abbreviated as HIG. There's even a shortcut in Xcode, which I have forgotten about, but when you type it, it opens the Human Interface Guidelines in Safari. Maybe it's Command-Shift-H. Yes, actually I remembered it. So it's Command-Shift-H, and it opens the page with the guidelines. Nice to see that they put a shortcut for it inside Xcode. Okay, section 6 is actually quite a long chapter. So section 6 is combine screens with tab view. I think we did that a bit last week, but we might have done it, but very briefly. I'm not sure, but maybe we covered it. Anyway, we'll cover it this time. Anyway, so to create an onboarding experience where people can swipe between pages, use a tab view. Like other container views, tab view contains multiple child views, but a tab view doesn't display them all at once. It shows one view at a time and gives people a way to switch between them. Oh yes, I think we use a tab view by default where you have tabs button at the bottom to switch between one tab and the other. And here we're going to use another very cool use case of tab view. In iOS apps, a default tab view displays tabs at the bottom of your screen. So most apps from Apple, for instance, work like that. Think about like the music app, for instance, or the clock app. They both follow this pattern. You tap a tab to display the corresponding view. In this example, you'll modify that behavior with the tab style modifier to swipe between the two pages instead. And it gives you a quite powerful behavior with way less code than would have been required in UIKit. So select content view in the navigator, then unpin the preview for features page. So we go back to the content view and we unpin the preview for the features page. Okay. We replace the body, the code of the body in content view with a tab view containing the two screens we've built, welcome page and feature page. And you can see we've put the tab style, the tab view style page for the tab view. Okay. And so the page tab view style lets you swipe left and right to change views. To see the tab view in action, click and drag in the preview. So like this. And it's quite neat how easy it was to build. I can tell you, like, actually, my first paid job after I graduated as an iOS developer was to build a view like this. And I had to build it in UIKit. I think using a scroll view. I don't know if it was a scroll view. No, I think it was a collection view, but with some kind of of stops, so that like when you would let go, the scroll would stop only on certain points, certain coordinates you had allowed. And building it in UIKit took quite a bit of work. Whereas look at this, like it's built like automatically, even auto-magically, we could say. That's quite nice. That's quite nice. That's one of the killer features of SwiftUI. Like one of the big pain point of UIKit, if you've ever used it, was building scrolling content. It was a freaking nightmare. And so SwiftUI is able to handle it so much better, in part because of this notion of ideal size and the fact that SwiftUI knows the size of the things it's displaying. That plays a big role. And yeah, they call it tab view, but basically it's a page view. And interestingly, this component in UIKit, one version of it is called the UI page controller, I think. And the UI page controller, it was, if you've ever used the iPad around when it was released. The iPad, when it was released, had this feature, especially for like ebook apps, where you could take the page and turn the page by swiping, and you would see like the page like curling and going to the other page, and the text would wrap in a realistic way as the page would curl and follow the movement of your finger. It was super impressive, and it was actually built in into UIKit. It was an option on this UI page controller. So if you have used iPads between like they advertise this on the first versions of the iPad. So like if you were lucky enough like me to have an iPad when it released in 2010, if I'm correct, you probably remember this behavior, and it was called the curl, the curl, I think, style for the transition. And back then it was mind blowing. Seeing that it was rendered at 60 FPS, super like fluid and everything, this was absolutely mind blowing back then. Yeah, you remember that effect from the books app. I think, to be honest, anyone that had an iPad remembers this, because it was the thing that made it feel so high end, and it shows that to give a feeling of being very high end, you don't need to have a lot of things. You need to have one thing that you do really, really well, and that you market a lot, and it does the job, because like I mean, 15 years later, we both remember it. Actually, I remember that the iPad, yeah, released 15 years ago. No, 14. Yeah, 14 years ago. It was in April in the US, and a bit later, it was in May that it released in France. So 14 years ago. Okay, so that was actually quite fast to add the tab view. Then we're going to add some colors to make it look nicer. We'll also add this little like page controller at the bottom. So a page tab view adds a white indicator at the bottom of the screen. Actually, apparently they are there, but we just can't see them. Let's see. And they are not being shown, but okay. Apparently they are there, but we can't see them. Maybe if we switch to dark mode. Oh yes, now we can see them. Perfect. So I will go back to light mode, because dark mode is not always great when the video is encoded during a live stream. But okay, they were here, they were just not visible. So how do we make them visible? We're going to define custom colors. So we're going to look in the list of files navigator and select something called assets. So let's have a look and see what is this asset thing. So it's this thing here. It's what's called the asset catalog. It's where you store images and colors, all of the graphical resources that your app will consume. And the reason why you put it into an asset catalog and not just like files put inside your project is because the asset catalog it allows you to give meaning about when to use each asset. You can say, for instance, you have a specific asset for light mode and dark mode, these kind of things. And also, when you build your app and when people download your app, they only get the assets that make sense for their iPhones. Like if they have an iPhone that has a display with more or less higher or lower density of pixels, they don't use the same icons, and it doesn't make sense for them to download the versions of the app that the device will never use. So that's why we have these things called asset catalogs that were not always there. They were introduced around iOS 5 or 6, something like that. At the beginning, we didn't have them. We just had like we just had PNG files like in our project, or JPEG files in our project, and that's how it was done back then. So we're going to use the plus button at the bottom of the assets to create a new color set. So here plus color set. We change the name of the color to gradient top. So it will be the top color of the gradient. And then we show the inspector by clicking at the top right of the window and choosing View Inspectors, Show Inspector. So here, uh, and we have several inspectors. I don't know which one we will use. The last one, okay. In the inspector, next to appearances, click and choose None to use the same color for both light and dark mode. So where do I do that? So appearances, so none, it means that we will use the same color in light and dark mode. Then select the color swatch label universal. So like that. In the inspector, use the controls below color to define a color. If you want to match the project screenshot, use these values. So red 0.852, green 0.646. So here I missed it, but it was, it's because, yeah, so it says point in the tutorial, but my computer is on the French local, and we use a comma to separate the decimals. So that's why. And also I'm realizing that I'm hiding this part. So you can see. So for me, it's comma 852, but for anyone else, it will be point. It's interesting to see that this part of the UI is localized, whereas like the rest, Swift code isn't localized. Like you always put a point to separate like the decimal part of a number in Swift. But this here, it uses the preferences of macOS. So that's kind of interesting. Okay, and then here it's 0.847, I think. Like that. Okay, seems to be correct. All right. Same thing for gradient bottom. So we'll see if I can go a bit faster this time. So I create a new color. I call it gradient bottom. You can see that I cannot put it after because it's ordered alphabetically automatically. So of course I could cheat by putting like a Z. No, that doesn't do the trick. I could do like gradient like gradient like two, or I could add something to say that one is at the top, one at the bottom, and to put them in the same order. Here, it's not too much of a problem that they are not in the same order. So here it's 0.954. So remember, same color for light and dark. So 0.954 like that. Then 529, 529, and 385. Okay, we have our color. All right. Then we open the content view file and declare a global property for the gradient colors at the top level above the declaration of the content view struct. Okay, so back to Xcode, moving the window back where it was. So content view, and we add this at the top of the screen. And let me hide all of the inspectors. What do they say? They say that a global property is visible to all of your code in all files, so you're not limited to using gradient colors in content view. The value of gradient colors is an array of two colors. An array is a collection of type that can store multiple instances of one type, such as color, string, or int. Xcode creates a camel case color value for each custom color set you define. So this means that you can see inside the asset, I've defined the name of the color, and it automatically, so Xcode automatically created the code to have these two nice identifiers to refer to the colors. Before that, you had to write to pass in strings with the name of the color. That was very error prone. What's nice with this is that if I make a mistake in the identifier, I get a compilation error. For instance, if here I make a mistake, so let me build the project again, because you need to build once so that the identifiers are created. But you can see that if here I put an extra P, for instance, I made a typo, I have an error because there is no such color. If I remove it, it builds successfully. And same way, if here I rename the color, then code that uses the old identifier won't work, and I will need to update the identifier. So this is what compile time safety does. It's a very desirable property because it makes your code much safer, because if there is an error, it gets caught at build time and not at compile time when your user is using the app. And you want to catch errors as early as possible, and catching errors at compile time is great. And so by doing this, basically, you rely on the compiler so that it enforces the fact that all the colors that you're using are valid. And that's quite nice because it alleviates for you the need to worry about it yourself. Remember when I was saying that you can add an extra comma at the after the last element of an array? Case and point. Yes, you can do it. I was able to successfully build my project even with this extra comma. Yes, exactly. We've capitalized it in the name of the color in the asset catalog, because it's more of the convention to write it like that. But in code, it's more the convention in Swift to start with a lowercase for the first word of an identifier for properties and methods also. And so that's why here it's a lowercase character. Types follow a different convention because types, they start with an uppercase even for the first word in the identifier. Very good question. Okay. So, and by the way, global properties like that, they are not great because yes, they are usable everywhere, but they're all in the global namespace and it's not great. So usually what you would want to do, you would, for instance, want to put it inside a struct that you would call, for instance, a struct that you would call colors. And then you would do colors. I mean, colors is already taken. No, the name colors is available actually. Color is taken, not colors. You would do then colors dot gradient colors. This way, gradient colors, it's scoped inside a type. It gives more meaning about what it does, and it's a better practice. Putting stuff inside the global namespace is not seen as a good practice. Here it's okay because it's a constant. If it were a variable, it would be really bad. Like global variables is a really bad practice in general in computer science. Global constants is slightly less of a bad practice because since they are constants, they cannot be changed, and so you don't run the risk of having a part of your code changing something that breaks something at the other end of your project. But still, it's not the best practice. So don't do this at scale in an actual app. And then we add a background to the tab view. So using once again the background modifier, and this time we don't pass a rounded rectangle, but we pass in a gradient, which is a view that will render a gradient and it will also take as much space as available to it. And so you can do swipe to see your background on both the welcome page and the feature page, because we've added the background to the tab view. And you can see indeed, what's nice that you can see that the background doesn't move because it's the same background for both actually. If I had put the background individually on each of the tab views, you can see that, I mean, it wouldn't take all of the space available because the welcome page and the features page, they don't take all of the space in the screen. But you can see very clearly that here it's two different backgrounds in the eyes of SwiftUI. Whereas here, since we've put the background on the tab view, then it's actually the same background and we have two views that are sliding in front of it. I wanted to make sure that you understood that distinction. Okay, section 8. Create a theme color and polish the style. So choose an app accent color that fits the color scheme of your app, then modify the text and backgrounds of your views to enhance the style. So in content view, apply a white foreground style to the tab view to change the color of the titles in both views. So we apply it just after the tab view style, and then you can see foreground style white, so it made text go from black to white. Okay. When you apply foreground style to a view, the color will cascade down to all subviews that don't set their own foreground style. And remember, this is thanks to something called the SwiftUI environment. Then select Assets in the navigator, then select accent color to change the accent color of your app. So you can see there is already a space for it. So by default, it's the blue, but we can set a different color. And so select universal, then edit the color in the color section of the inspector, so like we did before. And this time the values are 0.269. So let's do that. So it's going to be a color, a custom color. Should I choose sRGB? Yes. So if you want to learn the difference between sRGB, DisplayPfree, etc., look for what is a color space. I won't go into the details of it because this is quite complex, and I'm not gonna pretend like I know all of the intricacies of it, but it might be worth having a look at it. Okay, so 0.269, 0. You can't see the other thing, but me, I can see it. So this way I can win some time. 0, 6, 4, 7. Something like that. Let's move the window back. And then to see the new accent color in your app, select the content view file and look at the graphic and the features card. So if I go back to the content view, you can see indeed the color has changed. It used to be blue. Now it's this very muted purple color, and same thing here. I see a good remark. Most of this can be hand-coded as well, or does Swift require the Xcode Asset Manager to use these constructs like accent color? I think you can override this in code if you want. The accent color, I'm less sure of how you can do it, but I'm pretty sure that actually, I think you can go in your app like that, and at the top level of your app, I'm sure you can do something like, yeah. So, okay, it's defined on view, but on the top view of your app, you can do like accent color. Okay, now they've changed it, so now it's tint, but you can change the tint like that. So you can also do it in code. And so if you're using Playgrounds, so you say that you're using Playgrounds. Playgrounds, it's an app on iPad that allows you to build iOS apps. Actually, you can go all the way up to submitting your app to the App Store. It's actually surprisingly good. I did a video like 2 years ago on how to build an app for using Xcode Playgrounds. So I did a live stream actually 2 years ago, so you can check it out if you want after. And yeah, Xcode Playgrounds on or rather it's Swift Playgrounds on the iPad that supports building an iPad app is works quite well, honestly. I was very surprised by the quality of it. And what's funny is that in Xcode, in Swift Playgrounds on the iPad, you have a feature to generate an app icon automatically with like some presets, if I remember it correctly. But so you don't have a way to do the accent color with Asset Catalog. So it's interesting to see that there is one thing in the Playgrounds which isn't available in Xcode, and vice versa. Nice to see that there is no feature parity, but one isn't even the subset of the other. And so now let me get rid of the code that I might have written because I don't want to forget it. Yes. Okay. So this goes back and we go back to content view. Okay. Step 5, select the features page file, add your background color to the preview so you can see how your accent color will look in the finished app. So yes, because since we added the background, there is a good point. Let me go back to the to Xcode. So we added the background here on the tab view. This means that when we are designing the features page here, we don't see the background, but we need to see it in order to be able to gauge whether our view is readable and looks nice. And so the way we can do it is by defining it here inside the preview. And this way we can see we have the background displayed. Here it matches only the space, the ideal size of the features page. That's why it doesn't take all of the space available. We'll see if they show us how to fix it. So And then they say to do the same thing with the white foreground style. So here, I think they show it to show us like how you can customize the preview in a real app. This, I'm not sure that I would want to duplicate the code. I would try to have the code only in one place. I think that would be a better approach than trying to duplicate the code, because it's very easy to then change it in one place and not in the other. But at least it's good to see that we can customize the preview. And then they say, so the features page preview doesn't extend to the full height of the device frame, like we see here. I make it a little bit smaller, like that. Because its VStack tightly hugs its content, because the background only uses the ideal size of the view that it's been applied to. Extend the preview vertically by requesting infinite height. And so you do it by doing frame max height infinity, like that. You might had in mind another solution, which would have been to put a VStack and then a spacer before and a spacer after. This probably would have given a similar result. And when I was telling you that you can use a frame with max height or max width infinity instead of spacers, that's an example of how you can use it in practice. I see a question. Preview contents that just for the editor, it won't show during runtime on device. Yes, absolutely. And anything that's inside this preview, it gets stripped by Xcode when it generates your app. So not only it will not run on device, but also it will not even be part of your app when you ship it. On the other way, I think it's possible to run the preview on your device on Xcode if you want to check it like that. I don't remember how to do it, but I think it's possible. You do it by clicking here, and if you have an actual device plugged into your computer, it will appear. I don't have one plugged to my computer right now, but I think you're able to do that. Okay, let's see what we will do next. Now they talk a bit about this modifier. So as opposed to frame width, height, and alignment, which we've used before, where we were giving actual values, you can use this variant. So where you say max width, for instance, to specify a flexible frame. You can skip the arguments you don't need. Here you only provide a value for the max height. And if you look at all of the arguments which are available, you will see that actually, you see, min width, ideal width, max width, min height, ideal height, max height, alignment. You have quite a few of them. And since they all have default values, well, you have 1, 2, 3, 4, 5, 6, 7 arguments. This means that there is 2 to the power 7 combinations. Actually, no. Since you can also pass, pass in it takes it into account. So there is 2 to the power 7 combinations of ways to call this function with different arguments being provided, and for the others you rely on the default values. So that's quite impressive when you think about it. And actually, if you click here on the little disclosure indicator, you can see all of them being rendered. So it's nice that Xcode doesn't hang or crash, because as you can see, there is quite a few of them. There is quite a few of them. 2 to the power 7. I don't know how it is if you want to do the math on your end. Should be 2, 4, 8, 16, 32, 64, 128. So that's quite a lot, and this grows exponentially. So as you have more and more, if you have a function with maybe 15 arguments and each of them have a default value, and then you click on this button here, I don't know what happens. I think when I want to try it one of these days, but it's kind of there is a video of someone taking the Apple Watch and then using an electric drill to turn the digital front so that the views get smaller and smaller and smaller. It's kind of the same idea. It's gonna give a very weird thing. Back to the tutorial. Step 8, set custom spacing for the VStack. I mentioned it just a bit before. So you can set custom spacing and alignment for all VStacks. Try out different values in different stacks in your app to see the effects. So for instance, they say we should set a spacing of 30 here for the VStack. So by saying spacing like that of 30. And we can see there is more space now between all of the views. And the other thing is called alignment. So by default, it's center. You can put it leading. And if I put it leading normally, so I just need to put the argument. I don't think I put them into the right order. Yeah, alignment is first. So alignment like that. So by default, alignment is center. But if you do leading, you can see that normally, what's happening? Alignment, spacing, because I can't spell, that's why. So by default, it's the center alignment, but you can do leading, for instance, and you can see now it's aligned on the left. And once again, I go into much more details of how these values work in my more advanced SwiftUI series of videos available on my channel. And I even cover how to create custom alignments, which you can do. It's quite complex. It's a very advanced topic, but it's possible for the more complex use cases. And so here we want to do a spacing of 30 like that. Okay. Step 9, use a spacer to push the contents to the top of the screen. So we put a spacer at the bottom so that the content is pushed back toward the top of the screen. Okay. And to keep the contents away from the very top of the screen, add some padding to the title. So a padding of 100 at the top. Interestingly, I was about to say I would have put the padding. Maybe I would have put the padding on the VStack. Is there a difference? No, doesn't seem so. Instinctively, I would have put this padding on the VStack rather than on the text. It feels more like the responsibility of the VStack, to be honest. But at least it does the job. And if you need to implement like a UI that your designer defined in Figma, you will find yourself like setting this kind of padding on specific edges quite a lot in order to position things on the UI. And yeah, the alignments are quite interesting to experiment and try on. And what's interesting is to try and see like just up to when you can go with the default alignments and when is the moment when you need to rely on custom alignments. Like what cannot be implemented when you use just the custom like leading, center, and trailing alignments. And by the way, VStack has a leading, center, and trailing, and an HStack has top, center, and bottom, of course. And these stacks, they have like the same, they have all of the combinations. So they have leading, trailing, top and bottom, and also leading top, leading bottom. So they have like all of the possible combinations you could hope for. Okay. Now they say pin the features page preview. So let's do that like that. So you can see it while you make edits. Then open the feature card file and change the background modifier to use a custom view. So feature card, okay. So here. And so here we're going to say, so yes, that's what we have here. So, oh, okay, we do something different. Interesting, you see, here we were calling background and passing a tint and saying this should be rendered in a shape. And now it's still called background, but it's a different version of it. It takes different arguments. This is what is called an overload. I talked about it last time. And so what they call the variant is an overload. And so with this variant of background, you can use an arbitrary view. In the following steps, you'll use that flexibility to alter the rounded rectangle's colors. Because here we could only pass something that was that they call a shape. So we could only pass a shape, not any kind of views. Whereas with the other modifier, we can. What's interesting is that this modifier here was introduced probably with iOS 13. Let me check. Do they say availability somewhere? No. Let me just scroll up until I see the parent declaration. I hope I will. Okay. So this one was iOS 15, actually. because the other modifier, the one where you pass a view, it was introduced a bit later than at least that's how I remembered it. So this one, which OS is it? Okay, it's 15 also, but it's nice to see that there is a typo actually in Apple's documentation. So it can happen also for the best. Um, and so, yeah, back to the topic. Yeah, so what I wanted to hint at is that not all modifiers are available on all versions of iOS. And so this modifier background, for instance, is only available on iOS 15. So if your app needs to support older versions of iOS, you won't be able to use it. To be fair, if you start a new app today, I don't think you will want to support versions of iOS before iOS 15. Currently, we are at iOS 17 and 18 will be released quite soon. So if you start an app today, it's likely that you will support 17 and 16. Maybe go all the way to 15 if you really need to have a large compatibility, but going all the way to 14 is going to be more rare. There are apps that have to do it. Typically, apps that are for the public administration, where you need to support many devices, or services which are like very important services for people, like electricity, banking. These kind of apps, they tend to need to support a large array of versions of iOS. Because it's kind of a problem to say to someone that cannot update their device anymore that well, you cannot use your banking app anymore unless you buy a new phone. It's gonna make people angry, and if you're a bank, you might even get like some bad headlines in the press. So that's one of the reasons why some apps needs to support a lot of older versions of iOS. I don't recommend that you support like all the way up to iOS 14. But my point was, be aware that there are some modifiers that are not available to use on all versions of iOS. However, if you attempt to use a modifier that's not available, if you attempt to use a modifier not available on the versions of iOS that your app says that it supports, you will get an error in Xcode, which is kind of nice because originally in Objective-C, at the very beginning, you didn't have these kind of warnings and you could get a crash without being aware of it. So that was one of the fun things of building apps back in the days. Okay, and then we're going to reduce the opacity of the card um, of the card. Oh, I see a question. How are you invoking that history on the terms from Apple? So you mean how I go from this view here to this view there, for instance? I do command click. So command click here, and it shows me the place where the symbol was declared, which is the header of SwiftUI. SwiftUI is not open source, so you cannot see the implementation, but you can see the header that Swift imports and that allow you to use the features of SwiftUI. And so it's command click, or it would be right click and jump to definition if you want to do it without the shortcut. That's how you do it, and it's a very very useful shortcut. By the way, I have an entire video called, I think, like 65 tips to use Xcode like a pro, and you can check it out after if you want. And you have a lot of tips to to use Xcode like a pro, as the name does suggest. Fair warning, half the tips I discovered them while doing the live stream, so you can be a very good developer without knowing all of the tips in the live stream, of course. And so we're going to reduce the opacity of the card, so this thing here, and we do it by calling the opacity modifier, but we don't do it on the view itself, but only on the background, because we don't want to reduce the opacity of the image and of the text. We want it to stay super legible. And you can see that now it looks a bit more muted, maybe a bit too much, but we have an opacity of 25%. So the color is only 25% opaque. To say it differently, it's 65% transparent. And opacity values range from 0, fully transparent, to 1, opaque. So yes, so it was, yeah, so yeah, so 65% transparent. Yes, I was correct on that one. So try different values until you find an effect you like. So for instance, 0.5 is like this, 75 is like this. To be honest, I find 0.25 quite strong. I would more go for something like that. But remember, I'm not a designer, but the contrast feel quite too low. Like I feel like it's hard to read the text, and here it's more easy to it's easier to read. Uh, I'm not sure. I'm not sure which is best, to be honest. Okay, moving on. For a final touch, bring back the contrast. They mentioned contrast, so I was not that much saying things that didn't make sense. By reducing the brightness of the card background. So we're going to play on the brightness. So put it at minus 0.4. So I will put it back to 25 and then like that. Yes, much better. So playing on the brightness. Kind of reminds me when I'm doing my thumbnails and I try to play on the color of the text, what it looks like nicer and more readable and more appealing. Similar stuff. I had never used the brightness modifier, to be honest. What does it say? So a value between, by the way, I did that by doing alt click this time. A value between 0, no effect, and 1, full white brightening that represents the intensity of the brightness effect. What's nice is that they say a value between 0 and 1, and we passed a negative value and it still did something. So this is not a great documentation. So use brightness to brighten the intensity of the colors in a view. The example below shows a series of red squares with their brightness increased from 0, fully red, to 100% white in 20% increments. So actually, it's rather than you cannot go to above 100 and below 0 in brightness, but you can increase it both positively and negatively. So actually, this documentation here is not incorrect, but it's incomplete for sure. So it also shows how hard it is to correctly document an API, whatever that API is. So let's see what they say here. Yeah, -1 to 1. So brightness values, here they say it correctly. So also being able to stay consistent between the documentation you write and then the tutorials you write around the documentation is also another challenge. Like I'm doing that at work. I've been doing that at work in part for the past few months, and I can tell you it's definitely a challenge, and it's so easy to have everything go out of sync because there is no compiler to check that you are doing the things correctly. You know, like you change something in a web page and then you don't change it somewhere else. You're not notified, but it gets confusing for everyone really fast. And so brightness values, they range from -1 to 1. Negative values blend black into the view, and positive values blend white into the view. So one brightens and the other one darkens in a way. So brightness with a negative value is darken in a way, which kind of makes sense when you think about it. So try both positive and negative values to see how it works. And as always, keep editing the design until you like it. So if we remove the minus sign, for instance, it's brighter this time, and now it's darker. And if we do, for instance, minus like 84, it's way darker. It's so dark that it almost becomes like pure black, and we lose the fact that there is this purple color to it. And about how you find the correct value, you see here they say like keep editing until you like it. I'm sure that designers have a bit more like rules or how do you call it? Something to approximate. I cannot remember the word. It's like I have the word, but I can't remember it. But it's when you have a rule that gives you an approximation that is good enough. A heuristic. That's what I was looking for. A heuristic to know which colors are what colors are used. I see an interesting comment, which I think is worth. Yeah, rule of thumb also. Rule of thumb, definitely. Rule of thumb is heuristic, but said in a way less academic fashion. Heuristic feels more like I know what I'm doing. That's why you can trust me as a designer. I see an interesting comment that says what you are doing is a toy for kids. That's something I want to address, because this is a beginner tutorial and the goal is not to show you and the goal, you're going to get banned very soon, by the way. But the goal is not to show how to build a complex app. I'm not going to show you how to build Uber in this live stream. The goal is to show people how to really get started with Swift. It's like introductory classes. Imagine you start learning computer science. I mean, you're not going to start from zero to build Instagram with the same features and performance and everything. And yeah, so good remark said in quite a mean way. So first time I used the ban button on for another remark that was quite mean. So first time I used the ban button on my streaming software after 2 years, 3 years of doing live streams. So it's quite nice that it took that long. But hey, there is a first for everything. Okay, so actually this took way longer than I thought. I thought I would cover like 2 chapters in 2 hours. I will only cover this chapter because like my voice is already starting to kill me. So I will stop here. I will do the quiz first and then the recap on the page after, and then we will stop here for today. So like on the previous chapters, 3 questions to check our understanding. If you're watching the replay, try to pause and think about the answer because it's a great way to know if you've understood everything. So question 1, what's a good technique for inspecting the size of a view? ZStack, Size Inspector, or Border? So there is one we didn't use, Size Inspector. As far as I know, it doesn't exist. At least I've never used something with that name. ZStack is not what you use for this. ZStack is used in order to position several views from the back to the front, axis on the z-axis, and we have border, the modifier that shows a border around a view, and it's indeed quite useful because it allows you to see the space occupied, the area occupied by a view. So border here is indeed the correct answer, and I think there might be a shortcut somewhere in Xcode to see, at least in the simulator, I know there is one, to show the space occupied by the views. If there is one, I've covered it into my other live stream about 65 tips to use Xcode like a pro because it rings a bell. I don't remember how to do it exactly, but it rings a bell that. So if it's in the video, it's there, and there are chapters. So you will be able to find it quite easily if it's there. Question 2, in which direction do spacers expand to push other content? So in the direction of their containing stack, perpendicular to the direction of their containing stack. So now it's in the direction of their containing stack. So in an H stack, a spacer will take space horizontally, and in a V stack, it will take space vertically. And you can give an argument to a spacer, I think, to say min width. So to say like, don't take, I think it's min width. I'm not sure if it's min width or max width actually. It's min length, yeah. Same idea than min width. It's to say that the spacer should take that much space or more. So it's similar in the UIKit world when you have a constraint that is greater than or equal. It's the same kind of logic. Interesting. By the way, border is always inside, not around the edge, where half the line width would be outside of the view. I'm not sure, actually. I'm not sure. You know what? We can check it. We can check what are the arguments we pass to border. I think the border by default is in the middle, but I'm not sure. It's worth checking because indeed, when you draw a border, since the border, I mean, if the border is 1 pixel, in a way, I'm not sure it applies when the border makes only 1 pixel. But if your border is, for instance, 4 pixel wide, the question is, where do you draw the pixel? Do you draw all 4 pixels inside the border? Do you draw them outside the border, or do you draw half inside, half outside? So in softwares like Sketch or Figma, you have a choice in the UI to say if the border should be inside, outside, or on the center. And I'm sure there is a way to control that in Swift UI somehow. I'm not sure how it works, to be honest, but great remark. Because ideally you would want the border to be, I guess, at the center. I guess it's the best way to see the space that the view occupies. But at least what you want is for it to be consistent, because otherwise it's gonna be super confusing. But very, very good point to mention it. Then what do I see? Yes, you're right. You can use the design button in the canvas, which sort of creates a border on the views based on what you click on. So yes, I showed it, this thing here. So this thing, indeed, it also shows a border around the ideal size, or rather the size occupied by the view. And if it had an ideal size, it might be that is the actual size occupied, but like the ideal size is used to determine the actual size, but it might not always be equal to it. For instance, if there isn't enough space to render a text and text gets truncated, then the text is rendered in a size that is smaller than its ideal size. And then you say, yeah, you can overlay a rectangle. Yeah. When I said that you can always find a way to do it, I was thinking about this kind of stuff where you can always compose shapes in a way where it will do what you want it to do. But yeah, actually, I'm not sure if there is an API. But as you said, you can build one yourself. And so here, to go back to the question, in which direction do spacers expand to push other content in the direction of their containing stack? And a spacer helps you separate elements in a stack by pushing them away, and it can also help you make a view take all of the space available. Be careful, don't necessarily add a spacer by default, because there are some views, like for instance, we saw the tab view, that will take all of the space available by default. And it happens often that the parent view in a view hierarchy will take all of the space available by default. So don't use spacers until you actually need to. Don't sprinkle them everywhere because you think that you need them. If you don't really need them to make your view work, it's better not to put a spacer that actually doesn't serve any purpose. Because remember, any code that you don't write cannot have bugs, unlike code that you write, which can have bugs quite easily, actually. And wouldn't you say using frame max width, then setting an alignment is better than spacers? That's quite a debate, actually. That's quite a debate. Personally, I think I was using. I don't do SwiftUI in a day-to-day basis since the last months, but I was moving more towards using frame with max width and max height and alignment, to be honest, especially when you want to center, because when you want to center, you need to put a spacer on the left and one on the right. It can be a bit annoying. So the frame one is a bit more powerful. And also the frame one, you can use it in very interesting ways. Like for instance, if you want to center a content, you can try sometimes to put the content in the background of a view and then center it with the frame, with this frame modifier. So it's not super clear the way I've described it, sorry, but the bottom line is the frame is quite powerful. And I would say when you're getting started, spacer has the advantage of being very easy to understand what it does. But as you're building more and more complex views, indeed, using frame max width or max height can indeed be a solution that scales a little bit better. But both are supposed to be equivalent anyway. So in the end, it's more a question of preference and coding style. And so, question that seems actually quite a link to this: how can you create a frame with infinite height, or rather with infinite max height? Because if you try to set infinity for the height, you will get an error because it must be an actual value. So use the infinite height frame modifier. I don't think that exists, even though you could create one if you wanted to. That would, under the hood, call the correct one. Use the frame modifier with a max height argument of infinity. Use the frame modifier with a height argument of maximum. So this one, don't do it, you will get an error. But this one indeed is the correct one with the frame. So min width, ideal width, max width, min height, ideal height, max height alignment modifier. That was a mouthful. You can create many kinds of flexible frames by choosing just the arguments that suit your needs. And you're saying, yeah, same here. I usually create a custom func which accepts the element parameters that way. I don't have to always include spacers or type in frame max width. So yeah, in the end, it becomes more a question of style. And I would say the more important criterion for me is that whatever you choose to use, you use it consistently into your code base. Like what's bad is to do spacer in some places, frame max width in another place, a custom modifier in yet another place. Choose one approach and do it everywhere. It will always be better than doing a little bit of each in different places. But creating your own modifier is also absolutely on the table. All right, wrap up for this section about layout and style. So SwiftUI's layout system has a few simple rules, but its ultimate behavior can be complex, because even from simple rules, you can make a quite complex system emerge. By combining stacks, spacers, and padding, you can build expressive interfaces. So what have we learned? We've learned that SwiftUI provides a range of container views that group and repeat views. You can achieve the layout of any app interface using containers, such as stacks, along with views and modifiers. Going beyond what you saw in this tutorial, you can also use SwiftUI to ensure that your interface adapts dynamically to a wide range of traits and contexts, including different device screen sizes, resolutions, and color spaces, different device orientations, portrait or landscape, split view. I could also add light mode and dark mode, for instance. Which topics and skills have we covered? So debugging layout issues using borders, so very basic but still useful debugging skill. Adjusting the sizes of elements using frames. Using 3 types of stacks, VStack, HStack, and ZStack to create a complex interface. Controlling the placement of content in a stack with spacers. Navigating between views using a paged tab view. And custom color sets in the asset catalog. And I think that covers it quite well. We had already seen how to create like child views in the previous chapter, so we just used it as being part of our tool set. And yeah, that was quite a good lesson already. That's quite a good curriculum for this lesson. So if you want to keep practicing on what we've learned, so you can extend the app we've built either by playing with the design of the app, so trying to use all the techniques you've learned, such as padding, spacing, and stack layout. How much can you push the design in a new direction? How much can you accomplish with additional nesting of stacks? And remember, you can also read the document called Apple, the Human Interface Guidelines, to know how to build a UI that will be in the guidelines of what an iOS app should look like. You can try to add a third page to the onboarding flow, including whatever elements you want in the new page. Or you can try to change the color scheme of the app. You can update the True Gradients color or add a third. Try varying levels of opacity and brightness to make the feature cards different from one another, like we try to do a bit during the tutorial. And if you're more in the mood to challenge yourself, you can practice swiping between multiple views. So start a new Excel project and create a short story using tab view style page, so you can swipe between the pages of your book. Make the first page look like a book cover, including a large title, author name, one or more SF symbol, and some splashes of color. For the pages in the story, think of creative ways to display chapter titles, text, and pictures. And you could even get the text of a book that is like in the public domain to try it. And I see a question, so I will answer it. Quick question: if we add fixed heights to our components in our view, would that mean the sizing will be off in different devices? So we use Geometry Reader to fix this. Very good point. Very good point. If you put a fixed height, then you might have a problem that maybe you don't want the same height in all devices. Maybe you don't want your view to be of, I don't know, like 400 of width. What you actually want is your view to be 80% of the width of the screen. And indeed, when you need to read the size of the screen, you have a type that's called a geometry reader that allows you to do this. And basically, whenever you need to express a size in a way that is relative to that of the parent view, which could be the screen when you are at the top level, then you will need to use a geometry reader. So think about the constraint that you could do in UIKit of saying I want this view to be 60%, so 0.6 the size, the width of this other view. This is how you would do it through a geometry reader. We haven't covered geometry reader in this tutorial. Maybe we'll cover it in the next chapters. I don't know. But thank you for mentioning it, because if you're looking for a way to build more complex and powerful interfaces, Geometry Reader is definitely something that you're going to stumble upon because it's quite powerful. And basically, to sit in a nutshell, Geometry Reader is a way for a child view to access the size of its parent view. And this way, be able to say, okay, I want a frame that is 0.2, so 20% time the size of the parent view. And you're saying, and you're able to combine proportional max and mid values with fixed minimums. Yes, in that case, yes, you can indeed combine the two of them and maybe even build a nice utility in order to do it. Sometimes you won't even need to actually code the minimum, because most of the time that minimum will actually be given by the ideal size of the views. For instance, if you have a text being displayed, well, the minimum size is for the text to be readable, so not to be truncated. So sometimes you will indeed need to define these minimum sizes, but most of the time you might not need to, because you will define a max width, for instance, and the max width, you will not need to define a min width because it's kind of given automatically for you because of the ideal sizes of the child views. When the child views don't have ideal sizes, typically if they are shapes, for instance, then you would indeed need to also provide minimum value. Thank you. That was a very good remark. And they also say if we want to change ourselves, we can enhance the chat prototype. So the app we did in the first chapter, you can go back to your chat prototype project. Can you work out how to push messages to the left or right edge of the screen to indicate whether they're from the person using the app or the person they're talking to? Hint, if you have a custom view for the chat bubbles, you can use if statements inside stacks to conditionally include views. That could be a pretty good change, and not that I don't think it's that hard. So this one is much easier than the one above, and you can indeed try this one first. And you're saying, I hardly use minimum size. It's a rare occurrence where you need it, in my opinion. Yeah. To be honest, I don't think I've ever needed to use it. And the ideal one, same, because most of the time there's going to be one by default. And basically, I think in the cases where you don't have an ideal size, then you want the default behavior, which is to take as much space as possible, and you put a frame in order to a frame with an actual height or width in order to constrain the thing. So indeed, I concur. I don't recall using min width or min height in production ever, to be honest. Okay, and what will be next? So next week, in the next tutorial, we will learn how to create views that have state and learn how to make our app interactive using buttons. So state and buttons, it will be next time. So sorry, I know that someone was stuck there. It will be for next week, next Monday. But I'm really glad that we covered this chapter. It was 2 hours in the end. I didn't think it would be that long, but it was quite thorough. And I think for someone that is discovering SwiftUI, we've covered a lot of the groundwork. And now you have the foundations, and you also have a few ideas of where to look to go for something a bit more complex. So I think once again, Apple did a really great job with this series of tutorial. And so I see some nice messages in the chat. So thank you for the people who were there during the live stream and who made really great remarks and asked really great questions. I'm sure that the people who are watching the replay appreciate your effort. And for me, it also makes it feel much more interactive than if I were to speak in my empty office, in my empty home office for 2 hours. So thank you a lot. And I guess I just have to say, yeah, see you in 1 week for the next part of this tutorial. If you're watching live, if you're watching the replay and everything is already recorded, it's just like for a TV show, you can binge watch and just move on to the next video. Thank you for watching, and see you next time. Bye bye. Hey, what's up everyone? Welcome to part 3 of my training course to learn how to create, how to develop iOS apps using Swift, SwiftUI, and Xcode when you're a complete beginner. So this is part 3. This means that before there have been 2 previous parts where we've already covered quite a lot of ground. So if you're joining for this part 3, a quick reminder that as a support for this course, I'm using a tutorial released by Apple a few weeks ago as of when I'm recording the course. So right now we are at the beginning of May 2024. So you have the link to the course in the description. And let me show you what we have covered in the past weeks. So in the first video, we covered how to explore Xcode and build a super basic a super basic screen of an app in SwiftUI, a basic screen of an iOS app, of course. And in this first part, we also covered the second chapter, which was how to create views, structure, and properties, and how to start to create components that could be reused in several places of an app. Then in the second part, we covered chapter 3, which was quite long, longer than I expected, if you remember. And it was about how to lay out and style your view. So we had learned how to position text and images, but in this chapter, we learn how to position them more precisely to fit the constraint of an actual layout where you will want to maybe center things, put an amount of space before and after, all of this stuff, and also style. So by styling, we mean things like setting a given font, a given color, everything that is about how the information is presented. And today, we're going to cover chapter 4, which is about buttons and state. There is still one more chapter after, so this one about lists and text fields, but I think it will be for next time because, as you will see, chapter 4 is also quite long. So I think I've said more than enough for the introduction. Just as always, this is being recorded live, so if you're watching live first, thank you so much for being here this evening. And as always, if you have any question, any remark, please make it in the chat. I do my best to answer it. And you're probably asking a question that people watching the replay already have. So you're giving them a voice, which is super cool. And I'm sure that they will thank you for it. So let's get started. Buttons and state. Before we get started, as always, I will make myself a bit smaller because I don't want to hide the code. The code is the interesting content in this series of videos. So, what are we going to learn in this section? We learn how to update the UI with state. So this word state here, which is introduced maybe for the first time, you will see is quite an important word, in this tutorial, but also in app development as a whole. You will often see the word state come up, and there is a good reason for it. We'll explore this today. So we'll explore how add state properties and buttons work to update the UI of your app by creating an app to roll a virtual dice. So by buttons, we mean something that you can tap on, and more generally, the kind of components that the user can interact with. So it's about how to handle events that are triggered by the user when they interact with the UI. So we'll add the functionality to increase or decrease the number of dice on the screen to play different kinds of games. So we'll be able to roll 1, 2, 3, 4, maybe even more dices. And for that, I guess we'll need to have, two buttons: one to increase the quantity of dice and of dices, and one to reduce it, to decrease it, and one button to actually roll the dice or roll the dices. I'm not sure. Yes, no, singular is dice, so it would be dices. Let me know if I'm wrong. So section 1 will be about creating a custom view, something that we've already done before. So actually, they refer to a previous chapter. So customize views with properties that we covered in the first video. We learned to factor out repeated elements of our interface into a custom view to make an app with multiple dice. So maybe dice is actually plural, and dice is like, we don't take an S. Okay, so 1 dice, 2 die. Okay, that's very interesting. Thank you. I didn't know that one. Or maybe I knew about it and I had forgotten about it. Okay, so that's good to know about this one. So create a custom view to represent a single dice, then use it to make more dice in your app. Okay, at least now I will not be making that mistake for the rest of the live stream. Perfect. So step 1 is creating a new iOS app project in Xcode. So as always, I've already taken care of it and I'm on this screen inside Xcode. So the project, how do we call it? we call it dice roller. All right. Oh, 1 die, 2 dice. So what's interesting is that here they said dice in singular. So maybe it's a thing about, I don't know, like maybe like British English versus American English, or maybe it's like the rules have changed recently. I know that in France there are a lot of words that had like weird spellings, and they updated it in the 90s. So maybe that's also the same thing but in English. So I'm creating the app called Dice Roller. So product name, and they let me know that I have Shift pressed. Okay. Then, all right, everything else is good. Swift UI, Swift, perfect. Gonna put it just on my desktop. All right. What's next? Next, we create a Swift UI view file named Dice View. So we've done it quite a few times in the past. So Command N to create a new file. We create a Swift UI view and we call it Dice View. It's been created right here. Let me make it full screen so that you can see and you have a lot of room to see it. Then we replace the body, the code inside the body with an image of a dice. And we are lucky because we have these images available in SF symbols. That once again shows just how useful SF symbol can be. So let me make it so that you can see the preview. So like that. So it's quite small, but it should still see. It should still be readable. Hopefully, we will make it a little bit bigger by adding some style to the image. And so they say exactly what I said. So SF symbols has images for all 6 sides of a dice. Change the number at the end of the image name to see each one. So we can try it. So 1, 2, 3, 4, 5, 6. And if you try 7, of course, it doesn't exist. So they only have a 6-faced die. And you can see here it's spelled correctly. So I guess they got it wrong in the tutorial. I'm going to hide the preview because I already show it in Xcode, and I mean, often I cover it and it's not that great. Okay. I see a question about which framework I would recommend to get a job. It's a bit, maybe I will come back to it later, but it's quite a difficult question to answer in a short way. But you can check out my website, swiftwithvincent.com, and I have an article on this topic. So actually, I think I would recommend that you check it out. I guess it's the easiest because otherwise it's going to take a bit too much time out of the main content. And yeah, you only have 6 face dice, so you cannot do Dungeons and Dragons and the other role games. Indeed, I wonder maybe there are like other dice in SF symbol, but under a different name. You can actually check it if you're curious to see whether or not it's available. Okay. Next step is to add a property to the view to represent the number of pips on the dice. So the number of pips, I guess, is the number of dots. I guess is the scientific number for the black dots. So I'm adding it. Let me add it so outside of the body, but it's still inside the struct dice view. Okay. Let me go back to Safari. And so they say that we use the assignment operator to give the property a default value of 1. We might have done it before in the previous chapter, but they didn't call it out. But here, this allows us to give a default value. But we can still provide another value through the initializer if we want, and it will override this default value right here. So here they go into a bit more details about this syntax we've just written. So they say that this property is marked with the keyword var. I explained this, the difference between var and let a little bit before. So, I mean, before in the previous video. So the keyword var means that you can assign new values to it. The word that you will often find is that the property is mutable. It can be changed. It can be updated. The opposite of it is let. So the opposite of var is let. And when a property is let or a let constant, then it means that it is constant. You can also read that it's immutable. And so it means that the value can never be changed. It will contain the value that was set when created, and it will never be allowed to change. And so this view is dynamic. You'll change the value of the property when people roll the dice. So that's why it's a var. When you assign a default value to a structure's property, it's not required in initializer. That's why you didn't have to change the dice view instance in the preview to include number of pips. It's true that before, when we only declare properties like that, we would have this error that says, okay, you're missing the value when you initialize and you need to provide it. But since we're already providing a default value, we don't need to provide one here. However, if you want, you can still override with another value. All right. Step 6, we are going to use string interpolation. So what allows us to inject more complex data types inside a string to display the dice image using the value of your new property. And they say experiment, change the default value of number of pips to see the corresponding dice images. So once again, I'm copy pasting, but if you're learning Swift, I would really recommend that you try to write it yourself. I'm copy pasting because it's easier and there is less room of making a mistake. But if you're learning or writing it, helps a lot memorizing things efficiently. So here we have 1, so we show the dice of 1. But if I put 4, you can see that now we should show, yes, we show the dice of 4. And I can put 1 here, but I can override the value here and say 4 or 5. So you can see how it works. So basically, from this value here, we derive the name of the SF symbol that we want to display. That's how it works. And this approach, while simple, is actually used quite a lot in production. I've used variation of this trick to generate a key for a resource, whether it's an image, a localized string, or any kind of file in a way, by having like a constant part and the part that changes depending on some value. It's actually quite a common pattern. So it's good that they show it in the tutorial because you will probably need to use it reuse it at some point. So it's good to know that, like the more tools you have, the more effective you can be. So this is definitely a tool that you want to add to your tool belt if you're a beginner. So step 7, now we're going to use some modifiers to increase the size of the image. The resizable modifier tells the image it can stretch to fill any available space. So remember in the last video, we covered the concept of intrinsic size. So right now the image has an intrinsic size, meaning that it knows which size it needs to display its content fully. But when we make it resizable, instead it will become the kind of view that try to occupy as much space as available. So it's interesting to do it in 2 times. First, we apply the modifier resizable, and now it takes as much space as possible. So really trying to fill in all of the space available. You can see it like that. You can see that it doesn't respect the aspect ratio of the image because the image is stretched vertically. And then we're going to add the frame modifier to say, okay, we want to constrain it to an available space of 100. So this view here is still trying to take as much space as it can, but now it's only offered this space of 100 by 100. That's why it no longer takes the full screen. But it's important to understand that the logic is still the same. It still tries to take as much space as possible. We've just constrained it into a smaller space. And you can see that if I do 200 now, it's stretched vertically again. So there is no magic here. It's just these 2 mechanisms of let's take as much space as possible and then let's take as much space as available and then let's constrain the amount of available space that allows us to give a given size to the image. That's why I wanted to highlight it because it's quite important to understand that this mechanism is twofold. And so, yeah, the resizable modifier tells the image it can stretch to fill any available space. You don't want the dice to fill all the available space, so you limit the image by setting its frame size. So actually, they did a great job of explaining it. So once again, congrats to whoever wrote this tutorial because they really did a great job at explaining things step by step. And so they say you typically match the size of SF symbols to their surroundings content using the font modifier, But in this case, you're using the image as purely graphical content, so it's okay to use resizable and frame. They say that because very often when you use an icon, it doesn't go alone. Very often, an icon, it accompanies a piece of text. Typically, you will have the save icon next to the text that says save. And so you want to have the same size for both the text and the icon. And so it's very convenient to use the font modifier for both. But here we are in this rarer, more rare. I'm not sure if you say more rare or rarer. Like rarer feels weird to say, so I will say more rare or less current situation where you actually want to display the image by itself. And so it makes sense to give it a size just like you would for any kind of image. So we finished section 1. Now we're going to add a button to roll the dice. So we are introducing this button concept, which is supposed to be the center of this chapter. So add a button to roll the dice. We're going to use a button to change the image of the dice. A button uses a closure to run code when a person taps it. Rather, I would say when the user taps it, because you could automate tapping the button in some way. So it might be more general than a person. So step 1, we're going to embed the image in a VStack so that we can add the button below it. So remember, you can do it by writing code, but you can also do it in Xcode. Right-click on the image, embed in VStack, it's done. So step 2, inside the VStack, below the image and its modifiers, start typing button. Code completion will offer you several suggestions. Choose the one with a title key and an action. If you see title instead of title key, choose that initializer. I guess there might have been different names depending on versions of Xcode, for instance. I think I'm just going to do control and I in order to re-indent the code. And so here, so button, and we want this one. So let's use it. 2 arguments, a localized string key, and an action closure. If they don't explain what closure is, I will do it just after. So don't be scared if you've never seen the word closure. I will explain it regardless. So we replace the first placeholder with the string role. So what's a localized string key? It's basically a string, except that when our app will be executed, SwiftUI will try to see if inside our app we have a localization for this key. So if we have a translation, basically, in order to match the language of the user. That's the difference. I won't go into much more details about this because I could spend much more time. If you want to learn more about localizing an app and localized string keys, it's not hard to find resources. That's why I'm going to stop here. I just want to give you the pointer on what this means. And now the second parameter. So action, parentheses, arrow, void. It's a closure that executes code when people tap the button. So a closure, it's really a piece of code that can be executed at a later time. It's the most simple way to define it. You could say it's a piece of code that you can assign to a variable and then call later. That's the easiest way to define it. And of course, when I say assign to a variable, it includes that you can also pass it as an argument. A more correct way to say it, a more generic way would be to say that it's an expression. It's the ability to write a piece of code that you can use as an expression. And expressions, they can be assigned to variables. They can be passed as arguments. They can be used in many kinds of contexts. So they say press tab to take the placeholder and then press return. I did it before, so that's why I went from this syntax here to this one right here. I selected the placeholder by doing tab and then I pressed enter so that I had this shorter syntax. Why has the name of the argument action disappeared? It's something that's called in Swift the trailing closure syntax, and the rule is that if the last argument of a function, here the initializer of a button, is a closure, then you can pass the closure after the call of the initializer. It's because it makes the code a little bit nicer to read. And actually, it's the same for VStack. VStack, if you look, we saw it last time, the initializer takes takes some arguments with default values, and then at the end, a closure. And we don't need to write the name of the closure, which is content, because it's the last argument of the argument list. So we do the same here for the button. And so they explain it actually here. Xcode removes the action parameter completely and replaces it with a closure contained in a pair of braces. There's a code placeholder inside the braces where you write your code for the button. Okay, so they don't explain it that well, so I'm glad I gave this extra information. So now we're going to replace the last placeholder, so the one inside the closure, with the code to choose a random number for the pips of the dice. And so it's the code that will be run every time we click on the button to roll the dice. And so we set the property number of pips with a random integer between the interval of 1 and 6, 6 being included. So how do you say roll in French? So in French, roll the dice would be said jeter the dé, and it's more throwing the dice rather than rolling the dice, actually. And the expression would be, there is the saying les dés sont jetés, and it's kind of saying like all bets are off, like the dice has been cast. Cast would be the more correct. Yeah, we say casting a dice more than throwing. Casting is more correct. And so yeah, we say the dice have been cast, but rolling. I don't think there is an equivalent, or maybe I don't know it, or it's less familiar. But it's more like a casting. Yeah, we say casting the dice, like we would say like a casting a vote, actually. So yeah, that would be the French translation. And you're right, like maybe I should do a video on localization one day. You know what? I'm making a note to cover maybe this topic one day, because I think I've never covered it. And there are things to say now. There are several APIs that you can use, so that might make for a nice video. Oh, we have interesting error here. Cannot assign property. Self is immutable. So I'm sure they will explain how to solve it, because otherwise it will be the end of the tutorial. So let's see how they explain it before I start explaining it myself. But first, they say a few things about the code we wrote inside the closure. So they say that int.random selects a random integer from the range inside its parentheses. So now we know that it's the range that we passed as an argument. The code 1.6 creates a range of integers from 1 to 6, 6 being included. Note, this is another example of using an assignment operator. This time you're updating the value of number of pips every time the code runs. Okay, and now there is an error in your code that you'll fix in the next section by changing number of pips into an addState property. So section 3, use state to update a view. So the word state is starting to make its appearance. So all apps have data or state that changes over time. When an app changes state, it may need to update its interface. However, SwiftUI doesn't monitor every property in an app by default. In this app, you'll need to update the image when a person taps the roll button. To tell SwiftUI to monitor number of pips and update the UI when it changes, mark the property with the keyword addState. So this idea that state is all of the data that changes over the time that your app is open is very central to app development. And one of the big challenge of app development, and conversely, one of the big source of bugs in apps, is whenever there is a lack of synchronization between the data, the state of the data, and what's reflected by the UI. Typical example is the UI is showing a value that is outdated, for instance. So there is a more recent value in the data model, but it's not reflected on the screen and the user can't see it. Typical example of a bug. And one of the core principles of SwiftUI is to try and make the UI depend as much as possible on the data. It's what's called having a reactive UI. And the idea is that as soon as the data changes, the UI is automatically updated without the need to trigger anything in the code manually. And if there is nothing to trigger manually, it means that you can't forget to trigger it. And so it's a whole category of bug that theoretically becomes impossible to happen. So SwiftUI did better than UIKit on this respect, because in UIKit you had to manually update the value of your UI components whenever your UI would change. And that's why Apple introduced the framework Combine a few years ago to try and have a way to make the UI depend on changes of data. In the iOS community, you had a very popular framework called Eric Swift that also tried to do the same thing. And they were all trying to solve this issue of how do you manage state at scale in a large app, which is arguably one of the biggest challenge that you have to face when you're doing iOS app development on an app that is large enough. But spoiler alert, you reach large enough quite easily. Actually, we all imagine like it's the very big apps, but no, even a single project that you work on for a month is large enough that you can get into some pretty tricky situations. So step one, make number of pips a add state property. Then tap the roll button a few times to check that the image changes. View state is owned by the view. You always mark add state properties private so other views can't interfere with their value. All right. So we mark it at state and we make it private. They put the private after the add state. I will do the same. So okay, so yeah, I remember that the rule. So whether you say like you say like closer instead of more close, it's when there is a single syllable. Yeah. So rare, I guess it's two syllables. Yeah, because there is re, r. Okay. Yeah, it's always hard for French speakers because, for instance, close. Yeah, you say close and closer. So close counts as a single syllable according to this rule. And rare, I guess it's rarer. Maybe it's rarer actually. It's just that it feels weird saying it from a French speaking, but like it's the kind of stuff that you learn in school and then you kind of do it intuitively. But there is always a moment where like you have a doubt and you don't have you don't have Grammarly when you're speaking. That's the difference between when I'm writing an email or written content. And yeah, okay, so that makes sense in a way. Just that it feels so weird to say it, but yeah, yeah, exactly, exactly. Like syllables, counting syllables when you're not a native speaker, it's always a bit of like you're making guesses, educated guesses, but it's very hard to get it right. Okay, so now the app should work. So if I click on roll, indeed, you can see that it works. We are rolling the dice. The UI isn't pretty, but we are rolling the dice. Let me make it a little bit bigger so that you can see it even more. But the app is working. We have a working rolling dice, which should be random because we can assume that this function is random. I mean that it's been like that. It's like correct in the sense that it's not. It's a fair dice. I remember that word. It's a fair. It's a fair dice. So I won't go into too much of the details of why adding add state solved the error message that we saw. I cover it a bit more in my other series about SwiftUI, which is called Learning SwiftUI when you already know UIKit. Actually, it's Learning SwiftUI when you already have some experience with iOS. So if you want to learn more about this error, I would recommend you check out this series of videos because I can cover it right now because you need to know a lot of concepts about Swift that are not covered in this tutorial, so I won't go into the details. But if you want to learn more about why adding add state solve the issue of saying self is immutable inside the body, it's very interesting to understand why. So I can only encourage you to try and do so. But if it feels complex, don't worry, it's normal because it puts concepts in practice that we haven't covered in this tutorial, typically reference types versus value types. So step two, you add a border to the button to set it apart from the image. So what we've done in the previous video, so adding style to our view. And what's interesting is that you can see that we use a button style this time. So we use a predefined style for the button. By the way, you can still you can create your own button style, actually. I will cover it in a future video that I don't know when I will release, but it's ready to be released. So I will cover this in a future video. But you can put, when you have several buttons with the same style, you can factor this code out into a button style. And here we're using one of the built-in button styles, which is to have this bordered button. So to have this border with rounded rectangles that is characteristic of what you can see inside iOS apps. I see a few messages, so let me go over them. So passing at state based on string interpolation is a technique I've been looking for. Thank you so much for that clear explanation with the example. Okay, so I'm glad that I've been able to unlock you because yes, I remember someone saying last time that they were stuck on this chapter, so maybe it was actually you. So I'm glad if you'll be able to be unstuck. And indeed, this part can be that's the part where like you need to understand what's happening in order to be able to keep making some progress. So like the key idea here is that the atState property is owned by the view, and so it's the data model, and from it we derive the identifier of the image that we pass to the image, which actually displays the image. You say I can assume it can be even more powerful with key paths. Yeah, and actually, SwiftUI makes quite a lot of use of key paths when you want to refer to a property. Can I do a learn Objective-C video when you already know Swift? I thought about it before, but people who want to learn Objective-C, I feel like it's basically only people working at that tend to work at Meta on Instagram or on WhatsApp. And the problem is that they are already super capable and they will learn it by just reading the documentation. So I feel like I like the idea, but I'm afraid it's maybe a bit too much niche at this point. But I did do a video where I was going over the code of my old personal projects from like 10 years ago, and some of them, 2 out of 3, were in Objective-C. So I kind of have this video where I talk a bit about Objective-C, but it's not a comprehensive course by any means. Okay, so next step, now we're going to make the transition fade from the old dice image to the new one. So we're going to animate stuff. So for this, we put our code inside the view, inside the closures we pass to the function with animation. And so they actually say it here, adding with animation instructs SwiftUI to animate any state changes that occur within its code, or rather within the closure that we pass to the function. It uses a trailing closure similar to the way that button works. So I change the code like this. So once again, there is nothing magic here. This is just a function that takes a closure as an argument. There is nothing magic. There is nothing hard-coded into the compiler. We are just calling a function and passing it a closure. And as a consequence, you can see that now there is an animation. We have a fade in out. And so the old die is fading out while the new die is fading in. And arguably, this is more agreeable to the eye. I'm not sure how much into details of how animations work in SwiftUI this tutorial will go, but if you want to learn more about this, once again, this is a topic that I cover in my other series of videos. So learning SwiftUI when you already know UIKit, there is a video dedicated to it. It's called, I think, Animations and Transitions. So if you want to check out more info about how animations work in SwiftUI, I can really recommend that you check this video out. And now we are into section 4. And section 4 is all about creating a dynamic display of dice. So we're going to add functionality to choose the number of dice by creating another property. So marking the property with atState ensures that the interface updates when the number of dice changes. So atState is really this way to say my UI depends on this piece of state. So when this piece of state changes, please update the UI automatically for me. And when you have this mechanism, it becomes impossible to forget to update the UI when what's inside the atState property changes. And that solves, as I was saying, a ton of bugs. So in the content view of the project, so let me go in the content view. So the basic content view that you get when you create a SwiftUI app, we're going to replace the content of the VStack with a title. So we replace the content with this text, which has the font large title and also lowercase small caps. Interesting. I didn't know this modifier. What does it do? It adjusts the font to enable lowercase small capitals. So this function turns lowercase characters into small capitals for the font. It is generally used for display lines set in large and small caps, such as titles. It may include forms related to small capitals, such as old style figures. So interesting. I didn't know this that you could do this. So this shows just how powerful SwiftUI actually is. And so they say you can use modifiers on the font type the same way that you use them with views. So you can chain other font modifiers on large title to see the effects. If you want, you can put the modifiers on separate lines, so large title, lowercase small caps, and then bold. So it's interesting because in the past, we've done something like calling the modifier font weight and then saying a font weight of bold. But as they are suggesting, instead, what you can do is that you can call the modifier bold on the font itself. And it does the same thing. The two are actually equivalent. So it's good to know. I didn't know, or maybe I knew it, but I forgot. But you can have also this other syntax. So both are valid. I would say in a project, just be consistent. Don't use one in half the file and the other in the other half of your views. Try to be consistent, but I would say that both syntaxes seem to be quite equivalent. Actually, no, there is one difference: is that here it's always going to be bold. So bold is kind of like hard coded, whereas when you pass in a font weight, so like that, you could imagine passing a different value as an argument depending on some value. So actually, this gives a bit more flexibility than the other syntax. So they are not. I mean, they're equivalent in the sense that when you call bold using both syntaxes, it does the same thing, but this syntax offer more possibilities than the other one. What's the next step? Then we add an H stack with 3 dice views instances. And they say try rolling each dice. So we'll do that. So let me add the H stack inside the V stack. So at this level right here. So indeed, we have our 3 dice. And I see Evolving Swift UI is saying lowercase small caps looks pretty cool. I had no idea it was present in Swift. We'll be using it in my apps for sure. Yeah, it looks pretty nice. And if you have an app where this kind of aesthetic makes sense, definitely, like if you're a beginner, don't use it everywhere. Like don't use it for a long copy of text typically, but for a title that is a little bit stylized, and in this case it gives a little bit of, like, I don't know, it gives a bit of a retro feeling, you know. So I think it plays really nice. So yeah, really cool of Apple to calling this feature out, because I had no idea that you could do it. Okay, so then to be able to display any number of dice, we're going to use a for each view. Repeat dice view 3 times using a range from 1 to 3. Type the code manually. For each has code completion options for many different uses. So right now we do a for each, but we do a for each with a static number of elements that we iterate upon. So inside the H stack, we put the for each. And so you can see that the content hasn't changed, because we say for each element, for each integer in the interval from 1 to 3 included, so there are only 3 elements, 1, 2, and 3, we show a dice view. And you can see here, we say that for the ID, we use the description. So for each needs to have an ID, meaning that it needs to have something to identify each value. And the reason is that SwiftUI will automatically animate changes, but if it animates changes, it needs to be able to say, okay, this item has moved to another position. And so it needs to be able to say, okay, these 2 items are the same. And this is done through a protocol called identifiable, which lets you declare an ID. Or when you don't want to do that, you can just pass a key path, which refers to a property that will be used as the ID. And so here we're using the description, which is the textual representation of the value. This might not be a best practice in production, to be honest, because description, they often say only use this for debug purposes. There have been situations where basically what can happen is that Apple can change what the description returns at any point. So this is not the best. But it's okay for this example. I see a great question. Does for each also requires hashable conformance or just identifiable? So what I would say is that for each requires, let's see, it depends on the init that you pass. But if you pass, actually, you know what? Uh, yeah, ID self also works, but I guess this, since it's a bit more complex to explain how it works, I guess they don't want it to put it in the tutorial for this reason, and rightfully so. But this is indeed much more correct. I won't go into what this means, but if you want to know more about it, I have a video on my channel that is about key paths. I think it's called "Why You Should Use Key Paths." Fair warning, it's quite an old video. It's like in my first 3 months of putting out videos. So it's quite old and dated, but the content is still valid, so you can check it out to understand what this syntax means. And so for each, I wanted to check the init that it has. And what I think is going to happen is that if I try to do the for each that only takes, so it needs to be a random access collection here. But actually, you know what, the best way is to just remove this argument and see what happens. So we have an error that says cannot convert value close range int to explicit argument of type ranged int. Oh yes, I'm going to make it like that. So actually this works. So actually for each, it seems that you don't need to be identifiable. Actually, you just need to be hashable, and integers are hashable by default. So actually, I think the reason why they have to do this is because they want to use the closed range interval. So by the way, what is the difference between this and this is that this says from 1 to 3, but 3 not included. So this contains 1 and 2, whereas this contains 1, 2, and 3. And for some reason, this, you can use it alone, but you can't use this one, the closed version of it. And the equivalent would be doing this, but this is more complex. So I understand that for tutorial, they took a shortcut and they said, okay, let's use this syntax, even though it might not be the most correct, correct one, or rather the one with the that's the more faithful to the best practices you would want to apply in a real app. And so the conclusion to this debate is that for each actually only needs conformance to hashable and not identifiable. It's list that needs conformance to identifiable. And you're saying, I think regardless of that, I feel like out of muscle memory, we would just use, yeah, when you already know SwiftUI and you're used to it, you would do \self. But I understand that for a total beginner, like this thing, like self has a whole new meaning here, and it feels weird. It feels so weird, the syntax, that when they released KeyPath, initially they didn't include this because they hadn't like considered that you would need this at some point. So yeah, it would feel weird for a beginner. Interesting. If you do for each where data contains objects that have a large memory footprint, will using \shelf be slower than conforming to identifiable and using ID? Um, I would say, and I haven't tested, so it's only like an educated guess, but I would say that using ID \shelf is probably the same thing than using the protocol identifiable, because under the hood, what it does is that the algorithm that SwiftUI runs under the hood needs an ID, and so it's going to access this ID either by invoking a key path on an object or by calling the property ID on the object. So honestly, I would tend to say it's probably the same thing, but I haven't measured it. So, and you should never make assumptions on performances without measuring. So I would say that conceptually it should be the same to pass an ID or to conform to identifiable. Now there might be small and subtle differences in performances, maybe, but if there are, I'm not aware of them. But that's a good point. Thank you for raising it. Okay. Here they say so the for each view is dynamic. It computes its subviews based on its input, which may change with the state of the app. You create a range using 1 all the way through to 3, just as you did it in int.random 1 all the way to 6. The for each view creates one dice view for each value in the range. So now this range, so 1 to 3 is static. To make it adapt to any number of dice, you'll again use view state. This time with state will be owned by the content view. So we have state owned across 2 different views. So to make it adapt to a number of dice, you'll once again use view state. I've read this before. Add a new state property for the number of dice. So we add this as an add state property of here the content view. All right. Let's see. So now we use a new property to make the range dynamic. And they say try changing the default value of number of dice to see how the interface changes. So instead of 3, we say number of dice. Okay. Let me resume the preview. And so let's see by changing the value here. So 1, 2, 3. And now I'm going to 23. Oh, so many dice that they actually render outside of the screen. What's the reason? I think it's because we've given them a frame that's static of 100 and it cannot go like smaller, I guess. And so that's why it goes completely crazy. So it's not perfect code. Maybe we will add some bounding in the number of dice that you can add, but at least it works in the sense that we've made the number of dice dynamic now. So next step. Below the for each view and the H stack, add 2 buttons to increase and decrease the number of dice. So we add an H stack after the other H stack. So here, we're still inside the V stack, however. So remove dice, add dice. Look at the code inside each button's closure. In Swift, you can use plus equal and minus equal to add or subtract from a property's current value. In this case, you're adding or subtracting 1. So number of dice plus equal 1 is the same than number of dice equal number of dice plus 1. And this syntax is so common in computer science that you have this shorthand operator that avoids having to use to repeat the name of the variable twice. And same thing here, this is the same than number of dice equal number of dice minus 1. Same logic right here. Okay. Try out the button to make sure that they work. So remove a dice, add a dice, and we can see that from 4 dice, it's when there are issues. And you can see that it starts like getting up like that because there is not enough space to display like the text. And so it's like it feels like a weird like insect, it feels super weird. But it's kind of funny. And you can go all the way. Oh, if you go to 0, then you have a crash. You crash the preview because the interval from 1 to 0 is invalid because an interval, the left value must always be less than or equal to the one on the right. And so this is just like dividing by 0 or force unwrapping a nil value. This crashes your app and your preview. So I'm just going to restart the preview. Okay. Step 7, reduce the number of dice to 1. Actually, it's what I did. So they show the preview crashes because the range 1.0 isn't valid. So step 8, to prevent people from tapping the remove dice button when there's only one dice view, you can disable the button to prevent the crash and give people a visual cue that the button is unresponsive. Use the disable modifier to disable the remove dice button when number of dice has a value of 1. So like that. And what we've implemented here is what's called actually business logic in an app. If you ever see this word of like business logic, it's about the logic of what the app does. And so here is the UI business logic is the rules of how the UI operate. And so you can see that now we cannot go lower than 1 dice. They give an explanation of what we've written here. So this expression right here. So you use the equal operator to check whether two numbers are equal. Notice that equal is very different than just one equal. That's one of the big difference between math and computer science is that in math, equal means equality, whereas in computer science, in most languages, at least all of the languages from the C family, so from languages that got their syntax derived from the C language, equal means assigning and equal means equality. So very important to understand this because otherwise it can be very confusing. So the result of this comparison is a bool, so a value, a type which has one of two possible values, true or false. When number of dice equal 1 is true, the modifier disables the button. And you're saying it's not called housekeeping. Yeah, that might also be like one of the nickname for this kind of rules. Honestly, I think every person has their own name for it. Every company, every like methodology has their own name, but the bottom idea is always the same. It's the rules of how the UI should behave. Like when should buttons be enabled, disabled, when should errors be presented to the user, all of these things, which might seem easy, but they are often like quite a challenging part because in many iOS apps, you will have many apps that what they do actually is that they get data and they send data to a backend, and the only thing that the app does, the only logic of the app is to actually manage the UI in a correct state. So that's why there are people that says there was a debate. Yeah, exactly. So there was a debate about like last year about what's the business logic. There were people saying an app should have no business logic. It should all be on the server. Yes, that's true, but it's like there is always something that is a logic and that serves something related to what the app does. So there is always an amount of business logic, and you can call it UI business logic if you want, instead of like data business logic. It makes total sense. But what I want to highlight with this is that like these words, very often they can feel like very complex. It can feel that there are subtle nuances behind them. But to be honest, I feel most of the time every person has their own word to refer to it and its own meaning. And very often people talk about the same thing, but with different words. One thing I've learned is that when working with customers, it's better to just say like the logic of the app and not try to go into any nuance because everyone has their own version of it, and people tend to feel annoyed when you don't have the same version of the vocabulary than what they do. So like to prevent conflict, I just use the word logic, and it has always served me well. So that's what I would recommend also doing. And yeah, exactly. You have people telling that all of the logic should be on the server, and it can make sense. Like for years, I worked on banking apps, and it's the kind of apps where all of the logic is on the server, almost all of the logic, because I mean, you cannot trust the app to make a transfer. Like it's the backend of the bank that should be trusted for this for very good and obvious reasons. And these days, I've worked on the photo room app, and it's the opposite. There is some business logic to store the data, for instance, but all of the image editing happens mostly on the app itself. A few things happen on the backend because machine learning and generative AI is costly to run on the device, but there is much more business logic on the app. All of that to say that the amount of business logic that you have in an app always varies, but there will still be an amount of logic left because ultimately the app has to do something. Otherwise, it's just an empty app that displays nothing, but it's not very interesting for the user. So step 9, the image of the dice are fixed 101 by 100 points. So only 3 dice images fit on the screen. Use the disable modifier with the add dice button to prevent people from having more than 3 dice. So same logic. When we reach a number of 3 dice, we disable the button. So you can have between 1 and 3 dice, but no less and no more. And now the UI is much safer and less bug prone, which is quite nice. Next section, adapt the interface for more dice. We're going to use flexible width and height to allow the dice image to dynamically resize based on the number of dice on the screen. So it's very interesting because it's a more advanced UI use case. So we're going to increase the dice limit to 5 and tap add dice until there are 5 dice. So we increase the limit to 5. By the way, in a real app here, you wouldn't have just these numbers written here, which is what's called magic numbers, but rather you would create a constant that would be, for instance, called maximum number of dice and minimum number of dice. This way, you give meaning to these numbers. Otherwise, it's what's called a magic number. And you're saying, FYI, SF Symbols has a dice and a dice fill symbol. Oh, that's nice. Let's have a look. So if it's like fill, so it's not like that. Oh no, there is something else also. So it should be something. So let me see. You can do like dice like that. Oh, like that. And okay, so it could be used, for instance, if you had several tabs in your app, you could use it as the icon for the tabs. So that's pretty cool. That's pretty cool to know. Thanks for mentioning it. Okay, let me go back to the tutorial. So they say an hashtag view always gives its subviews their requested size, even if it needs to extend beyond the bounds of the screen. Very important to keep that in mind. The parent view offers like the parent view informs the child view of the available space, but if the child view wants more than this, it can still draw outside of the parent. And so they say that you need to pin the content view preview, then switch to dice view. Okay, so what we do is that we pin the content view preview, and then we switch back to dice view. This way we can still see the content view while we are updating the dice view. Okay, how do we update it? They say use a flexible frame to allow the dice images to shrink and tap add dice until there are 5 dice again. So instead of frame width and height, we use max width and max height. I think we used it with infinity last time. This time we're giving actual values, so we're just renaming width to max width and height to max height. And it means that it will try to take as much as this width and this height, but if there is less available, it will take less. You can also give mean width and mean height in order to give a minimum size. We'll see if we use this or not. And they say, try to add more. You can see that now they all fit. They just don't preserve their aspect ratio because here, since there isn't enough space to fit enough squares, they start. I mean, it's not that. It's more like they don't have enough space to fit 100 of width, but they do have enough space to fix 100 of height. So the width gets compressed, but not the height. Hence the lack of the square aspect ratio. Maybe we try and fix this. That's what they say. Now that the dice images are flexible width and heights, the H-tag can shrink them to fit on the screen. But when there are 4 or 5 dice, they are stretched vertically because there's nothing above or below the H-tag to limit its height. To prevent this, set the aspect ratio of the dice image to 1 and tap add dice until there are again 5 dice. So indeed, you are indeed giving the correct solution. So using resizable, which is already the case. And we can use scale to fit, which is a shortcut for what we're about to do right now. So they say to provide an aspect ratio of 1, so square, and content mode fit. So it says that we will try to fit the view in the available space on the opposite of fill, where fill is going to try to take as much space as possible, and it doesn't solve our problem. What do they say? They say that a 1 or square aspect ratio has equal width and height. So when you divide the width by the height, you get 1. That's the definition of a square. The fit content mode means that if the image doesn't have the same aspect ratio as the available space, it will shrink to the smaller axis and leave empty space on the other. Here, since the image is already square, it's not the case, but if we had had an image either in landscape or portrait aspect ratio, we would have seen a difference. And indeed, as you were saying, Yash, instead of doing aspect ratio content mode fit, you can just do scaled to fit, which does the exact same thing. It's just it's a shortcut. One thing that's important is that I think that if you put it in an other order, okay, no, it's still okay. This one is still correct, but yeah, don't put it before the resizable because resizable can only be applied on an image. And when you call this modifier, you've lost the information that it's an image and not just any kind of view. So once again, the order does matter. And they put it after the frame, so I will put it at the same place. Okay, so you can see that using flexible width actually in SwiftUI is quite simple. You just use the frame modifier with max width, max height, and if needed, min width and min height. This is easier than in UIKit, where you would have needed to put probably like a stack view and then play on the compression resistance and content hugging priorities. And it's quite confusing, to be honest. Even after years of doing iOS, I still get confused by it. So that's one of the things, to be honest, that I really like about SwiftUI. These nice modifiers that make quite advanced UI use cases very simple to implement. Because it's advanced, it's also very common. And arguably, you could say that a criterion to judge how good a framework is whether it makes common use cases easy to implement. Next section is using images in button labels. So we're going to customize the add and remove dice buttons to display images instead of text. So in content view, add another argument to the add dice button to add an image. So we can pass a system image if we want. So we'll do it for the add dice button here. So like that. And we can see that we've added indeed an icon on the left of the text. And they say the view a button displays is called its label. In many cases, you'll use a combination of images and text for button labels. For this button, an image is enough to tell people what it does, but a button should always have a text label, visible or not, so that it's available for people who rely on features like VoiceOver. So what's the feature that reads the content of the screen, the accessibility feature. So we're going to hide the button text using the label style modifier, and this time use icon only. You can notice that we pass it on the H tag and not on the button, and they say even though the modifier affects both buttons, the remove dice button still has a text label because it has no icon to display. And how is it possible that we apply the modifier on the H tag and it still has an effect on the buttons? It's because the data is passed to the child views using something called the environment. I won't cover it into details, but you have it covered in details in my SwiftUI videos. You're saying, can min sizes be a priority? So absolute minimum size physically, proportion of the parent view size. Yes, you can do it. So if you want to use a proportion of the parent view size, you will want to use a geometry reader, which allows you to get the size of the parent, and then you could take the width of the parent and then divide it equally, for instance. So you could do it like that. I mean, if you want to divide equally, that's what we already did. It's useful if you want to divide unequally. Maybe give 20% to the first view, 10% to the second, and the rest to the other, for instance. And absolute minimum size physically, yes, absolute minimum size physically. So you have the min height and min width arguments actually. So like here you see you have like you have the min width arguments along with max width and min height along with max height. So this is indeed absolutely doable. Both would be doable. So first one with min width and min height. Second one with a geometry reader. Okay, so we have the icon for the second button. And then what else do we have? So increase the button size using a title font. Once again, we apply it on the H tag so that it gets distributed conceptually to both the child views of the H tag. So we can see the button is now bigger. See a good remark. Jetpack Compose does this really well with modifier weight, where you can make a view take up a proportion of the view. Oh, that's nice. Indeed, it's smart to be able to have this very declarative approach. I'm sure that you can probably like re-implement it in SwiftUI. Maybe some people did in open source. Sorry about that. Sorry for your eardrums if you were listening with headsets. But thanks for mentioning it, because I haven't really tried Jetpack Compose. So thanks for mentioning it. And indeed, like, it seems like a smart API to be able to give a weight, and then the relative difference between the weights gives the result. Um, and yeah, you can also like maybe multiple spacers, even though that's a good question. Like if you put two spacers, like if you put like two spacers on the left and one spacer on the right, does it take more space on the left than it does on the right? To be honest, I'm not sure how it works. I'm not sure if because since like spacers should represent infinity, like, you know, like infinity plus infinity is still infinity. So I'm curious to see whether spacers can implement this notion of weight or not. That's a very, very good question. I will try to test it afterwards. You know what? I will put a screenshot. I'm screenshotting your comment, because if it does, it will make a great topic for a video in the future. So I will try. I will try it. Okay. And then, as you can imagine, we use an image for the other button. So this time, minus circle fill. And we have our plus and minus buttons that look a bit more like what we would expect to see. And what's nice is that since they move a bit, their movement is also animated, and it's because since the height of the H tag changes, then the position of the button also changes by way of consequence. All right, section 7, improve your app design. So we're going to style the buttons and dice and give our app a background color. So they say, add a background color set named app background. So we've done it last time, so I won't cover into details. And they say, choose your color set names carefully. I would even say choose all of your identifiers names carefully. Some names, like background and blue, conflict with existing system-defined color. Oh, that makes sense. Okay, so create a background color, and we're going to call it, to give it these values. So let's do it. So I go into the asset catalog here. So we create a new color set. I'm gonna call it background color, like that. It's gonna be a single value for both light mode and dark mode, and I need to give it its value. So they put it in a display p3, which is a different color space. I won't go into detail of what the color space is, but basically it's the amount of colors that can be represented by the screen. And so the wider the color space, the more colors you can display. Like now the analogy might not speak to people who are younger, but back in the 90s and early 2000s, when there was a lot of like improvement, you could see that you had computers that could display first like tens of thousands of colors, and it was like a marketing argument. Then it was like millions of colors, and it used to be like one of the marketing arguments that you would have. That's how they marketed computers to you back then. Just like saying, like, you know, like 100 songs in your pockets for Xcode is the same thing. I'm going to move the window so you can see what I'm typing. And so the values are 0.208. So 0.208. I need to put a comma because my computer is using the French local. So comma 478. So comma 478, like that. I don't think I've ever used monochrome console monitors, to be honest. I started like with like Windows 95, so we already had like things that kind of resembled a modern UI, except that it was like the screens were super small and they were killing your eye. But that's all we had back then, so it was still kind of nice. Okay, so that's the color that we have. And as Yash is saying, we're going to see that Xcode is going to automatically generate a code identifier for this color name, which is pretty cool. So let me move the window back to full width, and let's go back to the code. And so we are going to use it around here. So yes, we set a background. So on the VStack of the content view, and okay, they have called it app backgrounds. You know what? I'm gonna do the same than they do this way. There is less chance of making a mistake for people who are following the tutorial. And so here, background will be app background like that. And so this is an identifier generated based on the name of the color right here. And it's a new feature of Xcode 15. Before that, you had to either pass in the name of the color as a string, which is not type safe. It's not checked by the compiler that the color does exist. And you had to use third-party tools from the community, which were great to do this. But now Xcode does it out of the box, and it's a pretty cool new feature. So then they say use the tint modifier on the VStack to apply a global white tint to the app because contrast is a good thing for a beautiful UI. So like that. That seems better. We can see it doesn't apply to everything. Interesting. Maybe they explain why. The tint modifier only affects views that rely on the accent color, typically controls such as buttons and toggles. Views use tint in different ways. For example, notice that the roll button gained a subtle white background. Oh yes, indeed. The background changed a bit. And so they say, change the color of the text view to white using foreground style. So we do this on here, the dice roller title like that. So now it's in white. And to make the background expand to fill the screen, use a frame, pass infinity for the max width and max height parameters so that the frame will expand in both directions as far as it can go. So we are saying that this view here, this VStack, so what's in blue, should take all of the space available. And we do it like we saw last time by passing a frame, by calling the frame modifier with a max width of infinity and a max height of infinity. And it covers all of the space available, including space outside of the safe area. So including space like around the dynamic island and around the app switcher at the bottom. And yeah, why did they change it to foreground style and deprecate foreground color? I guess foreground style is maybe a bit more generic because it takes a style, and so a color is a style, but a shape apparently is also, a shape style. So I think it makes it more generic. That must be the reason. But at the cost that foreground color was a bit more explicit. But they made that change, fairly recently, because at the beginning it was just like foreground color and the background color, and life was simpler back then. So step 6, classic dice are solid white with black pips. To make the dice face solid, open the dice view fill and use the fill variant of the dice symbol name. So we're going to add a fill at the end, so here. So we add after the number of pips fill. So now they are filled. Okay. And now set the foreground color of the dice to white. Notice that this changes the dice to white, but leaves the pips transparent. So we are playing on transparency in order to have the pips be the background color that way. Well, that's quite nice. That's quite nice. I think maybe now some symbols, at least in SF symbols, have different layers, and so you can color the symbols in different ways. So maybe it's also possible to for this one to cover the border and the pips in different ways. Actually, I'm not sure, but if you want to try it, you can definitely try it. And you're saying Jetpack Compact composes way of the infinite frame is just modifier fill max size, fill max width, and fill max height are also alternatives. Yeah, it makes sense, and it kind of makes sense because Android, their previous systems which use like XML to declare the view, what you would do is that when you declare the view for its width and height, you would say either wrap content or match parents. So I think they probably wanted to have something that had the same level of expressivity and simplicity. So that's why I guess they did the fill max size. But in a way, if you wanted, you could create your fill max size and another hood called frame max width infinity, for instance. So you could always build it for yourself if you wanted. To be honest, I would still recommend to keep with the basic modifiers because it's much more easier for someone else to understand your code. But in a way, I think you can. I think here it's more a question of like naming and encapsulating, but I don't think there is a question of like one allows you to express more things than the other. But I might be wrong on that one. Okay. And now we're going to make the pips black. So actually, we do the thing where we pass in several colors. Great. So it's possible. I was right. So to make the pips black, use two foreground colors, one primary and one secondary. Use the foreground style modifier to set the primary color to black and the secondary color to white. And it probably also answers your question, Yash, of why they did foreground style instead of foreground color, because you have the flexibility apparently of passing more than one argument. And maybe this flexibility would have been harder to get with foreground color because then you would have to call it like foreground color and foreground colors. But then if either you have two of them or you have just one but foreground colors, and most of the time people will only pass one color, so it feels a bit weird. So that might be the reason why they chose this name of style, which is a bit more generic. But yeah, same. Like I never knew that you could do it, or maybe I saw it in a WWDC video like 1 or 2 years ago when they added the feature, and then I forgot about it, as it's always the case of like most of what you see during WWDC week, because so much content, but then the hard part is remembering it for the long run. So let's make actually this change. So let's go back to Xcode, and then I will read the longer explanation. But now we have the result. Wow, it's nice. It's nice. And you're saying, yeah, you would expect a foreground to only have one color, so two colors, a bit difficult to visualize. Yeah, it's like foreground style, and then you're passing an array of colors with the primary color and the secondary color. And then I guess the idea is that it's up to the view to interpret this as it makes sense for it. So an SF symbol in image interprets it in a way, but maybe your own views could interpret it in a very different ways. And so what we're seeing is the effect of SF symbol palette rendering mode. So it's the official name of this like layered coloring that I was mentioning. For the field dice symbols, the pip assumes the primary color while the rest takes on the secondary color. Note, some SF symbols are composed in a hierarchy with different elements that can take on primary, secondary, and tertiary colors. There are 4 symbol rendering modes which you can set manually using the symbol rendering mode modifier. You can read more about rendering modes and much more about SF symbols in the human interface guidelines. Remember, you can access them in Xcode by doing Command, Shift, and H. quite a fun shortcut that actually like opens Safari out of nowhere to the human interface guidelines, which I recommend that you explore because it's a great resource as an iOS developer. Okay, actually, end of the chapter. So let's check our understanding. Then we will have the recap, and I will stop here for today, and I will do the final chapter in the next video. So the quiz. This time there are 4 possible answers instead of 3. So select all true statements about view state. First one, SwiftUI automatically updates a view when the value of any of its add state property changes. This one is tricky. This one is tricky because up until iOS 16, it was the case. When a property that was at state would change, the body would be computed again. However, in iOS 17, when you use the observability that iOS 17 introduced, there is a change, subtle but important, is that SwiftUI will only recompute the body if the add state property was actually used inside the body. So it no longer recomputes the body when the property add state was not used. But here, I guess, because they haven't gone into this level of detail here, it's supposed to be true. But if you use an app in iOS 17 with iOS 17 observability, then it's not always true. However, for you, it shouldn't make any real difference. It's more of a performance question than a conceptual question of how your view behaves. So this one should be true. You mark at state properties with the public keyword. No, it's the inverse. They should be. How do I select more than one? Like, how do I select more than one actually? Uh, I don't know how I should select more than one. With Shift, it doesn't work. With Command, it doesn't work. I have no idea how I'm supposed to select. Or maybe all of the other ones are false. If that's the case and all of the other ones are false, it's kind of a very funny way to phrase the question. But you mark asset properties with the public keyword is not true, so it's false. Use modify to change the value of a state property. No, you just assign a new value, so it's false. And you can change the value of a view's state property from outside the view, so it's false also. So only this one is true, and okay, that's why you cannot select multiple ones. But yeah, okay, funny way to phrase the question. So I was correct. That's the only true statement. A state property connects your view to the SwiftUI state management system. I see a few comments. So pronunciation tip, hierarchy is clear said, starting with a hard H for high, so as in high. So hierarchy. Okay, so hierarchy. All right. Is it like a thing where like British and American have a different way of saying? But okay, hierarchy. Yeah, it kind of makes sense. It's true that hierarchy, it feels really like the way we say it in French, but hierarchy might be okay. That's a good one because I didn't thought of it at all. So thank you for this one. Hierarchy, yes, makes sense. And I think state has always been property based. It was just at state object that did object level change tracking. So yes, at state has always been property based indeed, but they've unified this even more in iOS 17. There are less different ways to annotate state. And you're saying the last one can be true, but hopefully you never find yourself in that situation. Yeah, indeed. And also, I mean, since like views are structs, to do it would be like very convoluted in a way, and would also like kind of like defy the purpose of how you are supposed to write SwiftUI code. So yes, it's more like you're not supposed to do it, rather than it's technically infeasible to do it. And yeah, maybe it's more British. Maybe actually it's more British. Yeah, that might be the case. Okay, what's the correct button code? So this one, oh no, this one has a parenthesis here, so it doesn't seem correct. This one seems similar to what we use. We pass in a string for the title of the button and then a closure after. This one feels very like Python-like, but it's not Python. And this one feels, this one is interesting because this one gives the idea that you could add the closure afterwards using a modifier. And this is not the correct way to do it, but it kind of allows me to answer a question you might have, which is why are some arguments passed through the initializer and some others passed through a modifier? So just to make sure that I said it correctly, why are some arguments passed through the initializer and some other passed through a modifier? The reason is that when you give arguments to initializer, you are guaranteed that all arguments will be given a value, either a default value that you provided or a value provided by the caller. On the other hand, you can never guarantee that a modifier will be called. So here you could say, for a button, having an action that can be triggered when the button is tapped, it's really part of what the button does. A button that doesn't trigger any action has no sense, has no meaning, has no reason to exist. That's why it makes sense to pass the closure action as part of the initializer of the button, because a button without said closure has no reason to exist. On the other hand, something like changing the button style makes sense to do it through a modifier, because some buttons you might want to change their styles, some other you might want not to do it, but a button with no change in the style still has a good reason to exist. So that's the reason why there are these two design patterns in how in which place is the best to declare an argument. if it's mandatory, or rather, if it doesn't make sense for the component to exist without it, then it should be done through the init, otherwise through a modifier. Um, and so this is the correct one. A closure contains code in braces. Okay. How do you disable a button? So interestingly, so it's disabled disable true is correct, but there might be a shorter version where you can just say disabled without passing true with a default value for the argument. So actually, let's just have a look here in the content view. If we look, so actually, no, it doesn't seem that you can just do disabled. It seems that you always need to pass in an expression. Yes. So you always need to pass in an expression. It makes sense that there is no shortcut, because having a button that is always disabled doesn't really make sense. The only reason to do it is like kind of like a scaffolding, like you haven't finished building your app, and so it's always disabled. But in production, a button that can never be enabled should never be there, because it means the closure can never be called. So it maybe make it a text in that case, but don't make it a button. So it makes sense that there is no shortcut where you have a default value of true by default. And so it's a good question that they ask, because it shows this subtlety, and you need to pass true because you need to explicitly mention that the button will always be disabled. And this should highlight the fact that that's not really something that should happen. There should always be a reason for the button to be enabled. But you can still express this by explicitly passing the value true. Okay, so as always, there is a quick, it can be a bit long, but there is a wrap up and a recap after the chapter. So let's cover it. So this chapter covered buttons and state. So button state and closures are key components of SwiftUI, and closures are even key components of Swift. They enable your app to respond to user actions, which lets you create powerful and expressive interfaces. So which concept have we learned? Before this tutorial, you wrote exclusively declarative SwiftUI code that describes how an app looks and functions. For Dice Roller, you needed to interact with your app by tapping a button. A button uses imperative code inside its action closure, which SwiftUI runs when someone taps it. So the difference between declarative and imperative, I'm going to sum it quickly, even though it's a topic that you can really explore at length, but declarative code says what should be built, but don't say how it should be built. So when you say I want a text with this font, you're not saying which object should be created, how the character should be displayed on the screen. You're just saying I want a text that displays this with this font, and then it's SwiftUI jobs to actually do the imperative part. And for a button, you need to have an imperative part, which you do for a closure, and the imperative part is code that says step by step what's happening. So take this value, increase it by 1, decrease it by 1, set a random value to it, etc., etc. Was there any reason why toggles weren't used for today's button at all? You mean toggles? What do they look like, toggles in SwiftUI? I'm not, you know what? I'm not sure. I have like, I see the ID, but a toggle is when you want to switch from one state to another. So we have a toggle. What does it look like? Okay, what could be its style? You can give it a label. I don't know if I say like hello, for instance. No. How do you create a toggle? I'm not sure how you create one. Maybe I can see it. Okay. Oh, okay. So yeah, so toggle, okay, it's the on-off. Okay. So it's the on-off. Okay, it's the thing to say whether it's on or off. Yes. So two things. Yes, toggle use binding, which is a way to pass state to a child view in a way that the child view can mutate it. So it's a bit more advanced. So okay, your question was more, why didn't we use a toggle rather than why didn't we use a toggle to implement the UI? Because I was like, where would you use a toggle in this UI? Okay, so I understand your question now. And yeah, to understand toggle, you have to understand binding. So maybe they will mention it in the next chapter. Otherwise, I've covered bindings in my more like advanced tutorial on SwiftUI, so learning SwiftUI when you already know UI kit. So you can check this out after, and you will see how it's covered. And yeah, indeed, Wi-Fi on and off, plane mode on and off. So it's a toggle. It's a toggle indeed. Um, all right. Yeah, and I was thinking also like toggles. I'm always confused because toggle wasn't called toggle in UI kit. I think it was called the UI switch. That might be the reason why the name toggle always like I have a hard time like thinking what it is because for a very long time it had a different name. Let me just see like is it like UI? Yeah, UI switch indeed. But toggle is a more correct name in a sense. And yeah, so radio button is different. Radio button, it's a set of buttons, and only one of them can be enabled at the same time. So like when you push one button, it pops the other one that was already enabled. So it's still a different beast. I think you can enable radio buttons in SwiftUI. It's by using something that's called a segmented control, if I remember it correctly. Let's get back to this. So we were here. So take a look at the declaration of a button initializer. The part here, so parentheses arrow void, after the action parameter is a closure type. The empty parentheses and the void following the arrow mean that this is the simplest form of closure, one that takes no argument and returns nothing. It just implements side effects. You can create one with a pair of curly braces containing the code you want to run, for instance, like this. The example above demonstrates trailing closure syntax, which you can use when the final parameter of an initializer is a closure. And actually, not just an initializer, any kind of function. It works with any kind of function. We saw it when we called the with animation function, for instance. If you prefer, you can include the action argument label. Here's how you'd initialize a button of this type without calling a closure. So this code here is the same as this code right here, except that here you've written everything, but you have this shorter syntax that's available in Swift. I see a suggestion about one of the, yes, I'm making a screenshot of the suggestion about how to implement the init with NSCoder. Yes, that's a good idea. That's a great idea. So I'm making a screenshot of it. So which topic and skills have we covered? Creating and customizing buttons, customizing them either through the action that they run or through the button style, which is a way to style the button. Executing code with closures, the trailing closure syntax, updating a view with add state properties, and creating a dynamic number of views with for each. If you want to continue practicing, so to go further, you can extend the app we've written by changing the button order shape by the button border shape of the roll button to a capsule. So rather than a rounded rectangle, rather a capsule, which is a slightly different shape. You can customize the remove dice and add dice buttons using the symbol rendering mode, maybe to put a different color on the plus and minus, for instance. Maybe have the plus be green, the minus be red. Why not? 3, instead of having an image of a dice and the roll button benefits, modify dice view so people can tap on the dice itself to randomize it. So to make the dice the button itself. And actually, this is easier to do than what you would imagine, because the tricky part here is to understand that a button here, we've given it just a string, but there is another initializer where you can give it what's called a label, and the label can be any kind of view. So you can move the whole dice view inside the button, and it will work perfectly. And you're saying bordered prominent makes it like a capsule shape. Actually, I'm not sure. I'm never sure what the button style look like. So let's actually try it. You know what? Where was the button style used? Was it? No, it was in the dice view. So let's try to do bordered prominence. So it seems it did something different, but we don't have a capsule shape. A capsule shape here, you would have like half circles on the left and on the right. So that's what a capsule shape would be like. So apparently, prominent border does something else. Yeah, tapping on a dice, I guess it feels very weird when you are an English native speaker. And if you want to challenge yourself, so here often it's a way to go further, but which is more complex, or rather that requires more autonomy on your part. So they say create a simple button app. So start a new Xcode project and create a 1 or 2 button app of your choice. You can use the design a simple app project to help you come up with an ID. So it's more like think about something that can be done with 1 or 2 buttons and implement it. So typical example would be generating random numbers, but it's arguably what we've done already. It could be also I know it's what we in the Swift data part, which comes later, but which we've already covered in previous videos. There is something like that where you generate, I think, random facts about numbers. There is something like that, or it could be just like displaying also like a random colors, stuff like that. Or it could be like I was about to say like guessing a number, but it requires a text field. So we'll see that just after. So actually, yeah, try to find your ID. Try to find your own ID and try to see if you can implement it. That's the best. And here there is two things to learn more. So reading about buttons in the human interface guidelines and watching the Demystify SwiftUI WWDC sessions from I think it was from 2021, if I'm correct, because I remember watching it in my old apartment. I really recommend watching this one because it goes into a lot of details of like how SwiftUI works under the hood, and the minutes you will spend watching this will be very, very, very well spent. I see a question. Will the editor take me to a new view if tapping the buttons invokes that view, or must I also switch to that in preview? So if you navigate to a new view, it will work in the preview as long as your view is also embedded in a navigation stack inside the preview. So it's just a question of whether your view is inside a navigation stack. It's not linked to the preview itself. It's just like, is it in navigation stack? And if not, then in the preview, you will need to add it in the preview if it's not in it by itself. But otherwise, it should absolutely work. And what will be next? So for the next video, for the final chapter, so dynamic behavior often extends beyond managing 1 or 2 pieces of data. Many apps manage a collection of things like contacts that might change in quantity. In the tutorial, you'll use an array to store a variable list of data and a for each view to create subviews corresponding to each item on the array. And you'll learn how to add items to the array using another iOS essential feature, the on-screen keyboard. So next time, it will be about creating dynamic content. So we'll do it live. We'll do it live not next week, because next week I should be in the US if all goes according to plan. So we will probably do it in 2 weeks, unless I'm sick when I get back from the US. So then it will be in 3 weeks. But normally the final chapter should be in 2 weeks. Yeah, I just have to say, so as always, a big thank you to people who watched live and who asked great questions and made great remarks. Always make it super enjoyable for me, and it really like elevates the quality of the replay for people who are watching the replay. So thank you. And am I going to Dub? Yes, I am going to Dub. I got the invite last week, and I still need to book the flights and hotel. I need to do it tomorrow because the prices are rising. But yes, I will be going to Dub. So I'm going to the US next, not next week, like in 2 days. And then I'm going back in June again. So very fortunate on this front. So if you see less live streams on the Mondays, that will also explain why. But yeah, it's gonna be exciting, and I will try to create a bit of content while I'm there. So if you have any ideas for content that I could create while I'm there, let me know in the comments on Twitter, on LinkedIn, wherever. I'm all ears. I'm not saying that I will be able to do everything, but the more ideas I have, the better I will be able to do stuff. And of course, looking forward to meeting anyone else that will be also going there. Yeah, a vlog would be nice. The thing with a vlog is that a vlog is always surprisingly harder to do usually, but more like smaller content on social media. I have the Ray-Ban Meta glasses with the camera, so that will be pretty cool. So I will try to. Oh yes, and showing the snacks. Yes, yeah. I remember the snacks were really nice, good quality, and like there were so many like Haribo candies available for free. It's like I mean, it's not good for your health, but having that like you can grab it or grab a Starbucks coffee for free. it was amazing. I mean, I still remember I went in 2019. I still remember that 5 years later. So it shows that it was quite memorable. All right. And for today, it's time for me to go to sleep. I need to catch on and get some rest before I go to the US. So yeah, just have to say like thank you for watching and see you in 2 or 3 weeks for the final part of the tutorial on how to get started with iOS with Swift, Xcode, and SwiftUI. Thank you for watching. See you next time. Bye bye. Hello, what's up, everyone? Welcome to the fourth and final part of this tutorial on how to learn how to develop on learning how to develop iOS apps with Xcode, Swift, and SwiftUI when you are a total beginner. So, what have we learned in the past three videos? So in the past 3 videos, I've used this tutorial, so develop in Swift made by Apple. You have the link in the description of the video. And we've covered the basics of how Xcode works. So Xcode, the software that you use when you want to create apps for any kind of device in the Apple ecosystem. Then we saw the basics of how views, structs, and properties could be used together to design simple but yet interesting views. So we did a simple weather app, and we saw that with this concept of putting together stuff inside views and subviews, we could reuse, and so we could build increasingly more complex systems. Then we cover layout and style with the basic of how to layout and style a SwiftUI view. So how to position elements precisely where you want them on the screen and how to style them. And by style, we mean things like color, font. It's mainly color and font, actually. I'm trying to think of a third one, but what could be style? Yeah, color, font. Is there a third thing that comes to mind when you talk about style? I'm not sure, actually. If you have an ID and you're watching live, let me know in the chat. But yeah, style, it's mostly color and font. Arguably, size could also be part of the style, even though it's also part of the layout. But style and layout are very interlinked together. Then in the previous chapter, so we covered buttons and state. So we saw how we could put in our UI. Oh, a great example. Yes, adding border and strokes. Yes, we covered that. And of course, I have already forgotten about it. But yes, so adding a border or a stroke or any kind of I don't know how you say it in English, but in French you would say like dressing up the text. I'm sure there is a word for it, but it's basically like everything that you put around the text. It can be also things like putting the first letter super big, this kind of stuff. But yeah, also like in styling, it can be things around text like we didn't cover it, but the space between characters or the space between each line also that can be customized. Actually, we saw how to make a font monospaced, for instance. So that was also a great example of how to style text to fit a specific context. Yes, outline would also be a great example. And so, previous chapter, so buttons and state, we saw how to lay out special UI components called buttons that the user could interact with. And when the user would interact with these buttons, it would change the state of the app, and then the UI would update itself in order to reflect the new state of the app. And today we're going to cover the last chapter of the tutorial, so called lists and text fields. And we're going to see how to create a dynamic interface in which user can enter data. Before, user could enter data, but in a very limited way. They could like add a dice or remove one, and they could draw the dice. So that was data entry, but you couldn't enter arbitrary data. When you have a text field, you can enter text and you can enter arbitrary text. And we'll see how you build such a UI. And we'll see that it's quite interesting because building such a UI actually needs you to be able to pass ownership of, or rather to not to transfer, but to give access because you don't transfer the ownership, but you give access in reading and writing to a piece of data by a subview. And we didn't cover that up until now. So that will be the main focus of today. So let's get started. So we'll create dynamic content. We're going to use text field, list, and binding to create dynamic content. So this binding stuff, it's what I was mentioning, is the way to give a subview a read and write access to a parent view. So if you've ever typed on an iPhone, you've used a text field. And arguably, every single iOS app, not every single one, but almost every single iOS app uses text fields, whether it's to log in, to search, to set up any kind of form. At some point, you will need to have a text field, even if it's a game, to enter the player's name. It's almost like there is no escaping using a text field. So it's very important to understand how this component works, not only because it's like the poster child for a component that needs to read and access a state in read and write, because of course, if you're writing a text field, you need to write the data somewhere, but also because it's the typical component of any iOS app. So in this tutorial, you'll build an app that lets someone enter a list of names and then select one at random by tapping a button. So we can see that this part, select one at random by tapping a button, is quite similar to what we did in the previous chapter. So we can see that we are building on the knowledge that we've acquired just before. And that's one of the reasons why I think this tutorial from Apple is really nice, because it like introduces concepts incrementally and it builds on what was introduced in the previous chapter. So this way it makes it, I think, very easy to keep everything fresh in mind and not forget things as you are learning newer things. Let me make myself a little bit smaller because I don't want to hide the code, because the code is way more important. All right. So first we'll create a list. So list is a common SwiftUI container view that displays data in a single column. Unlike stacks, lists scroll vertically, so you don't need to worry about having more data than will fit on the screen. This makes lists ideal when you don't know the length of a data set or when the length can change. So length can change, dynamic content, we can see a pattern here. So let's get started. We're going to create a new iOS app in Xcode. So by now, I think we're pretty familiar with how to do it. So it's going to be called Pick a Pal. So I'm in Xcode. So creating an iOS app. I'm calling it Pick a Pal. Guess I keep SwiftUI and Swift, but let's just make sure. Yeah, they don't go over it, but we'll keep SwiftUI and Swift and uncheck include tests, because I don't think we're going to be writing tests. Okay, the project has been saved on my desktop and I have my boilerplate right here. I'm just gonna wait for the preview to start just so that I can make sure that it works correctly. If there is a problem, much better to solve it right at the beginning. And of course, the preview always takes a bit of time to launch the first time. All right, it's gonna come. It's just about being patient. All right, we have the preview working. So let's go back to the tutorial. So they say that we should replace the content of the VStack with a static list of names. And a list view adds other views to the content in its body, like separator between rows and visual elements, such as rounded corners and backgrounds. So it's very important what they're saying here, is that the list, it adds, and you can see it here, and you will see it again when I will paste the code. The list, it displays the text, so the 4 pieces of text here, but it also adds style to these text views, because it doesn't just display the text on top of each other like a VStack would. It adds this inset rounded rectangle, it adds this gray background, and it adds these gray separators. So interestingly, you can see that they make us put the list inside the VStack and not instead of the VStack. So that's on purpose. I guess they want to draw our attention to the fact that here the list is indeed inside the VStack, because we can see the padding of the VStack on the side. But I guess they will get to it, maybe to make it more explicit. So then, to be able to add and remove names using the app, start by removing your text views from the list. Then add a state property called names to store an array of string values. Add a few names to the array. So actually, we're taking these values right here and we are putting them into this array. And let me make it over several lines so that we can see how it looks like. All right. And they say an array can contain values of any type, but all the items in the array need to be the same type. That's absolutely true. Step 4, use a for each view to create a dynamic list. Type the code manually. For each has code completion options for many different uses. So I've said it before and I say it again. I will copy paste because it's much simpler for me and it avoids me losing time on just writing code. But if you're following along or doing the tutorial yourself, please take time to write it down yourself, because when you're learning the thing, when you're learning the material, writing it really helps memorize and appropriate, get familiar with the knowledge. So don't follow my example of copy and pasting like I'm doing right here. So you can see that we're putting a for each inside of the list. And maybe they will explain why we do this. So first, they talk about the for each. They say that for each, so the for each view uses a closure with a parameter to represent each value from the dataset you give it. You might read the syntax as the syntax name, as in a name value coming into the closure. So this is the closure, and the idea is that the for each view will call the closure for each value inside the array and will pass each value as the argument of the closure. So here the closure will be called 4 times, and the first time it will receive the string Elisha in the name argument, second time Andre, third time Yasmin, and third time Pochun. So that's the logic of iterating. And you can see that it's basically the equivalent of a for loop, but in the SwiftUI realm. And they say, click and drag in the preview to see how the list uses standard iOS scrolling behavior, even when it's shorter than the height of the screen. So indeed, if we scroll, we can see that the scroll does happen and it bounces, meaning that we can scroll past the end, past the border of the parent view. And as soon as we let go, it goes back into place. Okay, section 2, use a text field to enter names. So we're getting into the meat of the topic. So a text field view lets people enter text in a box. The text field modifies a string value in your app's state. When people tap return, you can use a closure to add the name they entered to the list. So step 1 will create a new state property to store the name that will be added to the list. So this new property right here. So name to add. So we can see this pattern of adding a property to store the data that is currently being created. We saw it before. Actually, I'm not sure if we saw it. No, I think we saw it actually just after this. The tutorial goes into how to use Swift data, but I've already covered this in a series of tutorials, and I think that's where I saw this pattern. It was in the Swift data part. So if you haven't seen this pattern before, it's normal. Forget what I just said. I don't think it's been covered in this section like of the tutorial, the one about getting started, but it comes in the next part about Swift data, which I've already covered. And if you want to check it out, it's available on my YouTube channel. So rather than explicitly declaring the properties type with name to add colon string, you can rely on type inference when you assign it a default value. Because so the empty string, so quote quote with nothing in between, is a string value, Swift infers the type of name to add to be string. So very important, this syntax doesn't mean that name to add doesn't have a type or that it's like any possible type. It does have a type, it's of type string. Simply, we don't have to spell it out, so we don't have to write it like this, because since the default value here is of type string, the compiler can infer this property to be also of type string. But a good way to see that it does indeed have a type is to alt-click on it. And when you alt-click, you can see that indeed it's of type string. So the type is defined. We just don't need to write it explicitly. but it's there. And if we try to set something else to the property later on, like an int, for instance, we would get a compilation error. Step 2, we create a text field beneath the list and pass it a binding to the name to add property. When someone types into the text field, it changes the value of name to add, and SwiftUI knows to update your view. SwiftUI knows to update the view because the view uses the property in the text field. So as I was saying, the text field is going to both read and write to this property, to the string. It reads it to know what to display, but then as soon as you type a new character, it writes the new character to the property, which in turn redraws the text field to display the updated string. So it's really this loop. It's the same loop that we've seen before on how the UI updates, but this time we see it happen in a way where it's the user typing with the keyboard that triggers the UI being updated. And here they explain what is a binding. So a binding is a way for you to give one view access to state that another view owns. That's very important. Earlier, when I started to say that a binding is a way to share ownership, it was a mistake because you're not really sharing ownership, you're giving access to state owned by a parent view. That's very important because there is the view that owns the data and there is the view that only has access to the data. And it's not the same thing, it's not the same responsibility. To create a binding to a state property, prefix the property name with $. And if it feels a bit magical, it kind of is. It's literally something that is hard-coded inside the compiler. When you prefix a property with @state or any other property wrapper for that matter with $, it calls something called the projected value, which is something that a property wrapper can implement. And so in the case of @state, it returns a binding. And I see a question which is it only because it's declared @state variable when is it only because it's @state variable being used as that property? What do you mean by is it only? I'm not sure what you mean. Do you mean like is it like why the UI is being refreshed? I'm not sure what you mean. Or is it because or do you mean because when we add the dollar you get a binding? Let me know which one it is, and then I will try to answer it. In the meantime, I'm going to add the text field to the code. So let me go back to Xcode. So I'm supposed to add it after the list, I think, after the list and still in the VStack. Okay. So yeah. So indeed, it's only going to update the UI because the property is marked as @state. Or rather, it's a bit more subtle than that, and I covered it in the previous chapter, but let me go over it again because it's very important. Um, Up until iOS 17, the way observation worked in SwiftUI was that whenever an @state property would be updated, then the body of the corresponding view would be recomputed. This meant that an @state property to change was a necessary and sufficient condition for the body to be recomputed. With iOS 17, if you use iOS 17's new observation mechanism, this changes a bit because for the body to be recomputed, not only do you need the property to be @state, but you also need the property to be used inside the body. This means that @state is now only a necessary condition, but it's not sufficient. For it to be sufficient, you also need to have the property be used in the body. This way, if a property is marked as @state but not used in the body, then the body will not be recomputed. And the idea is that at scale, it can have a benefit on performances. And if you're wondering why this was only introduced in iOS 17, it's because in iOS 17, when they built it, they had support for macros, and it's in a big part thanks to macros that this mechanism works. Because in order to be able to track in order to be able to track when a property is used, you need to have a mechanism that's going to add calls to some kind of register that indeed the property has been used by the body. And for this, you need to add extra code that will run at runtime. And thanks to a macro, it can be generated. This extra code can be generated like automatically. That's why it was only introduced with iOS 17 and not before, because before the Swift language couldn't support it. If you're new to Swift, this must have sound very complex and cryptic. Don't be scared by it. It's more of an advanced topic, what a macro is. But I still wanted to mention it so that if you want to learn more, you have the pointers to know in which direction to look. Okay, so now let's move up. So yeah, before macros, you will need to explicitly set up observers, and this would be a nightmare. And that's why SwiftUI, which has a goal of being simple and accessible, didn't go down that road. But yeah, what the macro does is that it sets up observers. It's the observer pattern that you might have learned from design patterns, or even if you use like a Java back in the days, Java had the observer pattern built in, so you might have also used it. And if you've used it, you probably know that it's a bit like cumbersome, and so you understand why they didn't make it work like that in SwiftUI until they were able to fully abstract this observation code away by generating it automatically. Because not only it is like not amazing to write this kind of code, but it's also very, very error prone. It's kind of like managing memory manually in a way. Like a lot of room to make errors, and errors that can be frustrating to understand, debug. So good thing that they waited until the compiler could write this dull but error prone code for us. Okay, then we're going to use the onSubmit modifier to add the entered name to the names array and reset the text field. Similar to a button, onSubmit uses a closure to run imperative code when someone taps return. So we can see that the text field has this behavior that is kind of similar to a button. The button, you would give it a closure, and it would be called when the button was pressed. Here, the text field, you need to give it a binding to a text because its main feature is to type text. But if you want to react to the return key being tapped, then you can pass a closure, and you do it through the modifier onSubmit. This also is a good opportunity for me to give once again an explanation of why some arguments are passed in the init and others are passed through modifiers, because you might be wondering, well, for the button I had to pass the closure through the init. Why is it not the case here? It's because for a button, the closure to be triggered when the button is tapped is part of the core feature of the button. Arguably, a button without a closure to call when the button is tapped has no purpose. So that's why it has to be provided in the init. Same thing for a text field. A text field with no binding to a string to read and write to um, makes no sense. That's why you pass this binding in the init. However, it makes total sense for a text field to not have any specific behavior for when the return key has been hit, because maybe you don't want to do anything in that case, and it makes total sense. That's why, since this is more of a secondary or an accessory use case, the closure is passed through a modifier. So remember, the bottom line is that arguments passed through the init are part of the core feature of the view, and without them, the view doesn't really make sense. And arguments that are more like optional to how the view behaves, yes, they are passed through modifiers. This way, it gives more flexibility, but it comes at the price that there is no guarantee that the modifier will be called. That's why inside the view, you need to deal with both code paths. Here, the text field probably needs to check whether or not a closure has been provided before calling it. So that's all for what I wanted to say. So let's copy and paste the closure. Before I just read this. So they say you use append to add a new value to an array. It's similar to the way you modify a view. So you can call append. You can also do plus equal. It also works, but under the hood, it also calls append. And here they say experiment, add more names to the list, try pressing return when the text field is empty to see what happens. So let's try it. I'm also going to reformat the code like that. Okay, so I'm going to add my name first, and then I hit enter, and you can see my name was added. And then if I just hit enter, you can see that it adds an empty string to the list. So maybe we want to add some business logic in order to prevent this from happening. So let's see. Yeah, that's what's happening. So add an if statement to prevent empty strings from being added to the list. The if statement checks the condition not name to add is empty, so the same as name to add is empty equal false. If name to add contains an empty string, is empty will be true. Since you want to execute code when the string is not empty, use the exclamation mark or the not, or also called the not operator, to negate the meaning. So it's the same thing as doing equal false. If you read this code, you can read this code as if name to add is not empty. So let's do that. So let's select the code right here. Let's open a curly brace. This way it's automatically encapsulated inside of it. And then it's if not name to add is empty. Personally, I find it sometimes nicer to write it like that, equal false. The reason why is because when you write it like this, the exclamation mark, it can be easy to miss. Especially imagine if this variable were to start with like an L, for instance, it can be very easy to miss it. So personally, I prefer the equal false because when you look at the code at a glance, it's easier to spot an equal false than a leading exclamation mark. But this thing is mostly a matter of preferences. There is no like best practice here. Everyone has kind of like their own preference. What's the next step? To see how your app works with the iOS keyboard, choose Product Run to run your app in the simulator. It may take a few seconds for the simulator to boot and launch the app. So let's actually start the simulator while I keep reading here. And they say you may need to choose IO keyboard toggle software keyboard in the simulator to see the keyboard when you activate the text field. Yes, because by default, it's going to map the keyboard to the physical keyboard on my MacBook Pro. So it's taking time to boot the app. It always takes a bit of time the first time. And yeah, now it's still using the physical keyboard. So I'm going to go into the menu IO. Sorry, it's outside of what you can see in the live stream. And I'm going to uncheck connect hardware keyboard. This way, now you can see that I get the keyboard of the iPhone. You can see that the text field was raised automatically. That's because the space available to the VStack was made smaller when the keyboard appeared. This might look like nothing, but in UIKit, there is nothing doing that for you in most cases. And so you have to deal with it manually. And it was always one of the pain points of using UIKit. And so now I can start writing, so using this keyboard. And if I hit enter, so it's in French, so it's in French, so it says retour, but it's return. And if I hit this key, you can see that the name is added and the text field has also dismissed the keyboard. That's the default behavior of the keyboard. I'm going to remove the stay on top for the simulator, otherwise it's gonna be amazing. Then they say something that's very interesting. But before I see a message in the chat, you're kidding me. You had to hard code for all the different screen sizes when the keyboard appears. Yeah, you had to do it. So actually, the way you would do it, at least the way I did last time, I had to do it, was you could listen to a notification that would tell you that the keyboard will appear or disappear, and you could get the height of the keyboard from that. But yes, in the very first iOS apps I worked on, the size of the keyboard was usually a constant in the project because it made things simpler. But then when the iPhone 5 was released, for instance, I think the size of the keyboard changed a bit, and so this code would break. So yeah, you had to listen to the keyboard appearing and disappearing, and then get the change in size from the notification you would get, and reduce like the size of your constraints accordingly. I think there were packages that were made in order to deal with this. I'm thinking I remember a package called like keyboard avoiding text field or keyboard avoiding layout. There were open source libraries that would deal with it, but yeah, UIKit didn't offer a built-in way to deal with avoiding the keyboard, which would make it quite hard to get started because like the first time I tried to write a very simple iOS app, so more than 10 years ago, I got stuck on this because like the keyboard would cover the text field and I was like, how do I do it? And it gets super complex and you don't really know how to do it when you're like getting started. So that was a big pain point that SwiftUI managed to solve rather efficiently, to be honest. Okay, so they were saying one thing here, which is quite insightful, which is that autocorrection doesn't always recognize names correctly. So it makes sense to disable it for the Pickupal app. Turn off autocorrection for the text field by using a modifier. So let me show you what they mean. So here, if I start to write my name, so I need to type it here, you can see that it tries to autocorrect it, but it gives so suggestions that don't make sense, but also it might want if I have like if I try to write this one like po dot dash rather chun, okay, it gets it. But let's imagine that it's a name like I don't know, I'm adding characters, but no, it doesn't try to autocorrect. But let's try to just write this. So you can see that here I wrote Chunny, and if I hit space, it autocorrected to chunky because chunky is a word that's in the English dictionary, whereas like first names they might not be in the dictionary, but that doesn't mean that they don't exist. Um, so having autocorrect for such a text field that allows user to enter a name is not great, and so that's why we want to disable it. So I'm going to do autocorrection disabled, and I'm going to apply this modifier to the text field like that. And if I relaunch in the simulator, now you can see that autocorrection is so it's still writing down the suggestions, interestingly enough, but you can see that if I hit space, it's not autocorrecting. So you can see that disabling autocorrection is not the same as disabling the suggestions here. They're still here, but it won't autocorrect to one of them when it deems that there is a mistake in what you've written. And so they say that this modifier, so autocorrection disabled, is one of the many modifiers that alter the behavior and appearance of the keyboard. And if you're following the tutorial in a replay, definitely here make a pause and try to see what others there are, because it's very interesting to see how all the way that you can customize a component like a text field, which is actually quite versatile, because you can imagine, for instance, that maybe there is a modifier to say what kind of data are you typing, because if you're typing a number, a phone number, maybe we want to show you a different keyboard than if you're typing any kind of text. So that's really worth exploring these modifiers. So step 7, they tell us that Xcode pauses the preview when you run an app in the simulator. To reactivate it, click the arrow at the top of the preview canvas. So right here. You can keep the simulator open while you continue to work in Xcode, and tip to hide the debug area that appears at the bottom of the project window when you run your app, choose View Debug Area, Hide Debug Area. Oh, that's interesting. So you can do it, but can you do it like always or not? No, it's like you need to re-hide it next time. Or I think you can also click on this button right here, which is like shorter when you don't know the keyboard shortcut by heart. All right. Then picking a random element from an array. So add a button below the text field that picks a random name from the list. You'll display the pick name in a text view at the top of the app using a ternary conditional operator. So let's see. Step 1, add a new property to track the picked name. And you can see that we are also initializing it to the empty string. Step 2, add a text view above the list to display the picked name, or if there's no pick name, a single space. So this is where we're using this ternary. So ternary is this syntax which says if this condition is true, then use this value. Otherwise, use this other value. So it's kind of like an if statement, but with a different syntax. It's an if else statement, but with a different syntax. And it's like an if else statement, except that the if and the else can only contain a single expression that is returned. So it's a simplified version of the if else statement. And here they say that by using a single space instead of an empty string, you ensure that the view always occupies vertical space on the screen. A text view takes up no space when it doesn't have any content, which causes other views on the screen to shift. So what we want is that even when there is no pick name to display, we still want the text to take the size it would take when there is a pick name to display. This way, when we display a pick name, the UI won't shift because the view has gone from being 0 height to being the actual height of a piece of text. Okay, so I need to add this above the list, like that. So we can see the empty space. And we can see that if we use, you can see that when you use, so actually the empty space is here above the list. I was pointing at the wrong place, not here above. And you can see that if I remove the white space and only give the empty string, then the text takes no occupies no space on the screen. You can see it because if I click on text, nothing appears. Unlike when I click on list, for instance, here nothing appears. But if I put the space back, then you can see that it's displayed here. And so we have the white space, but the white space also as a consequence, gives its height to the text. And you might remember from a previous video that this is called the intrinsic height of the text. And when the text has no string to display, its intrinsic height and width are above 0. But as soon as it has a text, then from the text, it can derive the intrinsic width and height. And it's just a function of the text and the font used to display the text. So what's next? They say look at the ternary conditional operators. Maybe they will explain what I've explained just before in your code. So it has three parts. First, a Boolean condition, followed by a space and a question mark. Next, the value to use when the condition is true, followed by a colon. Last, the value to use when the condition is false. Ternary conditional operators are a compact way to represent a view that changes based on an either or condition, since the logic is right there in the views modifiers, in the views or modifiers code. It's more concise than techniques like the compute properties in customized view with properties, which would have been to create a property that would do this computation under the hood, which are more readable but hide the logic. You can choose whichever style suits you. I would say choose whichever makes the code clearer. And actually, since the latest feature of Swift, I think I could also write it like that if I wanted. Let me try. I'm not sure if it's valid. I will need to do return like that. Okay, I tried doing it like that. If return, else return. But no, I mean, it doesn't work super well that way. And if I don't put, because you can write this in Swift now, it's valid. But since we are inside the body of a view, which is quite a special place in code, sorry, which is quite a special place in code because you can't use in the body you can't use all of the control flow statement that you can use in regular Swift code. For instance, you can't use a for loop. You have to use a for each. You can use an if, but you can only use it in special places, and that's why here you cannot use an if. Otherwise, what I wanted to show you was that today, thank you. Today in Swift, you can do something like it would be something like if bool dot random then 0 else 1, like this build successfully. This is valid. So you can use this syntax instead of a ternary if you prefer. I would argue that the ternary is more readable when it's so simple, but you cannot use this syntax here because you can't use if else inside the value that you pass to a view inside the body. Swift doesn't know how to handle it, but it's still possible in code that is not part of the body of a view. That's what I wanted to show you. Right. So next step. Now we add a button below the text field that picks this random element from the list. So the button code is there. So let's just copy and paste and then try to explain it. So what do we have? So in the closure that gets called when the button is tapped, if let random name equal names.random element, so a method to get a random element from an array, it returns an optional because the array could be empty. And so if there is a random name, then we set picked random name to it. Otherwise, we set picked random name to the empty string. And that can only happen when the array names is already empty. I see a question. So in line syntax with two sets of braces, is that like that still can have multiple statements per set of braces? Inline statements with two sets of braces like that still can have multiple statements. Um, I think I think you could. I think you could, but you would need to put a semicolon to explicitly separate the statements. But I think you can do it. I wouldn't recommend it because Swift doesn't require semicolons, and it's kind of a shame to bring them back. But as long as you provide Swift with a way to know where the first statement stops and the second one starts, and that's the goal of a semicolon, then you can do it. And you might see also the semicolon syntax when you do like a guard statement, and you want in the else of the guard, you want to do something before returning and still do it on one line. That's also a place where you can see a semicolon appear in Swift. But semicolons are extremely rare in Swift, and it's typically that's a typical use case when you want to put two statements on a single line of code. Okay, so they give a bit more explanation. So you use a random element with an array to get one of its elements at random. If the array is empty, you'll get the special value, Swift value nil, which indicates a non-value. The possibility of a non-value introduces a risk to your code. If let is a kind of if statement that lets you safely work with potentially nil values. So a nil value, it represents the absence of a value, and it's kind of the same than the concept of a null pointer that you can have in other languages. The difference is that Swift will force you to explicitly deal with the case where a value is nil. And if you want to force it by saying, no, I know that it's not nil, you can still do it. But of course, if it happens to be nil, then your app will crash at runtime. So in this case, if the condition is met, so the array return a random name, you can use random name in the first block of code, so right here. If the condition is not met, so if the array return nil, or rather the method or random element called on the array return nil, then the code in the else block runs. And so step 5, add a divider to visually separate the text field and the button. And it says that a list automatically uses dividers to separate items. Look at your list and notice the alignment between the start of the dividers and the start of the text. So let's put a divider. So it's between the text field and the button. So it's gonna go right here. So let's see. I need to resume the preview. You can see the divider. So it's quite small. I'm going to zoom in a bit so that you can see it on the live stream, but I need to be able to still be able to scroll. Okay, so you can see the divider like right here. It's the same than what's used here, except that as you can see here, the list, it aligns the left end of the divider, or rather the leading end of the divider, with the leading edge of the text, because it's more pleasing visually. But it's not a built-in behavior of divider, it's a behavior that is managed by the list. And you can see that when you use a divider, it just puts a list of a line of 1 pixel here horizontally. I'm not sure if you use a divider inside an HTAG, if it puts a line vertically. It would make sense, but I don't remember having tested it. So actually, I'm not sure whether it would do it or not. Okay. So now I guess it's gonna be about testing. Actually, we should be able to test. If I click on pick random name, you can see that indeed it does work and it displays the random name at the top of the list. All right. Section 4 is use a toggle to customize the behavior. So we're going to give people the option to remove names after they're picked. To implement this feature, add a toggle for people to choose between the two behaviors. Toggles represent an on-off state, much like the text field to your toggle will modify the state of your view, so you'll need to add a new addState property. We're going to add a new Boolean state property to keep track of the name removal feature. So let me add this new addState property like that. So should remove picked name. Above the button, add a toggle with a binding to the new Boolean property. So above the button, we add this toggle. So we can see it looks like this, remove when picked, something that we are, so this kind of UI component we are super familiar with in iOS. We see it all the time. A typical example is in the settings app to enable or disable plane mode or enable or disable Wi-Fi. It's very ubiquitous in inside iOS apps, and it's basically the equivalent of the checkbox that you can see on the web. It's equivalent in the iOS world. So toggles are similar to text fields. Both require a single binding. So a text field requires a binding to a string, and as you can imagine, a toggle requires a binding to a boolean. And they say just after, because the toggle controls an on-off state, its binding is a boolean. So if I make a few mistakes when reading, actually, I'm realizing that I'm quite tired, and the reason is that I came back from California 2 days ago. So when we are at the end of the day, that's when I can still feel the jet lag still being a bit present, and I can see it like whenever like I struggle to say some word or I just like misread something. It's I can feel that I'm starting to get a bit tired right now, because if you add 9 hours, like it's almost 9 p.m. in France, so it would have been what, like 4 a.m. in California. So you understand why my body like feels a bit tired. Okay, next step: modify your buttons functionality to remove the pick name from the list if the toggle is on. So yeah, you were surprised I was live. To be sure, I wasn't sure I would do it, but I came back on Friday. I came back Friday afternoon, and I managed to go to bed like at the normal time on Friday. So like yesterday and the day before I was still a bit tired, a bit like sick from the plane, like the famous like plane flu. But today is getting better. But it's at the end of the day that you can feel that you get tired. And yesterday it was even worse because I was watching like a movie in the Vision Pro that I brought back from the US. And since the Vision Pro is very like isolating, you can fall asleep within a Vision Pro. I can tell you that. Like you can fall asleep more easily than watching a TV. Actually, so that was quite an interesting experience, and a bit scary because imagine you fall asleep and like you just do something and then you break your Vision Pro. That would be like the most stupid way to break it. So it was also like a little bit like concerning, to be honest. Okay, so they say now modify your buttons functionality to remove the pick name from the list if the toggle is on. So it will pick a name at random and then remove it. So it will remove a name at random. And rather it will remove it and also display it at the top. So it will take a name out of the list and put it at the top, but remove it from the list. So let me add the code into the button. So the button is here. And so, okay, so it's in the if let, so it's in this part of the code. Let me also fix the indentation. So if should remove pick name, then names remove all name where name equal name. So it's a way to remove. So it's going to remove all of the instances of that name. So actually, if I enter the same name several times and it's picked only once, it will be removed at all the places, which makes sense. You could also say you only want to remove the first time, the first occurrence. It's a matter of what's your business logic here. Both can be implemented and both can be correct depending on what you want. So let's see. You can see that for now it just picks a name, but if I start to enable the toggle, then indeed names are being taken out, and that's it. The list is empty and it's over. What does it say here on the additional information? So you use removal to run code in a closure for each of the elements in the array. This closure represents the element with the name parameter and returns the bool value to indicate whether the element should be removed. The expression name equal pick name produces the bool value that you return. And tip, remember you can eliminate the return keyword for simple expressions. I scroll to another part of the yes, I scrolled when I did like I didn't do like I wanted to do comment tab and I did comment like at and it did something else. So yes, you can remove return. Actually, you can write it just like that, and it should still build and work correctly. Let's try it. Yeah, still works. So the reason is that inside a closure, when a closure only has a single expression, you can omit the return keyword. And now this is true for any function in Swift, but it used to be true only for closures before Swift 5. And here, I don't really like what they say because they say you can eliminate the return keyword for simple expressions. I don't like the fact that they say simple expressions because simple is not precise enough. It's actually when you have a single expression. So this is a single expression. But simple, simple, you oppose it to complex. But you can have a complex expression that is still a single one. You could have here an expression with several ands and or, it would still be a single expression, and so you could still omit the return keyword. So here, I don't agree that they said simple expression. It should be a single expression that they should say, according to me, because this single expression can be as complex as you want. So it's not the best way to describe this feature of the language. To be honest, I'm nitpicking a bit, but also since I'm reading a tutorial already made, it's kind of like my added value to try and add some extra commentary on it. Otherwise, I really feel like I'm just like reading, copy and pasting, and basically doing a voiceover for this tutorial. Section 5, we're going to use a custom button label. So we'll customize the button's label by using a new initializer that takes two closures, one for the action and one for the label. I'm not sure whether we did that in the previous chapter. I think we did. Yeah, we did it when we, for instance, when we put like the plus and minus text, I think. I think we did it, yeah, to use the to provide a custom label for the button. And if we did, remember that label when it comes to a button, it doesn't mean the text of the button, but it means whatever view makes up the body of the button. So label is really it's the same as saying the body of the button. It's not just text. It can be confusing because in many uh, languages and frameworks, label can mean only text. Typically, if you use UIKit, you might remember UI label, which is the equivalent of text in Swift UI. But in Swift UI, when you talk about a label for a button, it actually means whatever view makes up the body of the button. So step one, we're going to add a button style and font to make the button more prominent. So we add a button style, border prominent, and the font title 2. So to the button right here, like that. We can see it's now much bigger. Uh, in Swift UI, maybe I made a mistake somewhere and I said UIKit or Swift instead of Swift UI. I've probably said something wrong without realizing it. So thank you for correcting it. Um, so what's next? Change the button to use a custom label. So the button will still take a first closure for the action, but then it will also take a second closure that will be the label, which is whatever makes up the body of the button. And they say you can use this technique to make a button out of any view. So any view, you can wrap it inside a button and then the user can tap on it and it triggers an action. And this initializer for button has two closures, one for the action and one for the label. The action closure contains imperative code, so what must be executed when the button is tapped, and the label closure contains declarative view code. Oh, could a label be an image in SwiftUI? Yeah. So in SwiftUI, it's even more complex because in SwiftUI, let me tell you why I say that it's even more complex. I'm just going to copy and paste this thing right here. Uh, and I'm going to go over it because label, honestly, they've used this wording for too many things. So here I remove this part right here and I add the second closure. So label like that. So when label is used in that sense, so a closure argument that returns a view passed to another view, it can be anything. It can be a text, but it could be a VStack, a very complex VStack, a combination of VStack and HStack. It can be anything. It can be any arbitrary view. Actually, you can see it that here. So let me command click. You can see that it says that it returns that the closure returns a label, and you can see what is label. It's a generic type that conforms to protocol view. So it can be any kind of view. That's the first use of label. But as it turns out, SwiftUI also has a built-in view called label, which is a shortcut to have a title and an image set side by side. So when you use this label view, then it's to display a text and an image. So that's why when you say, could you add could a button label be an image? Yes. Here you can pass anything that you want, but you could also pass this label, which makes it very easy to have text and image together. But the important thing is that this label with a capital L doesn't mean the same thing than this label with a lowercase l. Here it can be any kind of view whatsoever, and here it's a shortcut to basically having an HTag with an image and the text. So this can be quite confusing when you're not used to it, and to be honest, probably a bit of a misnomer on the SwiftUI team's end. And yeah, and I think there might be even a third, I think there might even be a third meaning to label that I don't remember right now, but I know it's one of the. One day I want to do an article or a newsletter email about like the many meanings of label in SwiftUI because it can be confusing, and I think there is three of them. So I think there is one that I have forgotten. So if you can find it, feel free to mention it in the chat. But one day this will be an article on my website because it's good to know about it. And it's also good to know that this like label with a capital L does exist, because it's not that very well known, and it can be quite useful in some situations. But let's go back to the tutorial. And I see some people are joining in the chat. Welcome everyone. So then we add padding to give the label a little room. So we put some padding on the label and not on the button itself. The distinction is important, because if you were to put the padding on the button, then let me show you. If I put the padding on the button, seemingly it does the same thing. Actually, no, it didn't do the same thing. Maybe I should more do it like that. Yeah. Okay, no, it's because we have the button style, and the button style doesn't put like the blue in the padding. But you can see that if you put the padding on the button, it added the padding, but after the content of the button, after the label of the button. That's because the button style, it's applied to the label and not the button itself. So you really want to make sure that you put the padding on the label and not on the button itself. It's actually a very common mistake in SwiftUI, and I actually have a video coming just about this topic, coming in a few weeks, because it's a very easy mistake to make. And depending on how you write the code, you could have the button look the same in both situations, but here it's gonna work correctly. And if you tap on this extra area, it still taps the button. But with the other code, when the padding is applied on the button, if you were to tap on this area, the button wouldn't register the tap, so it can be very confusing for the user. Actually, yeah. So they were saying, okay. So they were saying exactly what I was showing. So because you added the padding to the text view in the closure, the button applies its style to the padded text label. An experiment, what I did, remove the padding inside the label and add it to the button, and add it before the button style modifier to see how the layout changes. And so when you do that, the padding is applied to the button and not its label. And most of the time, it's not what you want. Or rather, no, it could be what you want. But the thing is, if the padding is applied in the label, then the space occupied by the padding will be tappable. But if the label is applied to the button, then the space occupied by the padding will not be tappable by the user. So it really depends on whether or not you want that space to be interactive for the user. Section 6, improve your app design. So now that the app is functional, add your own colors and icons to make it unique, because this is not really good looking. This is a typical example of an app being designed by a developer rather than a designer. So first, add a title and an icon at the top of the view. So we add a VStack for that at the top of the view. So something like that. That's already a bit better. It gives it a bit of this of the Apple built-in iOS app already. Then apply the app's accent color to the icon. And for that, we use the tint value in foreground style to apply a custom tint color to the views. Okay, so something like that. So now we have the tint color, so the same color than that of the button. Then we're going to use hierarchical rendering mode for the icon. And so SF symbols have several different rendering mode. Hierarchical symbol rendering mode alters the opacity of the symbol's component. So let's see how it looks like, but I guess it will make the other ones maybe less opaque. So yeah, full opacity, and then maybe like 0.5 and 0.25. So that's kind of interesting. Like last time, I think we saw how you can also give a different color to each of the elements inside an SS symbol. Now we see that we can also give them different opacities, so it kind of shows you all of the power, once again, of SF symbols. which are quite a powerful feature of SwiftUI. Some people really call it the hidden gem of SwiftUI because SF Symbol makes it possible for you to design a good-looking app without having any designer resources and skills, and that's a great job at lowering the barrier of entry to creating a simple but functioning and visually appealing iOS app. Next, we're going to update the style of the picked name. So font, boldness, and foreground style. So it's going to be here. And for that, we need to pick a name to see it appear. All right. Then we apply a rounded rectangle clip shape to the list. And they say developers often make lists that occupy the full screen of an app, in which case rounded corners aren't necessary. You embedded this list in a VStack with other views, so rounding the corners is a nice design touch. So saying clip shape and rounded rectangle, because right now you can see that it's just a square and it really shows you that you have a list embedded into something and it's not the most visually appealing thing. But just by rounding the corners, actually makes it feel a little bit more natural. And once again, I'm going to give an example of the Vision Pro, but that's because I've been using it so much. The apps on the Vision Pro, they also have the rounded corners in order to make the window feel more natural when it's floating inside your vision. Interestingly, when you do the cinema mode on the Apple TV app, then you no longer have the rounded corners. But it's the only case. And it's because in that case, it tries to emulate something from the real world that we know doesn't have rounded corners, typically a cinema screen. Or if it does have, or rather, if it does have rounded corners in real life, it's so small that at the distance where you're at, it almost looks like there is no rounding. All right. And finally, customize the accent color of the app like you did in design and interface. If you want to match the project screenshot, use these values. So red, green, and blue. So let's see if I can remember how to do it. I think I can remember how to do it. So the way you would do it would be to go into the asset catalog, add a color. So let me call it, I don't know, I will call it like main color. Then I need to make room so that I don't cover it. So I want to have the same color, whether it's light or dark. And then how do I pick the color? So it's here. So here it's 0.345. Remember that I need to change the point by a comma because my computer is in French. 0.337. So here, 0.337 and 0.812. 0.812. Okay, so now I have my color. And if I remember correctly, the way I would go about using it would be to go on the content view. So like that. And then, so on the VStack to inject, so to do something like environment, I think it's tint, no, or accent. Or maybe it's just, maybe you just call the tint and then you say main. Okay, so that worked. Maybe that wasn't the way they showed us last time, but at least it did the job of setting the main color I've created into the tint color. And then since all of the views that are lower in the view hierarchy read this tint color, basically they read the value that I've overridden with this modifier right here. Okay. Step 7, use an empty array for the default value of names so your app is ready to be used by other people. So what do we do? So, oh yes, put an empty array so that people can start to like enter names and remove them as they go. Okay. All right, we finished. Let's do the last quiz of this tutorial. So like last time, check your understanding. 3 questions. First one, select the correct code for passing view state into a control. So first one here declares the asset property with a trailing dollar. Okay, I don't think that's the correct one. This one, no trailing dollar when declaring, but also no trailing dollar when passing a binding. And the third one, here, oh, there is also another one. Okay, they did all of the possibilities. But this one, no dollar when declaring the property, but a dollar when passing a binding on the property. And here, a dollar in each place. And of course, is this one the correct one? So the dollar, you use it on a property that is marked at state when you want to derive a binding from that property. So that's the correct one. And say indeed you use at state to represent the state of a view, then create a binding using the dollar sign. Next question. Select the ternary conditional operator that never results in a number greater than 100. So value greater than 100, value or 100. So something that does like some kind of like clamping. So basically the logic would be if value is greater than 100, then return 100, else return value. So this does the opposite. It returns the value if it's greater than 100. So this never returns a number less than 100. This one here seems pretty good. Oh no, because this one, no. This one, there is 2 columns. So this one here with this one with the correct syntax and the correct position. So if value is greater than 100, return 100, else return value. This one is incorrect. So if the value is greater than 100, the result is 100. The value after the question mark. Otherwise, the result is the original value. So it's a way also to implement a way to implement the max function between two values. That's how you would implement it under the hood. And last question, select the code that performs an action when people tap return in a text field. So we have the onSubmit modifier. Here we have passing a closure on the init of the text field and passing the closure through the onEnter modifier. So it's onSubmit. So we saw that this is not the correct syntax. It could be, but it doesn't really make sense because like you don't always need to provide a closure for what happens when you hit enter on a text field. So it makes sense that you provide it only when needed through a modifier, and the name is onSubmit, not onEnter. I'm not sure for the logic, but basically, I mean, the logic is that first, the return key has different name depending on countries. It's return in the US, but it's enter in French, or rather we call it entrée, but it's the same thing. And submit, I think it comes more from the web, I would say, because the idea of submitting a form is a wording that feels very much web-based. But I understand that they made that choice because submitting a form might not, I mean, what I want to say is that yes, when you hit the return key, you submit a form, but that might not be the only way to submit a form. Maybe you can submit it, for instance, programmatically by an action happening. Maybe you have a button somewhere that you can tap and it also submits. You have an OK button and it also submits, for instance. So I think that's why they use the word onSubmit, which is a bit more generic, but kind of makes sense because it encompasses the broader reality. And what we want to know, what we want to do is trigger disclosure when the text field is submitted, regardless of how it was submitted. It could be by hitting the return key. It could be because something else happened. All right, let's read the wrap up and then we will be done with this tutorial to get started with iOS. So the wrap up on lists and text field. So text entry and displaying a list of items are features of many apps, and virtually any app offers this kind of feature. When you combine these skills with managing a dynamic dataset, you can explore even more kind of apps. And a typical app that is actually a front for a set of web services for a front for an API. That's what it does. It displays data, it allows the user to enter data, and it sends data back to the web service. But many iOS apps are like this. And so what we've seen is a key part of the logic of an iOS app. So let's reflect on the concept that we've learned. Bindings and state work together. You use add_state to create private state for a view to modify in response to people's actions. And then you use bindings to hand direct control of a view state to its subview. So direct control is very important because it shows the fact that there is a direct link in the sense that the parent explicitly passed a binding on a specific property to the child, but also I would say direct and full control because the child view can do what it wants with the binding. It can set a new value. So it's important to understand that the state is shared with the subview. So you hand a direct and complete control over a view state to its subview. Technically, there are still ways to prevent giving complete control. You could create your own custom binding where you would add maybe some validation steps before you write the changes. But this is a more advanced use case. TextField uses all three types of state management we've learned because to set up a text field, you create a string state property in your view, so the first kind of state management. You pass the text field a binding to the property so it can modify the property as people type on the keyboard, so how to share state with a subview. And then through the unsubmit modifier, we can offer a closure to perform actions when someone taps return, so a way to react to an event happening. And that's indeed the three types of state management that we've learned. So what topics and skills have we covered? List views for unknown amounts of data, so what is also called handling dynamic content. Storing a variable set of data in an array. This one feels pretty, once you've understood how to store a single piece of data in an state property, storing an array in a state property is kind of like it comes in rather naturally, I would say. Using for each to create views corresponding to each element in an array. So using for each to iterate over a collection and then produce a view for each element in the collection. Text field for entering text. Bindings to share state across views and across parent and child views. And custom labels for buttons and label being any kind of view that you want. If you want to continue practicing, so first there are ways that you could extend the app we've just written. So one issue with the current design is that you can enter the same name multiple times. And when that name is selected at random, both are removed. Both or all instances rather are removed. Move the logic in onSubmit to guarantee that each new entry is unique. Hint, you can use contains with arrays in much the same way you use remove all. So you want to test whether the array already contains the name before you add it into the array. Now the question is, what do you do if it already contains the name? Do you simply not add it but still clear the UI? Do you not clear the UI? Do you show an error to the user? That's up to you. You can try and implement this. Other possibility, you can modify your app to strip leading and trailing white space from names as they are entered using the method trimming characters in. Look at character set to find the right kind of value to pass as the argument. Stripping white space helps ensure a clean dataset in your app. This is very important because typically, especially when you copy paste, it's so easy to have a trailing white space or leading white space, and then it's going to be saved as part of the string and it's going to mess up how your app looks like, potentially even mess up the logic of your app, and you don't want this to happen. And last one, add save list and load list button to let people reuse a list of name. Hint, you'll need a new state property. And we're talking about storing locally in the memory. We're not talking about storing in a way that gets persisted across so we are not talking about a storage that is persisted across the launch of the app. If you want to learn about that, it's the next part of the tutorial, the one about Swift data, and I've already covered it in a set of video. And the way they suggest to do it here, save and load, it's similar to how the memory feature on a calculator would work, for instance. Question, how do you control against removing interspaces like doctor dot space so and so? That's a good question. So trimming characters, I think trimming characters only apply to leading and trailing characters. When you say trim, it refers to like the beginning or the end, not in the middle. Please check, but I think that's the case. Because otherwise, as you're correct, it would be way too dangerous because any kind of white space would be removed. But trimming, I think I'm 99% sure that it's only for the beginning or the end. But that's a very good point that you make. And then for a more complex challenge, if you want to challenge yourself, formatting an address label. So start a new Excel project named address label. Use state properties and text fields to collect the different elements of an address, like city and country. Why not also name, street, zip code, phone number? Then display a complete formatted address at the top of the screen. Customize the font, sizing, and colors of the intake form and address. And for instance, for the zip code, try to display a numeric keypad instead of the regular keypad, which also allows you to enter digits, but it's less convenient than the numeric keypad. And if you want to learn more, so you can read about text fields and lists and tables in the Human Interface Guidelines. So it's about knowing how to display lists, tables, and text fields inside an iOS app so that it looks nice and that it looks at home on iOS. You can read about managing user interface state in the SwiftUI documentation for a good summary of view state management. So questions like when is the view updated in response to a change in data are probably answered in this part of the documentation. This app that we've implemented has only touched the surface of what's possible with lists. Complete the building lists and navigation tutorial to explore more complex data modeling, list rows, and navigation to a detailed screen from a list. This is part of the Swift data tutorial, which I've already covered, so you can already find it in my videos. Textfield has robust formatting tools, including a formatter specifically intended to help format names. You can find out more about formatting text by checking out the SwiftUI documentation on Textfield and Formatter. This could be very useful, as you were mentioning, if you want to format the name of a doctor, a name with a title. It could be either Mr., Mrs., it could be a doctor, professor, all of these kind of title. Having it be formatted nicely can be very useful, and apparently Textfield, along with Formatter, has a feature for that. And finally, you can continue exploring SwiftUI with Learning SwiftUI and check a Swift tour. So I don't know about these two things, so let me check. Oh yes, Learning SwiftUI, it's a great tutorial. Actually, I did it in a live stream in August 2022, so almost 2 years ago. So you can find it in my channel, but it's a really great tutorial and it covers some topics that we've already seen, but some others. So if you want to go further, it can be very interesting because you will be reusing some things we've covered. So it will be a good way for you to validate that you've understood them quite well, and you will also learn newer things about the subtleties of UIs in SwiftUI. So I recommend this one. And a Swift tour, it's more about getting a tour of the language. So I won't cover this one. Maybe I will cover it someday in a live stream. But it's a document that goes over all of the feature of the Swift programming language. All right, and what's next? Now that you have a foundation in Swift and SwiftUI, begin prototyping some of your own app ideas. Download the app design workbook to get started prototyping an app from research all the way to user testing. So it seems that Apple has published what seems to be a methodology to create apps. Okay, so actually it's a keynote slide deck. I'm opening it. I'm going to try and show it to you. Could be interesting. Okay, just need to make it a bit smaller so that it fits. Okay. So we have many apps, many slides, 126 to be exact, and seems to be like a full methodology over how you should go about when you want to design an app. So that's a very interesting resource. I didn't know that it existed, so I'm glad I've learned about it. Yeah, if you plan to create your own app, definitely read this. especially if you have no knowledge in software creation methodology. And even if you do, it's always good to see like the twist on the typical methodology that Apple has probably put inside this document. But that's a great read. I will try to read it at some point, maybe in the plane when I will be going to WWDC. Seems like the perfect read for a long plane trip. And so it goes all the way from research all the way to user testing. Okay. Sorry. And when you're ready, you can continue with the developing Swift tutorials to learn about data modeling. So the part about Swift data, which, as I've told you, I've already covered. All right. So I think we are done with this series of tutorial to learn the very basics of how to develop in iOS. Thank you. How to develop in iOS apps with Swift, SwiftUI, and Xcode when you're a complete beginner. So thank you if you've followed up until now, because it means that you've followed everything. I hope that you've enjoyed this tutorial. So this tutorial, when you say, was there any good food at Apple for you? What do you mean? Because last time when I went, I didn't go at Apple actually. I went for work, but I didn't go at Apple. But if the question is like, is there good food at Apple for people like me who cannot eat lactose? Last time I went WWDC in 2019, it was the case because basically you always have a vegan option, and the vegan option is fine for lactose intolerance. So I'm very lucky that, I mean, US companies, they are very good at asking for dietary restrictions, so that's not a problem. But since there is like vegan options almost everywhere these days, it makes things much more simple for me. So I'm always very happy about that. But I have a good memory of the food at WWDC. Like it wasn't like amazing, but I mean back then you had 6,000 people that had to grab food during a 1 hour or 1 hour and a half span. So you cannot bring like fancy food, but like it was like sandwiches and stuff. But it was very good, and honestly, like I've known way worse at such large events. So that was quite nice and quite efficient, because distributing food to 6,000 people is quite a logistical challenge. I can tell you that. Like I didn't saw it, but I was scared of thinking about the size of the waste disposal bins and the amount of waste that they had to get out of the event every day. But the size of the bins must be extremely scary to see, because 6,000 people produce a lot of waste during a single day. Okay, so outside of this topic that had nothing to do with the main topic, I was what was I saying? I was saying yes. So it's the end of this tutorial. Thank you so much if you followed up until now. This series was recording during live stream. So once again, a big thank you to the people that watched the live streams. I saw people come again and again every week. So it's super nice to see that. I hope that you've enjoyed it. Thanks so much for the questions that you've asked. And thank you so much for the remark also that you've made. It really helped, I think, elevate the quality of these videos, because I didn't only follow the tutorial, but also I was able to answer your question and your remark. And it's very likely that people watching will have the same question as they go about it. What I'm gonna try to do is that I have the recordings of all of the live streams. I think I will try to stitch them together into a very long video. As long as you're under 12 hours, you can do it on YouTube. So I think I will put everything into like a mega video and put that on YouTube rather than the individual live stream replays. Just because when you have 5 live streams, the last 2 ones or the last 3 ones, they don't perform well in terms of views, and so they are less discoverable. So maybe a very, very long video will be more discoverable. So I'm going straight. We'll see how it goes. Always good to experiment. And worst case, I will just like put back the individual replays. And I think I've said everything I wanted to say. I think now it's going to be time for me soon to go to bed, because starting to get tired. I'm still a bit jet lagged from the US, but I'm glad that I did this final chapter of this series of live stream. And next week, normally, we should start a new series of live stream. I have a pretty good idea about what we're going to do. I hope you're going to enjoy it. It's not going to be about following tutorials this time. It's going to be about something completely new. It's going to be about a clever approach to try and find inspiration from the code base of popular real-world iOS apps. So I'm quite excited to do this one next week. And I think on this little teasing, it's one I have to say thanks again for watching, and see you next time. Bye bye.